Hello friends, hope you're having a fantastic day today. This is going to be part 5 of our 50-hour long mega DSA course that contains every single thing related to technical interviews, data structures and algorithms. Now due to YouTube's restrictions, I can't upload full 50 hours in one video, so that's why I have to create them into 5 different parts, but needless to say, the knowledge is still there and you can just do them sequentially. The links for part 1 to 4 is in the description, so you can find it over there. And now without any delay, let's get started with part 5. So now we are going to solve maths for technical interviews. Now there is no point in giving introduction about maths. We all live with it. We all have studied it in school. And you can spend a lifetime learning math. So again, it's a huge topic, but we are focusing only from the perspective of technical interviews. Now in the technical interviews, usually we deal with basic level maths, nothing out of the blue, no such kind of like integration or differentiation related questions and something very hard. It's always going to be something basic, but you just need to have the mathematical temperament to understand that what is the core ideology and concept underlying the existing problem. So we will see 5 such examples of such kind of questions. And again, this is basic mathematics, nothing out of the blue. So you should be able to understand it. And I hope you find this section useful. The LeetCode problem we are going to solve now is called +1. We can see that this one is a LeetCode easy problem and also a very well-liked problem. Basically, we are given a large integer that is being represented in an array sense and represented as digits, where every single value inside the digit represents that particular position. So now we need to just simply add 1 to this given array and return the new value in the form of the array. So without reading all of this, let's just try to understand it normally. Let's say that we are given an input. Basically, originally we are supposed to be given value 9523, but this is given in the form of an array. Now we need to do +1, so basically this value would become 9524, and this we need to return as the array. So we are going to once again going to create an array and we are going to return 9524, and this is the answer that we will have to return. Same way, if these are the digits we are given, we are simply going to return 1002, but in the form of an array. Now the thing is, when we are dealing with any value that contains 9, then we will have to work about the carry because we are adding one value to it. So if this is the value, we know adding 1 would yield the value as 10000. So once again, this is also going to be the array that we are going to have to return. But now notice that because these are all 4 nines, this was a 4-digit character, but this became 5-digit answer. So we will have to return an array with 5 entries, and this is the only edge case where we'll have to do something. Now logically, if you are ever going to be presented with this question, you are simply going to use the most basic math of addition and subtraction. So you are going to take whatever the value that we are given, that let's say that we are given value 123, you are going to start traversing from right to left, and in this fashion first you will take the value. If this value is not 9, then we can simply just add one value to it and return the answer. So in this case, since this 3 is not 9, so we can make it as 4 and then return the array as it is. So we are only changing the one index value. Let's say that we are given a value something like 1, 2 and 9. Now in this case, we know that this is a value 9. The moment we identify that there is a 9, we are going to change this to 0, and we are going to have to add 1 to this particular value and keep on repeating the same process. So basically in this case, we would have considered this to become 0, and now for this remaining portion 1 and 2, we can once again repeat the same operation, that we will have to add one value to it. So in this case, for this 1 and 2, this is going to be added with one more value, and since this is not 9, so basically we are going to mark this value as 3 and then return the answer as it is. Now the only problem is, if we identify for some reason that all the given characters are 9, then in this case what is going to happen? First we will try to add 1 over here. So then basically this would become 0 because this was 9. So we will have a value like this, where currently this is 9, this is 9 and this is 0, but this 9 also has value 1 that we will have to carry over. After the same operation, once again this would become 0, this would become 0, and we would have one carryover above this 9. Once again in the next iteration, all of these three would have become 0. Sorry, all of these three would have become 0, and we would still have one more carry that we are going to add in a newly created value. So the simple algorithm that we can create is that we will start iterating starting from right to left. If we identify that value does not contain 9, we simply do +1 and return the array as it is. For some reason, if we find that the value does contain 9, we are simply going to mark that index position as 0, and once again repeat the same operation for the remainder of the array of adding value 1, and keep on repeating the same process. For some reason we end or we go through the entire array and we identify that we are at the end of the loop, then we simply need to create one more array that is going to be the size, one size greater than the previous digits array that we were given, and we are going to initialize first value as 1 and all the other values as 0 and return that as the answer. So this is the whole solution. Now this is not any data structure or any problem that we are using, so it is going to run in big of one constant time time complexity, sorry, constant space complexity. Now in terms of time complexity, this is going to be dependent on the total number of digits that are present, so this is still going to be big of n, but it's not that much. It's a very simple problem. And now let's quickly see the coding solution for this one. So the coding solution is quite straightforward. All we need to do is just iterate over all the digits from left to right, and we are going to have a for loop to do exactly that. And then we are going to check that if the given digit is less than 9, we can simply increment the digit and return the digits array as it is. If that is not the case, if it is 9, then we will have to turn it to 0 and repeat the same process for subsequent digits, moving from right to left fashion. Now, in case if all the digits were 9 that we find out, then we simply need to have a new array called new digits that is going to be one character longer or one array space longer than the original digits array that we were given, and we are going to mark that value as 1 because that is going to be the most significant bit, and all the other ones are going to be 0 by default, and then we can simply return the new digits array. So this is the whole solution. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully, beats 100% of all these solutions. That is because it's a very simple problem. The coding solution is present in our GitHub repository, so feel free to go ahead and check it out from there. Thank you. So the LeetCode problem we are going to solve now is called happy number. Now we can see that this one is an easy problem and also an extremely well-liked problem. The statement is quite straightforward. We need to write an algorithm to determine that if the given number n is a happy number or not, and we are given the conditions that how can we define a number to be happy. Now it is quite straightforward that starting with any positive integer n, we need to replace the given number by the sum of the squares of its digits. So let's say that we are given a digit like 16, right? If n is equal to 16. In this case, we need to replace n with the square of its digits. So current digits are 1 and 6. So we need to do 1 square plus 6 square. So this is going to become 37. And then once again, we will need to do the same thing for the 37 as well, where we would do 3 square plus 7 square. So this is going to be 9 plus 49. So I think it's 58. And yeah, so on and so forth. We would keep on repeating this. Now we need to repeat this until either the number equals 1, where it would stay as it is, or it would loop endlessly in a cycle which does not include 1. So either we need to keep on doing this process until this becomes 1, or until we find out that there is actually a cycle that is happening. And there are only two possibilities: either it could be a cycle or it could be 1. Now for those numbers in which process this ends in, which ends in 1, are defined happy, so we need to return true for them, and all the other ones we need to return false. Okay, so let's try to understand how we are going to solve this problem by an example. Suppose the given number n is equal to 19, right? So in this case the square is going to be 1 square plus 9 square, so basically 81 plus 1, so 82. Once again for 82, so it's going to be 64 plus 4, so 68. Now for 68, so total is going to be 100. Now for 100, it's going to be 1 square plus 0 square plus 0 square. So basically this is going to become the value as 1. So because we find value to be 1, we can define 19 to be a happy number, and in this case we can return true. Now let's take one more example. Suppose the given n is equal to 2. This is going to be the full sequence and this is the full math behind it. So you can notice that I have marked all the values defined as circles, and if you want you can just pause the video at this moment and notice the numbers. But overall notice that we start at 2 and at some point we end up at 2 as well, and if we keep going forward then next value would be 4 and so on and so forth. So we would be in an infinite loop. So in this case we can define the given number n is not a happy number, so we can return this as false. So this is the ask of the problem. Now let's try to see the solution. Now for this solution, brute force basically doesn't make that much sense because it's very quite straightforward. We only need to take care of that whether n yields in value 1 or if n yields in a cycle. Now we know whether if n yields in value 1 or not. That is quite straightforward and easy to understand. We can keep on we can have a method that basically get the square of the sum of given values, and basically for the given value we keep on repeating the process for given n, where let's say that if the n value is going to be 55, first we do a modulo by 10, so we get the last digit, that is going to be 5. Then we do it square and add it to the sum. Then once again we divide n by 5, so the remaining value is going to be 50 because this is going to be integer. And then once again we do it modulo by 10, so basically we would get value as 5, and then we will just do the square of it. So this is going to be the full logic on how we will proceed with getting the square of the sum. It's quite easy to implement and we would see that in the code. Now if we have to detect cycle, all we need to do is to keep track of all the n values that we have generated so far, and we will have to find a mechanism to quickly access that. So for every single new value of n that comes in, we would know that whether we have already visited this value or not. And for that, best way is to move forward by using a hash set. So the idea is that we would have a hash set that would keep store of all the different unique n values that we have found so far. And there can be two scenarios. Whenever a new value of n is being found out, either it could already be existed value of n, and which means we found a loop, so we can check that using hash set in big O of one time, or the given value of n could be 1. If either of this cases happen, then we simply get out of the loop and we return whatever the subsequent value of n we found. So that's quite straightforward. Now if we see time and space complexity, in this case time complexity is going to be big O of n because we are simply iterating over given input n once. Now space complexity is also going to be big O of n because we are using this additional hash set to calculate all the possible values of n. But overall this is a decent solution and a very easy problem. So now let's quickly see the coding solution in this case. So the coding solution is actually quite straightforward. First of all, we are going to initialize a variable called scene numbers, and this is going to be a hash set that we are going to be using to keep track of all the numbers we have visited to make sure are we in a cycle or not. Then we are simply going to have a while loop where we are checking that while the given n is not equal to 1 and the current number is not present in the hash set of scene numbers that we have seen. If that is the case, first of all we are going to add the new unique entry to the scene numbers hash set, and then we are going to have a helper method called get sum of squares and pass in the value n. Now let's understand this method, the helper method. This is simply going to return an integer value and we are checking that current sum is equal to 0. Now while the given n is greater than 0, we are going to start breaking the given value n based on digit by digit by doing a modulo of 10, and we are going to add the square of that particular digit. and add it to the existing sum, and then we are going to divide the current n by value 10. And notice, because n is integer, so all the fractional values would be eliminated and we are only dealing with raw integers. Now in the end we simply need to return the sum once we are getting out of the loop, and then based on this sum value we would populate our n and keep on repeating the process. Now the moment we get out of the loop, there can only be two conditions: either the given n is equal to 1, or we found a scenario where the number was already present in the scene numbers. So in either case we simply need to determine that whether if the n is equal to 1 we can return true, if n is not equal to 1 we can return false, and this would be our boolean response. So let's try to run our code. Seems like the solution is working beautifully. Let's submit this code, and our code beats a lot of other solutions, which is pretty good. Now we could do some work in terms of space complexity. Now because we are using an additional hash set, we are not the best in terms of space complexity, but there can be ways to improve upon them. Let me know in the comments if you want to see the improved solutions, and maybe I can put it in the GitHub repository. Meanwhile, this solution is present in our GitHub repository, so you can go ahead and check it out from there. Thank you. So the LeetCode problem we are going to solve now is called power of x to the power n. Now this one is a LeetCode medium problem and also a very well liked problem, but let's understand the problem statement. Basically we want to implement a power of x to the power of n kind of a function. That's it. This is the whole solution. So in the input we are given two values x and n, where x defines any integer. So let's say value is given 2, and n would define the power that we need to generate. So let's say given n is equal to 4. So in this case we will have to return 2 to the power 4. So this is basically going to mean that 2 multiplied by 2 multiplied by 2 multiplied by 2. So basically this turns out to be 16, and this is what we need to return. Now for different kinds of input, it could be possible that the given value of n could also be negative as well. So if the given value of n is negative, then simply let's say that we are given the value 2 to the power minus 4. So in this case we can still perform the same operation, but basically we are just doing 1 divided by 2 to the power 4. So this is going to be 1 divided by 16, and I don't know what is the decimal value, but something like 0.06 or something like that. So this is what we need to return. Okay, so let's try to see that what is the most simplest approach to solve this problem. We know that we are given a value of n. It could be positive or negative. Let's consider those scenarios later, but let's say that value of n is given 5 and we are given the value of x. So let's say x is given 2. We can simply run a for loop that while n is greater than 0, basically we would keep on reducing the value of n one by one and multiplying the value of x by whatever the initial value of x we are given. So let's say currently x is equal to 2. During the first iteration we are going to do 2 multiplied by 2, and the value of n is going to be 4, then 3, then 2, then 1, and so on and so forth. And in the end we can return this value as 32 as the answer. This solution would work as expected, no issues with this. Now what is going to be the time complexity? The time complexity is going to be big O of the total number of n that is currently present, and which is a fair enough time complexity. It's not that complicated. But the thing is, we want to make improvements to it, and we want to make this faster and better solution. That for any given value of x, let's say the value of x to the power n that we are trying to calculate, we can also write this value in x square, and then we do n divided by 2, because if we do LHS with RHS, then basically x would become x multiplied by 2 multiplied by n divided by 2. So this is also going to be x to the power n, right? But logically we can come up with this solution. Now notice that by squaring the x with itself, we are reducing the value of n by 2, and we can keep on repeating this operation every single time. So in that case the solution would run in big of logarithmic of n time complexity. Now let me give you an example on what I mean. Let's take our scenario where given x is equal to 2 and we're given n, the value of n is equal to 4. We know that 2 to the power 4 would become 16, but let's try to use my formula. So in this case, for 2 to the power 4, we can say that 2 square, and then we can also do like on top of it, here the value is 4, so 4 divided by 2, so this is going to be 2 as well. 4 divided by 2, I hope you understood. Now if we do that, we know 2 square is going to be 4, and this value is going to be 2, so basically this is going to be 16, and we can return this as the answer. Now notice in this case, all we had to do is just do this one iteration once. We did not have to do 2 multiplied by 2 multiplied by 2 multiplied by 2. So this is a much better solution, but of course it comes with an additional cost on itself. Now let's try to think that how we can take care of negative scenarios. So if the given value of n is going to be negative value, once again same method can apply, but in this case, if 2 to the power of negative 4, then we need to do 1 divided by 2 to the power 4. So in this case, we will do 1 divided by 2 to the power 2, and then on top of it, it's going to be 2. So once again, the same set of steps are going to be done. The only thing is, for negative value of n, we would change the value of given x to 1 divided by x. So I hope that also makes sense. Now there is another scenario that we did not consider, and that is that so far we consider this value of n to be an even value. So that's why doing like this operation of n divided by 2 was easy, like this operation. But what if this was an odd value? So if, let's say, for some reason we are given x to the power 5, so in this case we can also treat this as x multiplied by x to the power 4. So in this case, we would just first multiply it with the current value of x, and then we would have an even value of n, and then we would just simply return the same logic. So this is going to be x multiplied by x square and square of it. So yeah, that's the whole point. Now there is also one more last final edge case, and I know you all must be done with all the edge cases, but if the given value of n is equal to 0, then anything to the power 0 is always going to be 1. So this is the standard thing, so we can just directly create a case and return that if the given n is equal to 0, we can directly return value as 1. So let's do a quick recap. We are basically going to do x to the power of n as x square and n divided by 2. If the given value of n is odd, then we are going to do x multiplied by x square and n divided by 2. If the given value of n is negative, then we are going to first convert x is equal to 1 divided by x. That's it. So this is the whole solution. It works as expected. Time complexity, as mentioned, it's going to be big O of log n, which is exceptionally good. Space complexity, apart from storing a couple of variables, we are not storing much, so it's not going to be that expensive. And now let's see the coding solution. So the coding solution is going to be quite straightforward. First, we are going to handle the base case where if the given value is equal to 0, then anything to the power of 0 is going to be 1. So we can quickly return that. Now, if that is not the case, first thing we are going to do is to convert the given n, that is an int value, to the long value, and this is being done for some specific edge case scenarios, nothing more than that. Then we are going to check that if the given n is equal to negative, we will first have to convert n to positive, and we will also have to replace the value of x with 1 divided by x. So basically we are going to be treating n as positive every single time, no matter what the value has been given, but we will just update the value of the given x. Now we are going to create a variable called double result and current product, and this is to store the total results and the appropriate result that we need to return. Okay, now we are going to use our logarithmic function where for as long as n is greater than 0, we are going to check that what is going to be the modulo of n by 2. If the value is 1, which means the given n is an odd number, so we are just going to do result multiplied by current product once. So that way basically we are going to be taking care of treating n is equal to even numbers for the subsequent values. Then we are going to be multiplying the current product with the current product, so basically square the base and then divide the value of n by 2. So at every single step, we are making the value of n, turning it into half, and then doing the multiplication. So, and then in the end, we can simply return the result. So let's quickly try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. and our code beats 100% of all the other solutions, and that is because we are solving this problem in big O of log and time, which is exceptional, and we are also beating a lot of other solution in terms of memory, and that's because we are just doing things efficiently. So once again, the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you. The coding solution we are going to solve now is called multiply strings, and we can see that this one is a LeetCode medium problem and also a very well like problem. Now in this case we are given two integer nums1 and nums2, but they are represented as a string, and we need to return the product of num1 and num2, which also needs to be represented as a string. Now in this case we cannot use built-in library that converts string to integer and then just do the multiplication on its own. So we'll have to find a clever way to do it, and the logical way is very straightforward. Basically we are just going to apply the same technique we learned sometime in the grade 3rd or 4th. Let's say that if I tell you that I have this number 24 and 7 and I need to do multiplication of these two numbers, what is going to be the simplest logic? So in this case 4 multiplied by 27 is going to be 28, so I'm going to use 8, and the carry is going to be 2. Then once again 2 multiplied by 7 is going to be 14. 14 plus 2 is going to be 16, so I'm going to be storing this value, and this is the multiplication result. Let's try to up the ante and let's try to do 12 multiplied by 13, right? In this case we are going to do the multiplication in 2 steps, and first step is going to be multiplying this 3 with this 2 and 1, and then next step would be multiplying this 1 with this 1 and 2, and then storing the result. Now notice every single time we move one digit to the left we are going to add a 0, subsequent 0 as well. So let's do that. So this is going to be 6 and this is going to be 3. Okay, now we will have to multiply 1 with this 12, but actually we are multiplying 10, so we are going to be adding 1 0 over here, and then this is going to be 2 and this is going to be 1, and we are going to do the sum of these two values. So this is going to be this 156, and this is the result. So basically this is the whole idea of how we can multiply multiple digits, or like 2 digits that contains multiple digits. Number one thing is we need to start from the rightmost position. Now starting from the rightmost position we are going to take a digit like in nums1 or no nums2. Let's say that for nums2 we took one digit, that is going to be this 3. We are going to take this digit and multiply with every single value of this nums1. Okay, so we can do that. Next thing is we are going to store this value somewhere that where it needs to make appropriate sense, and this appropriate sense comes from two portions. First one is, number one, depending on the index position we can determine that where this value should stay. Now let's come back to our computer based solution. Number one thing is, if we are given two digits nums1 and nums2, we need to store them somewhere, and the logic we are going to apply is that we are going to storing them in an array. Now the maximum length of this array can only be the total length of the sums of digits n1 and n2. So we can generate an array like that, and I don't want to get into mathematical explanation on why that is the case, but that is the case, trust me on this. So let's say you generate an array that is going to be storing the result. Now after doing that we'll have to do the tedious operation of storing the result for every single value, but we don't need to do one by one. We'll need to figure out what is going to be the appropriate space where we can directly store the results. So let's say that this is going to be 3 multiplied by 2, so we know that we'll have to store 6 somewhere in this array, but where the 6 is going to lie, that is going to be some of the index positions of these two values. So let's say the index position over here is 0 1 2 and 3. Now the index position for this one is going to be 1, and the index position for this one is also going to be 1, so 1 plus 1 is going to be 2. So we need to store this value in I index plus j index plus 1, this value. So we store it over here, and if there were to be a carry, which is not in this case, well, let's say instead of this being 12, what if this value was 16? So in this case we would have stored 8 over here, and then there would have been a carry, and that carry would have been stored one step before that. So this is where we would take their carry in, and then once again repeat the same operation for this two values and find the appropriate index position to insert that value like this. So the multiplication is going to be stored at I plus j plus 1 location. I just explained why. And then carry is going to be stored at I plus jth location, because that is going to be one location lesser than the previous location. Now the question is how we are going to convert all of this string into numbers. So we cannot use directly parse int method, but we can do it at the character level. So at a character level, we can just subtract the value from 0, and then whatever subsequent values, we can actually convert that into integer. So I'll show you in the code on how it's done. So now let's see that what are the things we have. Number one, we have the way to convert nums1 and nums2 into integers. So let's say we would have values like this. Next thing is we are going to have a result array where we are going to be storing all the results of all the calculated values. And last thing is we are going to apply the common method of multiplying all the values, or like every digit by digit. So taking in one digit and multiplying with all the other digits, and once again repeating the same operation for all the remaining ones, taking care of the carry and storing them in the appropriate position inside the result array. And that we are going to be doing by doing I plus j plus 1 and I plus j for the carry. Okay, so I hope this explanation makes sense. Multiplication, it's quite straightforward. We are just going to do it the same way we have been doing since second grade, and that is to take care of all the values and then take care of the carry, and whatever the values we can store it in the answer. This solution would work perfectly well. And in the end, there is going to be one last thing that we need to do, because we have the result being stored inside an array. We will have to convert this array back to string, and which we can do it using string builder, or there are many inbuilt methods that can do it, and we are allowed to do it. And lastly, we need to convert it into toString and return that as the answer. So this is the whole solution. This would run in big O of m multiplied by n time complexity, where m is the total number of digits present in nums1 and n is the total number of digits present in n2, because we are multiplying all the digits with all the other digits. There is no faster way to do it apart from this, and it's acceptable because that is what the question demands. And in terms of space complexity, because we are using an additional array to store all the values, this is going to be big O of n plus m, where once again n is the total number of digits for n1 and m is the total number of digits for n2, nums2. And this is an acceptable solution. Now personally, if someone asks this question in an interview, I don't think like it's a very valid question to begin with, but it's a popular question, and sometimes interviewer like to throw some curve balls at you. So hopefully you can tackle them just as easily as I explained. But overall, now let's move on to the coding solution for this one. Now the coding solution is not the most straightforward one, even though the problem is very simple. So let's walk through the coding solution. First, we are going to check for an edge case that either num1 or num2 is equal to 0. We can simply return 0. If that is not the case, we are going to initialize our result array that is going to be of the combined length of num1 plus num2. And then we are going to iterate over every single I and j combinations. So we are going to use two for loops to iterate over all the numbers. Now notice that we are going in reverse. So we are going from rightmost position to the leftmost position. Now for every single character, we are going to multiply we are going to multiply digit by digit. And even though we cannot use directly parse int mechanism, we can still convert any particular string value to appropriate integer value by doing this operation at the character level. And then we are going to multiply both of these two digits. After that, important thing is to find appropriate position inside the result array to store that product. And we are also going to need to store the high value. That is where we are going to be calculating the carry. After that, we will add the multiplication result to the current position, and also handle if there exists any query any carry. and then we are going to set the current position to the remainder value of the result position low, and also divide it by 10 to find the high position value. So we can work with appropriate next values that are going to be coming in. Then we'll need to convert this array, result array, into a string, which is quite straightforward. We are just going to use the string builder function, and then we can check that if the return the product value, if that is equal to 0, we can simply return 0. If that is not the case, we'll just convert it to the toString and return whatever the value it is as it is. So let's try to run this code. Okay, seems like it's working as expected. Let's submit this code. And our code runs beautifully, beats most of the other solutions, which is very good. Also really good in terms of space complexity as well. So once again, the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So now we are going to do an awesome LeetCode problem called detect squares, and we can see that this one is a LeetCode medium problem, and also not very well like problem because it's like quite complicated to understand, but I really found this problem quite fascinating. So let's try to work on this. Basically, we are given a stream of points on an XY or two-dimensional plane, and we need to design an algorithm that basically does two things. First, it adds the new points that we are getting of stream of XY plane data structure in, like, basically storing them somewhere in a type of data structure, and duplicated endpoints are allowed, and they should be treated as different endpoints. So we'll have to keep track of the frequency of any particular endpoint at any given moment. Second thing is, given the query point, we might be needed to implement a method called counts, where we are given a point, xy point, where basically we need to determine that out of all the points that we have added so far, based on the given counts point, are we able to generate any squares? And if we can, we need to determine that what are the total number of squares we are able to make using that particular point and all the other previously points that we have received. So basically we need to implement a detect square class, and we need to have two methods in it. First one is add, that basically adds a point, and second one is count, that returns that how many number of squares that we have been able to generate. Now let's try to understand this with an example. Typically we would be given an input like this, where first we are initializing the detect square class, and then we are adding bunch of the values, and we are also at random instances asking for a count of total number of squares that we have been able to detect, and these are the endpoints that we are adding. So now let's try to see how it looks like visually. So basically in this example, first we initialize this detect squares, then we add three values. So those three values are 1 1 1 3 and 3 1. So they are over here 1 1 1 3 and 3 1, only these three values. Okay, and at the same time we also come up with a count mechanism, where we are trying to check that does there exist any square from this 3 1 endpoint. So basically from this particular endpoint, are we able to generate any squares? Now notice that at this moment in this method we only have these 3 points, so we are not able to generate a square at the moment. So we will return 0 for that count method, but subsequently we add one more point, that is this 3 3, and which is defined over here. And after that, once again we ask the same question of generating a count, and to which we can notice that now we are able to generate a square. And a square is simple, that every single edge should have the same length and they should be perpendicular to each other. So in this case, each of this has a length 2, and they are perpendicular to each other like x and y axis. So that's why this is a square that we can form using this 3 1 point. So in this case we would return 1 as the answer. And we could have a case where, let's say, Next value we are trying to add is once again 3 3, so we would have one more point over here, and then we are being asked to check that are we able to detect any squares using this 3 1 endpoint. So now in this case we can generate two squares. First square looks like this and second square looks like the other previous endpoints. So basically in this case we would have returned 2, but you get the point that what we are trying to generate. Now understanding this problem is actually quite complicated. How do logically we can make the solution work basically, and then we would try to understand that how can we tackle of implementing add method and how can we tackle implementing the count method in the most efficient manner. Now let's try to visually understand the solution approach. We are given these 4 points. We are trying to determine that how many squares we are able to generate using this 3 1 endpoint. Number one thing that we are going to do is to check that do we have any other points that are common with x endpoint values. So in this case we can find that there exists a value 3 3 that is different from this point, because we also have an endpoint called 3 1 that is currently plotted, but we cannot use the same endpoint in this case. So let's say that we want to find a value that has x but a different y. Okay, so we find a corresponding value 3 3. Now we know that these two are going to be in a straight line. Now if there were to exist another value that can generate a square, basically it has to be of the same edge length as this one, so it has to have the value 2 as the edge length of it. Okay, now we have one of the edges for the square. What would it allow us to generate the square? Number one thing is we can iterate over all the other remaining points and try to see that what are the different points we have and are we able to generate a square from that or not. But in this case we would have to take a look at all the different 3 remaining sides. That is going to be an expensive operation. Second approach we can do it is that based on these two endpoints we can determine that what are the endpoints we are going to need, because we already have the distance 2 in order to generate a square. And we know for a fact that if let's say that on an empty graph we only have the values 3 3 and 3 1, and we are being told that this is one of the side of your square, then other side of the square has to live somewhere over here or over here, where the distance has to be 2 in either case. And let me explain what I mean, because we can only generate a square like this or we can generate a square like this, because this is a common edge. This has to live there for sure, and we know that this distance has to be 2 and this distance also has to be 2 in order for a square to exist. So what are the potential endpoints? We know that this is 3 1 and this is 3 3. So if there has to be a square with value 2 possible, then that value is going to be, so this value would have become where we are adding the x coordinate to with value 2. So basically this would have become 5 and 3, and this would have become basically 5 and 1. If let's say we had this endpoint present, we could have generated a square, because notice that the difference would have been 2 on each side and this has to be 2 because of this. Or second option is that we could have on the other side, so that is going to be x minus 2 values for both of them, because y coordinate is going to remain constant because we are aligning our match based on the y coordinate. So this value would become basically 1 and 3, and this value would become 1 and 1. And we know that now we already had one side that was 3 3 and another side that was 3 1. Potential two values we found is either 5 3 and 5 1, or 1 3 and 1 1. So now the thing that we need to do is to check that amongst the added endpoints, do we have either these two entries or these two entries. It's not like if we have 1 3 and 5 3 it would work. No, it would not work. It has to be pair of 1 3 and 1 1, or pair of 5 3 and 5 1. And in this case we know from the input that we have a pair 1 3 and 1 1, and if we are able to find these endpoints, basically we are able to generate a square. So we can just update that value. And it could be possible that if we had this point, let's say 1 3 two times and 1 1 two times, then in this case we would have generated 2 multiplied by 2, so in total 4 squares. If we only had this like 2 times and this value maybe just once, so in this case we would have generated 2 multiplied by 1, because of the number of occurrences, only 2 squares. So we will have to keep track of the frequency of endpoint as well, in order to determine that what is going to be the fastest solution. So now let's come back to our original ask. We basically were given a data structure where sequentially we are adding the values. Now in order to add the values, what are the things that we need to take care or we need to understand? Number one, we need a quick way to look up whether any particular x value, x coordinate exists or not. And why are we considering? Same can be said for the y coordinate. I'm just taking x because it logically makes sense. Why? Because remember, in this case we were able to quickly identify this endpoint, and then we wanted to check corresponding values. So corresponding values would have been like 5 3 and 5 1, or 1 1 and 1 3. So in this case we were able to checking based on the x endpoints. That is number one thing. Second thing is, we also need to store appropriate y coordinate in accordance with the x coordinate, because there are pairs being present for x y pair. And third thing is, we need to know the frequency of any particular endpoint. So if let's say this 1 3 was present 2 times, I wanted to know this quickly. So what data structure comes to your mind in order to store this information that can fulfill all of this? Number one, if we are trying to store x and y, we could have used something like hash map. But in this case, apart from storing x and y, we also need to store the frequency as well. We can still use hash map, but this is going to be like a slightly complicated hash map, because number one, we are going to have a hash map where we need to have key value pairs. So we are going to have key and value combinations. As key, we would treat the x coordinate values. So let's say that currently first we had the value 1 1, we would have added 1 over here, and as its appropriate value, we are also going to store one more hash map, a mini hash map within hash map, and that too is going to run basically the same way. It is going to have a key vault pair of its own, where the key is going to be the y coordinate. So basically this is going to be value 1, and the value is going to be the frequency of y coordinates occurrence, because we already have the frequency of x coordinates occurrence. We only need to keep track that how many times the same y coordinate occur for the same x coordinate. So in this case, the frequency is also going to be 1 1, so we can store that information. Same way, next coordinate we are adding is going to be 1 3. So once again, the key 1 is going to remain common, but as part of its value, we are going to have one more entry inside this hash map, where now the value of y coordinate is going to be 3, and its frequency is going to be 1. Okay, then we are going to have one more entry where the x coordinate is going to be 3 1. So we are going to have one more entry 3, and as y coordinate, the value is going to be 1 and its frequency is going to be 1. Same way, we have one more value 3 3 in this case. So 3, we already have it as a key, as an input, so we would have stored over here the another value 3, that is the y coordinate, and its frequency as 1. So we are keeping track of frequency at every given instance, and for every single x coordinate we have the subsequent y coordinates and its frequencies. So it follows both of our desired needs. Now we know how to quickly add a value. If we see time complexity, in this case, this would have run in nearly big O of 1 time every time, because based on the x coordinate we would be able to quickly look up and we would be able to see that what are the corresponding y coordinates in also big O of 1 time, because we are using a hash map. In terms of time, like space complexity, this would become an big O of n solution. For every combination of x and y pairs, we would need to add new entries to the hash map. So we can generically just mention that this is going to be big O of n. Okay, this would be our solution for adding method, or to build this data structure. Okay, next portion of the problem is that how do we detect squares? Now notice that for the detect square method, Basically we need to generate that what is going to be the count of squares, and we are given an entry point, so an xy coordinate that we are already given. We can treat this xy coordinate as one of our x1 and y1 that we are trying to working with. So we are going to be dealing with an x1 value, and we can quickly check in our hash map that whether we have any other values for this x1 that is currently present within our detect square method. So let's say that we wanted to detect that for this value 3 1, how many number of squares exist. Okay, so in this case for this 3 1, we know that the x value is 3. So we will come to our hash map and we will see that for this 3, how many corresponding xy values we have. One value we have is going to be 3 and 1, and so this is one value that we currently have present, but because it's the same x and y, we cannot use this endpoint, so we will just ignore this. Next value we have is 3 3. So next value that is currently present is going to be 3 3, and that is pretty good that we can actually use this. So now we have one endpoint is 3 1, another endpoint is 3 3. So difference between y1 and y2 is going to be 2. Now because we have this value 2, all we need to do is to add 2 to the one side of x and add 2 to the other side of x. So basically we already have this one edge 3 1 and 3 3. So now we will need to determine that plus 2 on the x side, so that is going to be 5 1 and 5 3. Do we have this pair present? And second one is 1 1 and 1 3. Do we have like this combination present? And if either of this combination is present, which again we can quickly look up because we are storing all the information in a hash map, so we can quickly look up whether 5 is present as an input or whether 1 is present as an x coordinate, and if they are present, what are the corresponding y values. We can also take a look at the frequencies, and then we would basically just detect the squares and build the solution. So this is the whole solution. And if we try to understand the time complexity for basically count operation, this is slightly tricky but not that tricky, because we know that we can quickly look up the values of x coordinate for any particular entry in big O of one time. But for that x coordinate, there can be multiple y coordinates. So in the worst case scenario, we might have to iterate over all the possible y coordinates as well. Because imagine, let's say that instead of this being 1 1, what if we have all of these bunch of different endpoints, and even over here we have all of these bunch of different endpoints. For every single pair, we have to keep looking for the combinations of different x and y coordinates. So that would become a hassle. So the time complexity for this count method would be big O of m, where m is the total number of y coordinates present, because in the worst case we might have to iterate over all of them. So that's still relatively a good time and space complexity given how complex this question could have been. So we are trying to use the logic and power of math and some geometry to solve this problem and to not go through the brute force route. So I hope this solution made sense to you. Now let's quickly see the coding approach for this one. So the coding solution is going to be slightly complicated, but let's understand. So first we are initializing a private hash map that we are naming as points count, that we are going to be using to adding all the values. And notice that we have key as an integer and its subsequent value as another hash map. So there is a hash map within an hash map. Okay, then we are going to have a detect square method that is simply going to initialize the hash map, and then we are going to implement the add method. Now in the add method, it's quite straightforward that we are considering the value x as 0.0 and value y as 0.1. For every single x coordinate, we are initializing a new hash map if the x coordinate is not already present. And then for every single y coordinate, we are checking that if it is not present, we basically add the frequency as 1, or if it is present, we basically update the existing frequency. So if it is present like 2 times, we just add it to 3. Okay, now here comes the meat of our problem, that is the count method. Now in the count method, as an input, we are given an endpoint. So we are treating its x and y coordinates as x1 and y1. This would allow us to iterate over all the possible combinations. And we are initializing a variable called total squares that we have found so far as 0. Now the very first thing that we need to check is that does our hash map contains any other value that is on the same x coordinates as the given point x1 coordinate. If we don't have any values, we can directly return 0, that's it. But if we do have bunch of points on the x coordinate, then for each one of them we'll have to do the following, and that is that we would find that what are the subsequent y values. We will also try to see that what has been the frequency of that x y combination. We would check that if the y2 is equal to y1, which means we are at the same point that we are already given, we can ignore that. If that is not the case, we would find that what is going to be the edge length or side length by doing the subtraction of y2 minus y1, and this is going to be an absolute value, so it doesn't matter if it's like above x or below x. Overall we are only dealing with positive integer. Then we will have to check that what are the possible values that would allow us to generate basically a square, and then we would add it to the existing list of total squares. And for that we are using a helper method called count squares, where we are taking in x1 and y1 coordinates. We are also taking in x3 and y3 coordinates that we are trying to build, and we have the y2 and the count y2, so frequency of that coordinate. So after having all of this value in the helper method, we simply check that do we have the x3 coordinate that we were talking about and its subsequent y1 value. If we do, what has been the count frequency, and we simply multiply that to basically add the value to our total squares. And we do it for both like x1 plus side length and x1 minus side length. So this would give us both set of endpoints, and in the end we simply return total squares. Now I know the coding solution looks quite long, but if you just go and check it out our GitHub repository, you would find that this is an easier solution to understand once you know that what conceptual solution means. Let's try to run this code. Okay, seems like our solution is working beautifully. Let's submit this code. And our code beats 95% of all the other solutions, which is exceptional. And we beat 91% of all the other solutions in terms of time complexity, space complexity as well, which is also quite nice. So this is present in our GitHub repository. And I know that this solution says it's a medium solution, but in my opinion, this can be treated as a hard problem as well, because it's not quite straightforward to understand. The next topic in the sequence is going to be matrix, where we are going to do the full course on different matrix problems. Now, matrix is nothing but an extension of array. It's a two-dimensional array that can be used to represent anything. This video that you are seeing, an image or a grid or a graph or all sorts of different things. So we will solve some popular DSA problems, and again, introduction you all have seen in the topics like array, two-dimensional dynamic programming, some advanced graph problems, and all sorts of places. We can use matrix to represent basically graphs as well. So you must have seen some examples of that. And this is just to solidify your knowledge if you are specifically being asked on multi-dimensional array related problems. So without any delay, let's get started. Hello friends, we are soon employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do set matrix zeros problem, and this problem has been asked by some of my dream companies. So companies are like Microsoft, Amazon, Facebook, Apple, Bloomberg, Adobe, and also sometime in the past there have been Google and Goldman Sachs and eBay. They all have asked this problem, and that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and it is a very well liked problem. Basically we are given an m by n integer matrix, and we are told that at any point if we identify that there exists an element that is 0, then we need to set that entire row and entire column as 0. And we are also told that we need to do it in place. So let's see it with an example. So over here in the example, we are given a matrix like this, in the input, and we can see that this is the element that is 0. So because this element is 0, we will have to convert this whole row and this whole column to and set it up to zeros, and we need to return an answer like this one. Same goes with this second example, that we are given a matrix like this, where we are given 2 zeros at these 2 locations, and because there are 2 zeros, we will convert this entire row and this entire column to 0 because of this particular 0, and we will convert this entire row and again this entire column to 0 because of this particular node. So this row is common, so anyways we will just convert it to zeros, and this would be the final answer we need to return. So suppose this is the example that we are given, and let's see that what could be the most basic intuitive approach that comes to our mind. Well, first thing that comes to our mind is that we can actually start iterating over whatever this given input is, and the moment we encounter a value 0, we can just convert that column and that row where the 0 belongs to and set it up all to all the zeros. And let me show you that why it won't work. So first of all, we'll start iterating over here. We cross this node and this node. We don't find any zeros, so we are good so far. Now at this point, we identify that there exists a 0 over here, which means that for this particular column and this particular row, we will have to convert it to 0. So let's just do that. So if we do that, what we will basically do is we will remove all of these entries, and now we will convert these entries to zeros, which means that this is 0, this is 0, and this will all become 0. Now the problem will happen that after iterating this element, the moment we reach to this particular node, we will again have to convert all of these values to zeros as well. But remember that should not have been done. Why? Because originally the value over here was actually 1, which means that this particular row, this particular column does not need it to be converted to 0 because of this particular node. So that is the problem over here. Let's see that what could be the solution. So let me quickly draw back this to its original form. One thing we can do is we can actually create a copy of this one, and in that particular copy we can actually start making the change whenever we find a 0 in this particular matrix, so that we do not end up changing the elements before they are being visited. So let me quickly create a copy of this particular node. Okay, so now we have created a copy. Again, we'll start iterating over all these elements. We won't do anything over here. We identify that this is a 0 element. The moment we identify that this is a 0 element, we will actually make changes to this particular copied element. So now we will update the elements in this particular fashion. So all of these would be converted to 0. Now again we start iterating over this one. So this is 1, this is 1, so we are good. This is also 1, so we are good. Now this is again a 0. So because this is a 0, we will again update this row and this this column and this row in the copied node. So let me quickly make those updates, and this will be the solution. So in the end, we can actually return this copied solution where there is only one entry over here and all the other elements are 0. So this solution would work, but the issue is that we are actually using a big O of m cross n space over here. So let's try to see that can we do some improvement rather than using this additional space. Okay, so in the previous approach, we used a new matrix to keep track of all the elements where the rows and columns, the entire things needed to be done out to 0. But this is actually not necessary. Remember that at any point we identify that inside the given matrix, if there exists a 0, all we need to do is we need to convert that entire column and row, set it up to zeros, which will happen in both of these cases. So because at any point we identify a 0, the change applied to entire matrix for that particular row and column. Why do we use the entire additional matrix to store all the values? This is useless. And better approach is that we can actually create another set where we take care of all the row positions and all the column positions, and all we need to care is that at any point if we identify a 0 at any moment, we simply need to enter that entry in those particular row and column positions and then convert those row and column position to 0. Let me quickly show you how we are going to do this. So over here we will start iterating all the nodes, and we identify that these particular nodes, 1, 2 and 3, these nodes, they are not 0, so we are okay with this one. But this is a 0, so because we identify that there exists a 0 node, we will quickly note this position to this row and column entries. So we will add an entry over here called 0, and we will also add an entry over here called 0, right? We are good so far. Now again we will keep iterating over this given input in the similar fashion. So these two are also not 0 and this is also not 0, so we are good so far. Next we are going to do is that because this entry is 0, again we will record those positions inside this additional row and column set that we have created. And now this last entry is also not 0, which means we don't care about anything. And at the end, all we need to do is we need to iterate over this additional created sets and see that at whatever position we encounter the 0 value, for that particular row we will convert it to 0, and that particular column we will convert it to 0. So first of all we will visit this hash set of rows, and we identify that okay, first one is 0. So because first one is 0, all of these entries needed to be converted to 0, so we will convert these entries to 0. So we are good so far. Again we identify that second is also 0, so again we will repeat the same thing, and we will get rid of all of these ones and we will convert them to zeros as well. Now this last one is not 1, so we are good, and we will not touch this particular column. Now we will do the same thing for this one. So this is because this is 0, we will convert all of them to 0, so this becomes 0, and this one is also 0, so we will convert all of them, and this last cell also becomes 0. And in the end we can just simply return this newly created matrix. So this is a much bigger improvement than that in the previous one we were actually storing an additional entire matrix where the space complexity is big O of m cross n. So over here the space complexity is actually improved, and we are only using big O of m plus n. Why plus n? Because suppose the number of rows are m and number of columns are n, so we are still creating this two additional hash sets with those particular element values. The question is, can we actually do something better and even not using this m plus n space, and can we actually use the space complexity to be big O of 1? And yes, there is a solution that achieves this in big O of 1 as well. So let me quickly show you how. Okay, so previously we were actually using an additional data structure like this one to keep track of all the rows where we need to change the value to zeros. So over here, suppose we identify that there exists a 0 over here, we would update that value in this particular place, and later we would know that hey, we need to convert all these values to zeros. And we were also using another data structure to keep track of number of columns that needs to be converted to 0 in the same manner. That over here we identify that this is a 0, we will update an entry over here, and we will mark this point as 0, and later we would update all of these nodes to zeros. But rather than using this separate nodes, what we can do is we can get rid of them, and we can do the same thing by using this first row as an alternative for this original additional data structure. And also we can use this first column as an alternative for that original column data structure. And basically we will do the same concept, but we won't be using any extra space anywhere, and this is a wonderful approach. Now there will be one problem with this one, and the problem would be that over here we would be using this particular row to keep track of all the columns where the value needs to be converted to 0, and same way we will have to use this particular column to keep track of all the nodes where the rows needs to be updated. The problem is that this particular position is actually a point of conflict where there exist two intersecting nodes. So what we will do is, as a solution, we would actually create an additional node, and we will use these two nodes. So these three nodes would be working in combination, and for the first column we will need to do is just use this entire first row to keep track of all the columns that needs to be updated. And let me show you that how we are going to do the things. Okay, so First of all, we will iterate over this matrix and we identify that, okay, this value is 1, so we don't care. This value is also 1, so we don't care. Now this value is 0. So because this value is 0, we will have to make change to this particular row and this particular column. But this is at correct position, this 0 for this row. So we only have to update it over here. So we will add an entry 0 over here, right? Now next thing we will do is we will keep iterating over this matrix. So we'll we'll check these three values and all of them are 1, so we are good. This is also 1, so we are good. Now this value is 0. So because this value is 0, we will have to update over here and also over here. So we will do that. So we will convert this value and convert it to 0. We will also convert this value and change it to 0. And at the end we will just iterate over this element, and this element is already 1, so we don't have to do anything. Now this is the matrix we have. All we will have to do is we'll have to iterate over this and these 6 nodes, and at any position we identify the 0, we will convert that row or that column and change it to zeros. So first of all, we will start iterating over this first row, and this is 1, so we are good. But this is 0, so because this is 0, we will have to convert all of these to 0. So let's do that. So this value would be turned to 0, and we are good. Now again we come at this position, this is also 0, so all of these values needs to be converted to 0. So we will flip all of those values to zeros as well. Okay, now we are done iterating over this first row. Now we will iterate over this first column. So for the first column, we identify that, okay, this particular position is 0. So because this is 0, we will update the entire row as zeros. So let's do that. So we will get rid of this first value and we will change it to 0. Now we will iterate to this next node. So this is 1. So because this is 1, we will not touch this row, so we don't have to do anything. And because this is 0, so because this is 0, we will have to convert this entire row to zeros. But since these two nodes have already been converted to 0, we don't have to do anything, and this would be our final solution. So if we write the answer, we can actually write an answer like this one. This would be our final answer, and we can actually return this as the answer, and this solution works perfectly fine. Let's see the time and space complexity in this case. So the time complexity is actually going to be big O of m cross n. Why? Because we will have to iterate over this entire matrix, and that takes m cross n time. In terms of space complexity, we already know that we are only using this additional node. Apart from that, we are not using any additional space. So the space complexity is actually constant space, and this is the final solution. This solution is very good, and let's see the coding. First of all, we will create an additional variable, and we will create a boolean variable, and we will just name it as first column. We will initialize the value as false. And now we'll have to iterate over the matrix, so we'll need to know the length and height of the matrix. So let's initialize two variables to store the height of row and column of the matrix. Now we'll start iterating over the matrix, and we'll start updating the value inside the first row and first column. So we will check that if inside the given matrix for the first row, if there is any element where the value is actually 0, then we will convert that and we will update the value of the first call variable. Okay, once that is done, we will also have to iterate over all the columns. So we will create another loop inside the loop. And now we simply have to check that whether at any position we are encountering any value that is 0. If there is any value that is 0, we will have to update the corresponding I and jth position inside the first row and column subsequently. So once this loop ends, all the values should have been stored inside the first row and first column. So all we will have to do is iterate over the first row and first column, and we will update the subsequent rows and columns. So we will check that if at any position the corresponding value for the I and jth position, if that is 0 inside the first row, we will have to update the element of the this particular node inside the matrix to 0 as well. And once this loop ends, we would have taken care of all the elements inside the given matrix. But we notice that we are running this loop from I equal to 1 and j equal to 1, which means that we are not taking care of first row and first column. So we'll have to take care of first row and first column. Now remember, in order for us to take care of the first row, we will have to check the very first element, which is this particular element inside the given matrix. So we will do that. So we will check that if matrix at 0 0 position, if that is 0, we will have to update all the values inside the first row. And once that is done, we will also have to check for the first column. So for that, we actually have a variable first column, and if the first column variable, if that is true, then we will have to update the first column to 0. And after this ends, I think we should have taken care of all the nodes. So let's try to run this code. Okay, seems like a compilation error. Okay, seems like our solution is working. Let's try to submit this code. Our submission did not work for this one. Oh, we will have to start from j equal to 1 inside this first column. So let's try to run the code again. Let's try to submit it again. Okay, seems like our solution is working, and it's actually pretty efficient compared to a lot of other solutions. I would be posting this inside the comments so you can check it out from there. Also, I have created a repository inside the GitHub where I have posted the solution of all the Java problems that we have done so far inside the LeetCode. Okay, so this is the repository. You can go to any problem and you would be able to find the accepted Java solution for that particular problem, and I would be posting this link inside the description as well so you can check it out. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do spiral matrix lead code problem, and this problem has been asked by tons of my favorite companies. Companies like Microsoft, Amazon, Apple, Facebook, Google, Adobe, Uber, Bloomberg, TikTok, Walmart, Tesla, Paytm, Flipkart, ByteDance, eBay, Goldman Sachs, Robinhood, and Salesforce. So you can imagine that this problem has been really popular at top tier IT companies, and that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given an m cross n matrix, and we need to return all the elements inside the matrix in a spiral order. So suppose we are given matrix like this in a 3 by 3 matrix, we need to iterate over this given matrix in this following fashion in a spiral and return elements in that sequence. So to make things more understandable, I have drawn different matrix of different sizes, and let's see that what would be the spiral traversal for each one of them. So we will always start at the 0 0 position, and then we'll start traversing on the right side until we hit a boundary. So over here we hit a boundary, and then because we hit a boundary, we'll go downwards. Now again downwards we hit a boundary again. Again we will go in the left direction. Again we hit a boundary over here of the matrix. Now we'll again go upwards in the direction. But now this time we will not wait for us to hit a boundary. We will actually stop at this position number 4. Why? Because if we keep going in this upwards direction, we will end up at this position number 1, which is, though it is before the boundary, still this is the node that has already been visited, which means that we are traversing in a particular direction until the point where whether we hit a boundary or we hit a visited node. So this is a really important concept to understand. Now let's go back to the traversal. So again from this 4 we will come back at this point 5, and now from this 5 you can realize that there is no other direction this 5 can go to, and this would be the answer. So this would be the end of the traversal. Let's do the traversal for this 4 by 4 matrix. So again we start at this initial position, we start going on the right direction, then again we go downwards, again we go leftwards, then we go up until the point when we hit this visited node. Again we go right, again we go down, and again we go left, and this would be the traversal. For this 5 by 5, let me quickly show you what would be the traversal, and of course it's pretty simple to understand, so I know you also know that what would be the traversal. This is how we are traversing in all three of the cases. Now remember that there are two important things to consider over here. First thing is that at any point we are traversing, we are always following a pattern in terms of the number of directions or the type of direction we are taking, and that pattern is always we start at the initial position, which is this one, and then we always go on the right side first. After going the right direction, we go downwards, so we go downwards. After going downwards, we go leftwards, and after going leftwards again we go in the up direction, so we go upwards. Then again we go back on the rightwards, again we go down, and again we go left and right up, and we keep on following until we reach to a point where all the nodes that are adjacent to any particular node, so in this case this number 10, where all the other nodes they have already been visited. In this case it would be this node number 13, where all the other nodes they have already been visited. So we are traversing until the point where we exhaust out of all the nodes that we can traverse. And let's see that what would be the approach for us to solve this problem. Like we already know that what are the directions we need to traverse into, and we are always traversing in any particular direction until the point where either we hit a boundary or we hit a visited node, which means that these things are important for us to keep track of, that this boundary or this visited node, we need to understand that how to identify them, how to keep track of them, and what are the different approaches to tackle both of these, and what would be the solution. So in order to solve this problem, there are actually two different solutions. I'm showing you both of them. You can pick whatever you want to. Both have its pros and cons, and you can discuss it with your interviewer which solution you want to pick. So let's go with the first one. Now first approach is that we actually start shrinking the boundaries and we don't care about visited nodes. How we are going to do it, let me quickly show it to you. So first of all, we always start at this initial position. We know the directions we need to take. We go right, then we go down, then we go left, and then again we go up. This is the state of direction we are going to follow. Let me also create our answer of the nodes that we are going to traverse along. So first of all, we start at this position number 1, and then we follow up until this point where we hit a boundary over here. Now the moment we hit a boundary over here, we are going to add all of these values to our answer. So let me quickly add all the nodes to my answer. And then because we hit a boundary over here and this was the direction, right direction, we know that next direction we need to go is downwards. So we start going downwards, but we are going to do one thing important over here, and that thing we are going to do is we are going to ignore all of them, and we are going to actually shrink our boundary up until this point. So originally this matrix was actually 4 by 4 matrix. Now we are going to convert this matrix to be a 3 by 4 matrix, and we are going to ignore this first row as if that never actually bothered and that never actually existed. So by doing so, what we are doing is that we don't need to take care of these elements, and since we have already added them to our answer, so they are always going to be in our answer as well, right? Now again we go downwards in the same path until the point where we hit a boundary. So we hit a boundary over here. We are going to add all the nodes to our answer. So nodes would be 8, 12 and 16 in this sequence, and again we are going to ignore all of them because we have seen all of them, and now again we are going to shrink our boundary up until this point, and we are going to ignore all of these places. So let me actually remove them, that they never existed for us. Now again, after downwards we will start traversing on the left direction. So we go until this point, we will add all the entries in our answer, and again we are going to delete all of them because they never existed for us, and our boundary actually shrinks even further. And after that we start going in the upwards direction. But notice over here we don't have to care about these nodes because we have already shrunk our boundary to only consider up until this point, which means that we are going to add this values 9 and 5 and again shrink our boundary, and then we will add this value 6 and 7, again shrink our boundary, add value number 11 and then again shrink our boundary, and in the end we are only left with one value, value number 10, and we will add it to our answer, and this would be the answer that we need to return. So this solution works perfectly fine. We don't have to bother keeping track of the number of nodes visited because we are shrinking our boundary with every single iteration. And let's see that what are the pros and cons of this one. So first of all, we'll try to calculate that what is the time and space complexity for this one. So time complexity is actually going to be big O of m cross n. Why m cross n? Because we have to iterate all the nodes inside the given matrix. So that is a given thing. Now in terms of space complexity, we are actually doing it in a constant space complexity. Like you can't consider this answer to be a space complexity because anyways we have to return a list of all the nodes that we have traversed. So that is part of the answer, that is not part of our algorithm, and that is why this is a very good approach. And you can discuss with your interviewer that if he is okay with this approach, you can also move forward with this one. Let me show you what would be the second approach. So for the second approach, we are actually going to keep track of the visited cells and also the boundaries, and whichever we hit first, we are actually going to change our direction. So one thing remains common is that we are always going to traverse in the same sequence of direction. So first of all, we will traverse in the right direction, then we will go in the downwards path, then we will go in the leftwards path, and then we will go on the upwards path. So this will remain common, and then we keep on repeating, and at any moment we hit either a visited cell or we hit a boundary. So originally we are at this position number 1, and we are going to mark all the coordinates of the matrix. So the coordinates of the matrix is going to be 0 1 2 3 and 0 1 2 3. Now current position of this 1 is actually 0 0, we can see over here. So what we are going to do is we are going to create a hash set, and inside the hash set we are going to first of all check that whether the coordinate that we are visiting, have we visited it already or not. If we have not visited it, we will add an entry to our hash set. So at this position number 1, we will add an entry to our hash set saying that okay, currently we have already visited this coordinate number 0 0, and we are also going to create our answer list, and inside the answer list we are going to mention all the nodes that we have traversed, which we need to return in the end. So we will add this entry number 1, and then we will keep iterating on this direction on the right side until we hit either a boundary or a visited node. Remember, either a boundary or a visited node, both the things we are keeping track of. So and at the same time we are going to add all the entries. So in this case we would have added entries like 0 0 0 1 0 2 and 0 3. All the things we have added, we have already also added it to our answer that we have already traversed this nodes 1 2 3 and 4. And now we know that because we have hit a boundary, it is time for us to go in the downwards direction. So again we will go in the downwards direction until the point we hit a boundary, and we would have also added all the values to our hash set as well again, and also to our answer list as well. Like I am not going to bother writing all of them, but I can understand that you are smart enough to understand that. Again we go on the leftwards direction until the point we hit a boundary, and again we start going on the upwards direction. But notice that when we are going in the upwards direction, we are actually going up until this point number 5. We are adding all the values to our hash set, we are also adding all the values to our answer. Now at this 5, when we try to go this position number 1, we would first check that okay, whether this position number 1, which is located at the coordinate 0 0, have we visited it already or not. And we would identify that okay, the 0 0 has already been visited, which means that because it has been visited, we actually don't need to go and do that again. Or what we need to do is change our direction. So from this position number 5, again we would change our direction in the same manner where we would have changed our direction if we would have encountered any boundary. So then again we will add all those entries 6 and 7 and again add them to our hash set, and then we keep iterating until we reach to the end of all the entire matrix, and we would have visited all of them. Now this solution works perfectly fine. Now but the thing is, you would immediately say that hey, this solution actually we are using an additional hash set, which means that for the space complexity we are actually using big O of m cross n space complexity, which means how come this solution can be better. This is actually a bad solution. So your interviewer is definitely going to let you know that okay, you can't use this hash set to keep track of all the visited nodes. In this case, what we are going to do is there is another solution to solve this problem without keeping track of all of the visited number of nodes. So at any position, if we have visited some node, what we are going to do is we are going to add it to our answer list first, and then we are going to change its value. And how we are going to change its values? We are going to put something random that is out of bounds, or it doesn't even make sense. So over here, suppose we are at this position number 1, and then we start traversing this 1 2 3 4. So we have traversed 1 2 3 4, we have added it to our answer, and then at the same time, the moment we are done with traversing through any node, we are actually going to change its value to something, let's say minus 100, or let's say value number false, or something like that, right? Anything that is not part, that can never be a part of this matrix, and we need to replace our value with this one. So let's say in this case we replace our value with this minus 100, considering that this would not be a part of this matrix. Like, it can be, and then you can change this value, you can discuss it with your interviewer, and then again we start iterating in the same fashion. So again we would have added all the values to our answer list, and again we would have changed all of its values to whatever the value we decided, and we are going to keep repeating the same work up until this point. And notice that at this position number 5, when we try to go upwards, we are going to check that, okay, if the value of this particular cell, if that is not minus 100, then only we can say that, okay, this node has not been visited, and then only we will add it to our answer. But the moment we find out that, okay, this value is actually minus 100, which means we have already visited this node and added to our answer already. So now we have to change our direction in the same manner where we would have changed our direction if we had encountered any boundary, and then we would follow the same path and we would be able to solve this problem. So if we see the time and space complexity, in this case the time complexity is also going to be big O of m cross n, and the space complexity is actually going to be big O of 1 constant time space complexity. Now you would argue that the issue with this approach is that we are actually changing whatever the given input is, and that is not a bad practice, that is not a good practice in when you are actually doing inside the job. But when you are giving any competitive coding interview, your interviewer might expect you to do it. So it's always good to know a better approach. Let's move on to coding now. So first of all, we are going to create an integer called visited, and we are going to assign it some random value. So let's assign 101. Also, we are going to create two variables to keep track of the number of rows and number of columns we have. After that, we are going to have a couple of variables to keep track of the row position and column position we are at, and we are going to initialize it to value number 0. Now we have to iterate over our 4 directions. So we are going to create a 2D array. We are going to name it as directions, and we are going to iterate over all the 4 directions. So we are going to have 4 coordinates that would be used to go to any direction we want to. And we are going to maintain a sequence where the first would be to go to right, then next would be to go to down, then left, and then up. Now we need to keep track of what is the current direction we are at and when we need to change the direction. So we are going to initialize couple of variables called current direction and the change direction, and we are going to assign the value 0 to both of them. So we will have to create an array list to store the result. So we are going to initialize a list of integers to store the answer. Inside our answer, we are going to add the first node of our matrix, which is located at position 0 0. And after that, remember, every time we go through any value, we will have to update that value inside the matrix, because I am showing you the implementation for the second approach I showed in the explanation video. So we will update the value of this matrix node to this visited element that we already set up. Now we will start iterating over our given matrix, and we are going to have few conditions. So first thing is, we need to iterate over the given matrix. Also, we have to iterate over in a particular direction, and the moment we encounter a condition where we are either reaching a boundary or reaching a visited node, we will have to change the direction. So we are going to use current direction, change direction, and make conditions around them. So first of all, we are going to have a while loop, that while the change direction is actually going to be less than 2. And why less than 2? Because we have 4 directions, and at any point we can only go in one direction, and when we are the maximum amount of patterns we have is either we can go on right down or left up path, and that is what we are going to use. Once that is done, we will have another while loop that takes care of all the possible ways where we need to restrict our matrix. First four conditions would be to check that whether we are hitting a boundary, and the last condition is to check that whether we are hitting a visited node or not. If none of this is true, first of all we will have to reset the change direction to 0 because we are not breaking any direction. After that, we are going to update the value of row and column. Then we will add the current matrix row and column position to our answer array list, and then we will update that value for that particular row and column position to visited value. And after first loop ends, we will have to update the values of the current direction and change direction. So for the current direction, we are actually going to add a value, and then we are going to modulate it by 4. We will have to update the value of our change direction. And after both the loop ends, basically our answer array list should have all the elements, and we would have traversed the matrix, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working. Let's submit this code. And our code actually runs 100% faster than all the other solutions, which is pretty nice. Also, I have created a GitHub repository where I'm storing all the problems that I have solved so far, and you can go to any problem and you would be able to find the Java solution for that, and you can use it. It's quite helpful. And I would be posting this link in the solution as well, also this solution in the comments as well, so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do rotate image lead code problem, and this problem actually has very real practical applications, as we know that there are a bunch of different softwares that allows the option to rotate an image. And if we see the list of companies where I want to join in and already have asked this problem, there are companies like Facebook, Microsoft, Amazon, Apple, Google, Bloomberg, Uber, TikTok, Nvidia, eBay, Paytm, and Robinhood. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem, and basically we are given an n cross n 2D matrix which represents an image. Now we need to rotate this image by 90 degrees clockwise. Also, one more thing that is mentioned, that we need to do it in place. We do not need to use an additional 2D matrix to solve this problem. So the space complexity has to be constant in this case. Let's try to see it with an example. So over here we are given a matrix like 1 2 3 4 5 6 7 8 9, and we can see that this particular row is actually converted to this column, which means that all the nodes have been transported to 90 degrees, which means this 1 has gone to this place, this 2 has gone to this place, and this 3 has actually gone to this place. And same goes for all the other elements, that this 4 has actually gone to this place, which we can see over here, and this 7 has actually gone to this place, which we can see over here. And the same way it is shown in this second example. Okay, suppose this is the input matrix we are given, which means that this is the answer for the 90 degrees rotated matrix. Now notice couple of interesting things in both of them. Well, over here the value 1 2 3 is in a row. So over here this value 1 2 3 is actually in a column. Same goes over here, that this value 4 5 6 is in a row, but this 4 5 6 is in a column, and same goes for the 7 8 9 7 8 9. So this is clearly a pattern over here. And basically what we can do it is that if we somehow convert this input to replace all the values that are inside the rows to be inside the columns, and then reverse those entries, so reverse all the rows, we would actually get a 90 degree rotated array. And let me quickly show you how we are going to do it. Okay, so suppose this is the original input. I have drawn it much bigger over here. And now what we are going to do is, for every single row, we are going to place it inside the column, and every single column we are going to place it in the row, which means that currently at if we consider this position number 2, if we see the I and jth location, this 2 is actually located at the position 0, 1, representing these two values. So what we are going to do is, we are going to flip the values of the 0 and 1, and same we are going to do this for this 4, which means that this 4 will come to this place and this 2 will come to this place. The thing we did for this 2 and 4 we are going to repeat for all the other characters, and then we would have an array which would have where all the rows would have been converted to all the columns. Also, there is a name for the process of converting all the rows to all the columns, and that is actually called transposing a matrix. So first of all, we are going to transpose this original given input matrix, and we will see that the result would look something like this. So this 1 will remain at the same position because this 0, 0 is at the correct place, so we can't change anything. Now this 2 is going to be replaced by this 4, which means that over here we would have 2 and over here we would have 4. Again, this 3 is going to replace by this 7, so over here we would have 7 and over here we would have 3. So if we just notice right now, this row 1, 2, 3 has actually been converted to a column, and this column 1, 4, 7 has actually been converted to a row. We are going to repeat the same process now, and now this 5 will not have any impact because the position is actually 1, 1. But for the 6 and 8 we will actually have to swap their values, that now over here we would have the value number 8 and over here we would have value number 6, and this 9 will remain at the same position because the value is 2, 2, which means we can't do much about it. And now basically now we have created all the rows and converted them to different columns. Now the next idea is that we are going to put this in the reverse order, and if we reverse the rows for this transposed matrix, we can clearly see that we would get a 90-degree rotated answer. Let's do that. So over here the values would be 7, 4, 1. If we reverse this particular row, same thing we will do for this one. So the answer is going to be 8, 5, 2, and again for this one, the last row, the answer is going to be 9, 6, 3. And if we see, this is actually same as the answer we had achieved before, and I just draw all these 3 different matrices to give you an example that how we are going to do the things. But basically all of this activity can be done in place inside the single matrix. All we will have to do is we'll have to use a temporary variable to first of all swap the elements in this fashion, and then once that is done, we will need a temporary variable to replace the values inside the given matrix and reverse the rows. If we see the time and space complexity for this approach, basically for the time complexity, we will have to iterate over all the elements inside the given node to create this transpose matrix, and once the transpose matrix has been created, we will have to reverse all the elements, which means that the time complexity in this case is going to be big O of n cross n, but we will have to repeat this process 2 times. So which means we can say that big O of n cross n times 2, but in general we can just write it as big O of n cross n, and this would be our solution. In terms of space complexity, as mentioned earlier, we are not using any additional space, which means we are doing it in a constant space complexity, and this is a very good solution. Any interviewer would be really impressed with your approach, and this works for all the different n cross n matrix. Now let me quickly show you another solution for the same problem where we don't need to do like this transposing activity, and we can actually solve this problem in a single go. So for the second approach, we are going to do things a little bit differently. First of all, I have drawn over here a bunch of different matrix of different n size. So n is equal to 1, 2, 3 and 4 I have shown you. And now we are going to see that if we rotate them 90 degrees, can we see some patterns over here? So suppose we have a matrix of the size number 1. If we rotate this 90 degrees, it makes no sense. The value is going to still remain same. So we are going to keep it as 1. Now for this n is equal to 2, if we rotate this matrix by 90 degrees, actually the thing is going to happen is that this 1 node is going to shift 1 value to the right. This 2 node is also going to shift one value to the right. 4 and 3, all of them are going to shift 1 value to the right. And the answer in this case is going to be, okay, so first of all, we'll shift 1 over here, 1 value to the right, 2, and then 4 and then 3. So this is the 90 degrees rotated angle for this n is equal to 2. So basically what we have done is we have rotated all the values one place to the right, okay, for the outer layer. And in this case, since we only have 4 elements, which means the layer is only one, we are good. So when we get to this n is equal to 3, things becomes a little bit interesting. And interesting how? Because we have the cells located on the outer layer and we have one cell that is located in the inner layer. Now when n is equal to 1, when the number of cell that is located inside the inner layer, we know that the value is going to remain same. So even if we 90 degree rotate this particular element, it is still going to fall over here on the same place. We are not going to do anything special with this one. But for these other values, we will going to apply the same logic we applied over here, where because n was 2, we had to rotate all the values 1 degree to the right or one place to the right. In this case, because n is equal to 3, we are going to rotate all the values to the two elements to the right, okay, and this would be the answer. So if we see in this case, this 1 is going to come at this place, this 2 is going to come at this place, this 3 is going to come at this place, and same thing is going to keep on repeating for all the other elements. And that is how we are going to find its solution. So let me quickly draw the solution for this outer layer over here. This is the answer for the outer layer of this matrix. And because in the inner layer we only have one element, and for one element we don't have to do anything special, the 5 is going to be at the same place, and this is going to be the solution, that we rotated all the elements couple of places to the right. Now in this case, n is equal to 4. So obviously for the outer layer, you can imagine that the pattern we are going to follow is going to be the same, that we are going to rotate all the elements 3 steps to the right, okay, so that is clear. But for this inner layer, we can actually see that this time we have a set of 4 values, which means we have a 2 cross 2 matrix inside. So over here we are going to use the same logic we used over here, where we are going to rotate them one step on the right. So first let's do it for the outer layer, and then we will do it for the inner layer. So the rotation for this outer layer is completed. Now for this inner layer, we will have to rotate them 1 times based on whatever we have seen when n was 2. So we are going to do the same thing. This is the answer of 90 degree rotated angle, which means one thing we can see over here is that we can have 4 pointers starting at this 1, 4, 16 and 13, and rotate all these values in place by using a temporary variable. Once that is done, we can repeat the same process for this value number 2, 8, 15 and 9. And again, we will keep on rotating them sequentially at the same time in place. And then we would be able to fill out our outer layer. Once that is done, we will come inwards and we will start filling the inner layer based on whatever the number of n we have. And that is the approach we are going to take. Okay, so suppose we have a 3 by 3 matrix, and I'm going to show you what is the approach we are planning to take. Now this additional matrix I have drawn, that is only for the understanding purpose. Actually we are going to do everything in just one single matrix, but I'm just going to show you that what are the value changes happening and how we are going to use this temporary variable to fix our problem. So first of all, we are going to store the value of this 1 inside our temporary variables. Okay, so the value inside the temporary variable is 1. Now what we are going to do is, first of all, we are going to project this value number 7 to this place 1. So this becomes 7 and this becomes 7. Currently this is the scenario. Now we are going to project this value number 9 over here, which means that this 7 is going to be replaced by value number 9, and this is also 9 at this at the current moment. Again we are going to project this 3 to this 9, which means that the value of this 9 is going to be replaced by 3, and this is going to remain 3. And now at the final moment, we are going to take whatever the temporary variable we had, and we are going to put it in this place, which means that this value is going to be 1. So at a single iteration, we have actually shifted values of all of these 4 places in its correct position. Again, we are going to repeat the same procedure for these 4 values, which means that over here now we are in the next iteration. Now the value of the temporary variable is 2, Now because the value of the temporary variable is 2, first of all we are going to project this value number 4 to this place number 2, which means that currently both values are going to be 4 4. Then we will project this value 8 to this 4, which means that this is already 8 and this value becomes 8. Then we will project whatever value of 6 we had at this position number 8, which means that this value would become 6 and this is already 6. And at the end we are going to take whatever the temporary variable we had, we are going to project that value over here, which means that this 6 is going to be replaced by this value number 2. And once that is done, essentially in 2 iterations we have taken care of all the values that were placed out in the outer layer, and we are done with this one. Now only thing we need to consider is this inner layer, and because for the inner layer n is equal to 1, which means that we can basically leave the value as it is, and this is the answer. And this is how we are going to able to rotate the entire element in 90 degrees in just like very few iterations. We don't have to do like transpose matrix and then replace all the values and change all the values. So even if we see the time and space complexity, in this case the time complexity is going to be big O of n cross n, but we only have to do it single times, and space complexity is going to be big O of 1 because we are only using an additional temporary variable to store some values. Apart from that we are not using anything special to store any values. So we will initialize a variable called n, and we are going to store the length of the matrix for this one. Once we have that, we will have to iterate over this given matrix, and we are going to create 2 for loops to iterate over this given matrix. Now remember, we only have to iterate over half of the matrix. We don't have to do much work, which means that we are not going to iterate from int I is equal to 0 to I is equal to n. We are actually going to do it I is less than or equal to n plus 1 by 2. Now you will ask that why n plus 1 by 2? Because in the condition where the given n is odd number, we will have to take care of that scenario as well. So first of all, we are going to create a temporary variable, and we are going to store value of one of the elements inside this temp variable, and then we will start working on the flip operation for the remaining 3 elements. Once that is done, we will start iterating over all the elements. And once this loop ends, basically we would have rotated our matrix 90 degrees angle for all the elements. Now the question comes that how did I get this value of I and j? Actually I could explain it to you, but I would expect that you draw any 3x3 or 4x4 matrix on paper and try to see that how we are getting these values of I and j, because that would be a very good exercise for you. Anyways, I would be posting this code in the solution, so you would be able to check it out. But still I would expect that if you do it by yourself, you would never be able to forget it. Now let's try to run this code. Okay, seems like our code is working. Let's try to submit this code. And tada, our solution is actually 100% faster than a lot of other solutions, and basically we are solving this problem pretty efficiently. Again, I would be posting this in the comments so you can check it out from there, and there I would ask you to figure out that how we are getting these values of I and j compared to this value of n, and that would be a really good exercise for you to do at home.
Hello friends, I'm a cloud solutions architect at Microsoft, and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting LeetCode problem called valid Sudoku. Now, if we see some of the popular companies who have already asked this question, there are companies like Amazon, Apple, Nvidia, Uber, Microsoft, Facebook, Google, Bloomberg, DoorDash, Goldman Sachs, and Snapchat. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem and also very well-liked problem on LeetCode. In this problem, basically we are given a 9x9 Sudoku board, and we need to determine that whether this given Sudoku board, if that is valid or not. Now, we are told that only filled cells needs to be validated according to following rules, and we are given 3 rules to determine that whether the board is valid or not. First rule dictates that each row must contains the digits between 1 to 9 without repetition. This is the key phrase, that there should not be any duplication. First rule defines that every single row must have unique characters from 1 to 9. Second row defines that every single column must have unique characters between 1 to 9. The third definition shows that the box of 3 by 3 or the sub boxes in the grid must contains the digit 1 to 9 without repetition. So this is a little bit tricky one, but basically amongst the 9 by 9 box, we can make 9 different 3 by 3 boxes where the values 1 to 9 should be present without any repetition. Now we are told that the Sudoku board in this case is partially filled, and we need to only check the boards based on the filled items, nothing more than that. So it could be possible that we cannot be able to complete the entire Sudoku, but given the filled elements, if they are at least behaving these three definitions that are mentioned, where every single row, every single column and every single box, they all should have 1 to 9 unique elements, then we can determine that this Sudoku board is valid. If it is not the case, then we can determine that this is not valid. So if we take a look at this particular example, this is the example of a valid Sudoku box. And what makes this Sudoku box valid is that every single row, or all amongst all the 9 rows, the filled elements are filled in a manner that there is no repetition between 1 to 9. Now if we just take one example, say for example for this first particular row, if I add one more 5 over here, then it completely makes this Sudoku board invalid, because the elements 5 is repeated 2 times in this particular row. We are not concerned with the empty cells, because we can determine that can have any particular value, but if there is a 5 or any duplication present over here, we can determine this to be invalid. But let's just say that 5 is not present over here, so we are good. Same way, if I just put an 8 over here in this middle portion, then this column would be invalid, and that would make this entire Sudoku box invalid. So that is also one more thing that we need to take care of. And the third and little bit more complicated thing is the boxes that we need to be concerned with in this case. So there, as we can see from this image, there are actually 9 boxes present in any given Sudoku board, and we need to determine that 1 to 9 values are remain non-duplicated for all of them. So basically, say for an example, for this particular box, now this box currently only has one value 6, which means this box is valid because there is no duplication. But if I add one more 6 over here, which means then the 6 is repeated 2 times, so that would make it invalidated. So basically, we need to take care of rows, we need to take care of columns, and we need to take care of boxes for this particular problem to solve them. Basically, I'm going to show you 3 different solutions, one for the row, one for the column, one for the boxes, and then we will find a way to combine all 3 of them. So say for example, this is the row we are given, right? Now we are only considering one row for now, because same solution can be applied to all the remaining 9 rows. So that is a trivial fact. So basically, first we will try to determine, suppose this is the row we are given. What is our objective? Our objective is to make sure that all the filled values over here, they are unique between 1 to 9 and there is no repetition. So the simplest way to do is to create a hash set. So if I create a hash set, currently this hash set is empty. Maximum possible length this can have is going to be 9, because there are only 9 cells in any given row. Okay, now the logic we are going to use is that first we are going to iterate over the row. If the value, there is some value, we will try to first check that whether that value is present in the hash set or not. If it is not present, then we will add that particular value in the hash set and move on to the next element. If the value is already present, which means that there is a duplication we find, and then we can simply return false, that this given Sudoku board is invalid. So let's try to do that. First we are at position number 1. Currently there is nothing in the hash set, so because there is no value, we will add entry 1 over here, and we can determine that this node has been visited, or this cell has been visited for the row perspective, and there is nothing wrong we find. Now this one is a dot. So if there is a dot, or if there are no values, we can simply skip over that, because that is none of our concern. We are only concerned with the elements that are already filled. Now the next element is 3. So we will add an entry 3 over here, because 3 was already not present. This one is again empty. This one is value number 6. So we will add 6 over here, and then same way we will add 2 over here. And these 2 cells are not empty. So we have reached to the end of the row, which means we can determine that this particular row is currently valid and there are no issues with that. But say for an example, for this last cell, rather than adding this value, if we had one more value number 3 over here, then what would happen? Once at this position, when we add value number 2 over here, now we are over here, this one is a filled value. Because this is a filled value, we will try to see that whether this value is present in the hash set or not. Since this value is already present, this is a big no-no, and we found a duplicated entry, which means immediately we can call this entire Sudoku board invalid because we find an invalid row. So that is how we are going to determine the rows. Now currently this one only had one row, so we use just one single hash set. Say for an example, we were dealing with 9 different rows. If that was the case, what we would have to do is we would simply have to create 9 different hash sets, and basically for every single hash set we are going to repeat the same process. So this is just repeating the same process for different set of inputs. If the given Sudoku board is, let's say, 16 by 16, we would have had 16 hash sets, but still the core concept would remain same. Now the way we've solved for the box, the same way we can actually solve for the columns. Again, for the columns we are also going to create a hash set. So say for an example, this is the column, we will create the hash set and we will repeat the same logic. So currently this value number 1 is not present, we will add value number 1 over here. This 3 is not present, we will add 3, same way we will add 6, and we will add 2. And now we are at the end of this column and we didn't find any duplicated entries. So we can say that this particular column is valid, and then we can move on to the next column. And same way for the next column, we would create a new hash set. And if any point in time we find duplicated entries, so say for an example, for the second column we have two values 1 and 1 over here. First we would add this 1 over here, then the moment we move on to the next value and we see that, hey, in the hash set 1 is already present, we can say that, okay, this particular column is invalid, and that is why this entire Sudoku board is invalid. So this is also a very simple thing to understand. Same logic we are using, what we use for rows, we are going to use for the columns. The thing is for the box. Now for the box, this is a matrix kind of a structure, okay? And for the matrix kind of a structure, again, our main logic or the thing we need to achieve is going to remain the same, that we need to make sure that there are no duplicated entries for the filled values between 1 to 9. So again, even for the box, we would be able to create a simple matrix or a simple hash set. Now for this even hash set, we are going to apply the same logic, and we would keep adding the entries until we find any duplicate entries, and if we find duplicated entries, we will call it invalid. So this is a very simple thing to do, but the tricky part is, okay, now say for an example, we need to determine for rows and columns. Okay, currently say for an example, we are just ignoring the boxes for now. We are only considering that how to solve this problem for just row and columns, and we need to find that we don't find any duplication between 1 to 9 for every single row and every single column. How we are going to achieve that? We are going to achieve that in the same manner I explained earlier. The only logic we are going to use is that we are going to create 9 hash sets for rows. Okay, so for rows we are going to create 9 hash sets. Every single row we are going to check for the duplicated entries. If we find any duplication, we can return invalid immediately. If we don't find the duplication, we will move on to the next row, and we will keep on repeating the same process. The same thing we are going to use for the columns as well, that even for the columns we are going to create 9 hash sets. So again, and we are going to repeat the same process to check that whether there are any duplicated entries or not. And since there are none in this particular case, we can simply in the end return the answer valid. Now remember, we only solve this problem for the rows and columns, okay? But the thing is, we need to take care of the boxes as well. Now for the boxes, there is just one tricky part, and the tricky part is that actually for the boxes, it is not as simple as just the correlation between row and column. Because for rows, we had the particular separate entries for every single row that we can traverse over them or determine them pretty easily. Even for the columns, we have the direct way to identify that whether this is a column or not. But when it comes to the boxes, we need to establish a correlation between the set of different rows and different columns. And how would we be able to achieve that? Okay, so even for the boxes, basically we need to create 9 hash sets. But the thing is, how do we define which number goes where? So basically these are going to be all the boxes that we need to create, okay? And these are the 9 boxes. But the thing is, how do we able to define the 9 boxes? The answer is quite simple. We are actually going to do a division by 3 for any particular row value and any particular column value. So that would be a very clear indicator on what box we need to choose. And let me give you a quick demo. So basically the idea is that, okay, currently this row position is 0, 1 and 2. Okay, now say for example, if we do like 0 divided by 3, what is the value we are going to get? 0, of course. If we do like 1 divided by 3, what is the value we are going to do? We are actually going to consider the floor value, okay, not the ceiling value. So if we consider the floor value, 1 divided by 3 is going to be like 0.33. So basically in the integer it is going to be 0. So these three values are going to represent 0. Same way these three values are going to represent 0, which means if we are iterating over any of these cells, we can say that we need to consider box number 0 for that. So that is pretty good. Same way, if we are going over any other these three values, so okay, this is going to be 1, 1 and 1, because if we divide them by 3, and same way this is going to be 1, 1, 1, because if we divide them by 3, same way this is going to be 2, 2, 2, and same way this is going to be 2, 2, 2. Now say for example, we are at any cell amongst this particular box. Now we need to identify that which particular hash set to select. Now this one is going to be box number 6. So hash set number 6 we need to select, okay? But how do we define this hash set number 6 is going to be the correct one? And this is where we are going to use this formula, where for any particular cell position, we are going to do this formula where we are doing row divided by 3 plus we are doing 3 and plus we are doing column divided by 3. Okay, so this is the formula we are going to use to determine that what is the correct box number. Now suppose for this particular formula, suppose we are at this particular box or this particular cell. Okay, now if we take a look at this particular cell, currently the row is going to be row number 4. Okay, row is 4 and currently the column position is going to be 7. Let's apply this particular formula for this row and column position. If we do that, we are going to do 4 divided by 3 plus 3 plus 7 divided by 3. Okay, so in this case 4 divided by 3 is going to give us the answer number 1, plus 3 and plus 7 divided by 3 is going to give us the answer 2. If we do sum of these three values, we are going to get the value of 6, and the 6 is going to determine that the box currently, if we are at this particular position, we need to check it against hash set number 6. This is the only complicated matter for this particular question. If you are able to identify a way to find the correct box, then this is a very simple problem to solve, and which we just did. So this is the whole logic, and basically now we know that how we are going to solve for row plus column plus box. The idea is that for row we are going to use 9 hash sets, for column we are going to use 9 hash sets, and even for boxes we are going to use 9 hash sets. And we already know how to determine what is the correct box we need to look at, and based on that we simply need to check for the duplicated entries. If we find any duplication, we simply get rid of it. If we don't find any duplication, awesome, then we can conclude this given Sudoku to be valid, and this is the whole optimal solution. Now if we see time and space complexity for this one, the time complexity is actually obviously going to be big O of n square. And why n square? Because we are given n to be same for both rows and columns, so that is why this is going to be big O of n square. If we see space complexity, now this one is like a debatable question, because we already know that we are going to use 27 additional hash sets. The thing is, why did we come up with this number 9? Because we are given n is equal to 9 by 9 matrix, so we are given n is equal to 9, so that is why this 9 came in. So basically space complexity is going to be big O of 3n. So in general we can write this to be big O of n. But if we are explicitly told that we are only going to use 9 boxes, then we can also conclude this to be a finite number, and this could also be considered as constant. So if you do this discussion with your interviewer, you are going to look very clear in your concepts regarding time and space complexity. Since this is already pretty long video and the coding is just a bunch of repetition, so I am just going to explain you the code and then I'm going to paste this in the comments so you can check it out from there. So first of all, we are going to create an array of hash sets. So first we are going to create an array for row, second we are going to create for column, and third we are going to create for the boxes. And the size of this particular array is going to be the size of 9, that is given over here, and we are hard coding this value because we are basically told that this is going to be a 9x9 Sudoku. Now after filling these values, we simply need to initiate the hash set for every single one of them. So we are going to just iterate over all the values, and we are going to initiate the hash set to accept the character as the input. Now we are going to run two loops. First is to iterate over the row, and second one is to iterate over the column. And using the two inner loops, like one inside the other, we would be able to iterate over the given input matrix. Now the moment we are iterating over the given input matrix, first of all we are going to determine that what is the current character at any particular position or any particular cell. Now if the value is dot, or if there is no value, we can simply continue and move on to the next element. But if there is a value, we are simply going to first do these things. First we are going to check that whether for this particular row hash set, is this value already present. If the value is already present, we can simply return false. If that is not present, we are going to add the value to that particular row hash set. Same thing we are going to do for the column, that if the value is present, we are going to return false. If the value is not present, we are going to add that value to that particular subsequent columns hash set. And then we are going to apply our formula where we are going to check for the particular box, and then we are going to check that for that particular box, if the value is present, we are going to return false. If it is not present, we are going to return the subsequent correct value. And basically if we get out of the loop, we are simply going to return true, that we did not find any place where there was invalidity and we could have written false. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently fast compared to a lot of other solutions in terms of time complexity, and also it is very convenient in terms of space complexity. So I would be posting this solution in the comments so you can check it out from there. Also at the same time, if you want to check all the solutions that I have done so far, I have created a public GitHub repository where I'm putting all of my answer, and this is going to be a great resource for anyone who is trying to prepare for different tech interviews. So I would be pasting this link in the comments as well, so you can check it out from there. Thank you. Hello friends, I'm a cloud solutions architect at Microsoft, and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting LeetCode problem called Game of Life. Now, if we see some of the popular companies who have already asked this question, there are companies like Amazon, Bloomberg, Google, DoorDash, Microsoft, Snapchat, and Facebook. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also very well like problem on LeetCode. Basically, we need to find the next state in the game of life. Now, the question is, what is game of life? Originally, this has been created by a mathematician named John Horton, where we are given a board that is made of m cross n grid. So there can be like any 2D grid of m cross n cells. Now, the thing is, we are given the initial state of a cell, and the possibility is that any particular cell can be a live cell, so that is represented by value number 1, or it could be a dead cell that is represented by value number 0. Now the thing is, we are given the original cell in some formation, and then we need to find the next state of the cell using the rules that are provided by the game of life. So over here I am basically creating a table from these 4 given rules, and then we are going to use this table to see that what would be the next state in game of life and how would we be able to solve this problem. Okay, first one is, it's saying that any live cell with fewer than 2 live neighbors dies in the next state due to the underpopulation. Okay, so if the current state is live, so we just note this with value number 1. Okay, so if the current state is live and if the number of neighbors is less than 2, okay, so the number of neighbors is less than 2, then the next state is going to be 0, or the next state is going to be dead state. Now the next one is that if any live cell with 2 or 3 living neighbors will live on to the next generation. Okay, so if the current state is 1, if the number of neighbors is either 2 or 3, if that is the case, then the next state is going to be live for that particular cell. That is good. Now the next third one is that any live cell with more than 3 live neighbors would die due to overpopulation. So okay, if the current state is live and if the number of neighbors is greater than 3, if that is the case, then basically the cell is going to die and the next state is going to be 0. And the last one is that if any dead cell with exactly 3 living neighbors would become a live cell because of reproduction. So if the current state is going to be 0 and if the number of neighbors is exactly 3, then the next state is going to be 1 for that particular neighbor. These are the only 4 rules that we are concerned with for our game of life. And initially we would be given an example that looks something like this, where on an m cross n grid we are given some values that represents live and dead cells, and we need to find the next subsequent states based on these 4 rules. So this is the whole ask of the problem. Now let's try to see some examples. So if we see this first example, okay, let's see that what would happen with each cell. So currently the position of this cell is 0. Okay, this is a dead cell. Let's see, for dead cell, does it has 3 neighbors that are alive? No, that is not the case, which means this will remain dead. Okay, so this will remain dead. Now for this next particular cell, okay, currently this is live one. For the live cell, how many live neighbors this has? This only has 1 live neighbor, which means it is less than 2 live neighbor. So this would also be dead. So this is going to be dead. Also for this one, this is already dead, and again it will remain dead. And also this one will this one. Okay, so this is the important part. Now at this particular position, we do not need to see the positioning of the neighbor from this particular cell. We need to see the positioning of live neighbors from this original cell. So this is important for this problem. So even when we are at this position number 1 and we need to identify that how many number of live neighbors this has, we are going to refer over here, not on this newly created state, because all the states are going to change at the same time. Here I am showing you one by one, but in originality it's going to happen everything at the same time. Okay, so in this case, currently this one only has 1 live neighbor. So again, this one has less than 2 live neighbors. So since the number of live neighbors is less than 2, this is also going to become 0. Now let's try to solve for this next problem. Okay, in this next one, okay, this one looks very similar. So I'm going to add one more 1 over here. Now in this case, okay, currently this one is 0. Let's see that how many live neighbors this cell has. This cell currently has 3 live neighbors. Okay, if there are 3 live neighbors, which means that this 0 state has the possibility to become state number 1. So in the next state, this is going to become value number 1. Okay, and in the over here, now this one has 2 live neighbors, not 3 live neighbors. We are not considering this portion, we are only considering the original pattern. So currently this one has 2 live neighbors. If there are 2 live neighbors, it will remain 1. So this will remain 1. Same goes with this one. This has 2 live neighbors, so this will also remain 1. And same goes with the last cell, that the last cell also has 2 live neighbors, so this is also going to remain 1. And this is going to be the next state. Let's try a little bit trickier example. So in this case, let's see that what is going to be the answer. And this is going to be the next state. And this is the whole crux of the problem that we need to solve. Now understanding this problem is more trickier than actually solving this problem, because the solution for this problem is actually quite simple, and there are only like just few things we need to consider to make this more efficient. Okay, so now we have our example that we are going to use to solve this problem, and we have the number of rules that is already given in the problem statement. And now let's see that what is going to be the solution. Now suppose if we want to solve this problem, what are the things we are going to need? Well, first thing we are going to need is that for every single cell we are going to need the number of live neighbors. Okay, so we would be able to calculate that using just going over the grid, but in the problem we would be able to do it quite efficiently using just scanning through all the neighbors of any particular cell. So that is not a difficult task to do. Now let's see that what would be the solution. Now suppose we are at this particular position 1. Now how many number of live neighbors this has? This one currently has 2 live neighbors. Okay, if there are 2 live neighbors, this one is going to remain 1, so we don't need to do anything. Let's just keep this 1 as it is. Now for this particular one, this has 3 live neighbors. So again, we are going to use this rule. So this one is going to remain as it is. Now for this particular one, this also has 2 live neighbors. So we don't need to do anything. This one can remain as it is. So currently this upper row is going to remain as it is. Now for this particular 0, now this 0 is actually covered with all 3 ones, which means that this 0 needs to become a value number 1. Okay, so now this becomes value number 1. Now when we are at this position number 1, how many number of live neighbors does this particular one has? Well, okay, let's count. This one has 1, 2, 3 live neighbors. Okay, 4 live neighbors and also 5 live neighbors. The question is, can I call for this particular cell that it has 5 live neighbors? The answer is no. Why no? Because this particular one was originally a 0, and hence this should only have 4 live neighbors, not 5 live neighbors, because this cell I changed while I was iterating over. Now this is a problem that we have to worry about. And what is happening is that while we are iterating over the matrix, we are changing the state depending on these 4 rules, and it could be possible that the rules that are being changed could impact the remaining cells on their rules, and we might end up with a wrong answer. So one possible solution for that is that rather than making changes in place, if we just create a duplicated grid for this particular cell which contains the original items. So say for an example, suppose this was the original input we are given and we need to make changes. So what we are going to do is, first of all, we are going to create a duplicated entries and we are going to keep track of live neighbors. Okay, so let's just first quickly create a duplicated entry. If I create, okay, so now I have created a duplicated entry, and now whenever I have to make the change, I'm going to make change in this original box. But in order to find that how many number of live neighbors exist, I'm going to check on the box with the previous state. So this is going to be the copied version and this is going to be the original version. And after I'm done making change to all the original items, basically all I will have to do is just copy them over to the copied version, and then I would be able to calculate the next state of the original version. So that is how I'm solving the problem of state changing by creating a duplicated entry. Okay, and now this becomes very easy. How very easy? Okay, so we already iterated over this first row. The values are going to remain 1 1 1. That is common, that is good. Now we are at this current 0 position, so this one has 3 live neighbors, so definitely this is going to become 1. Okay, awesome. Now currently I am at this particular position 1, and the number of live neighbors is, it has 4 live neighbors. So because it has 4 live neighbors, it has greater than 3 live neighbors, this would become 0. So that this I can make change over here, that this would become 0. For this particular 0, how many live neighbors it has? It has 1, 2, 3 and 4 live neighbors. And now see over here, because I have this copied version, I was able to come up with the value number 4. If I was checking previously, I would have come up with the value number 3 and then I would have changed its state to 1. But actually, since this has 4 live neighbors, I would not need to do any changes to the state of this particular 0, and I can keep it as it is. Now I'm at this particular position 0. Okay, so for this 0, how many ones it has? It only has 1 neighbor, so I don't need to do anything. For this particular 0, how many neighbors it has? It currently has 2 neighbors, so I don't need to do anything. For this particular 1, how many neighbors it has? Currently it only has 1 live neighbor. Meanwhile over here it shows 0, but actually it has 1 live neighbor. So the number of live neighbors is less than 2, which means this state is going to be changed to value number 0. So let's see that from this particular original version we had, how many items got changed. Basically this got changed, so this became 0. This also got changed, so this was originally 0 and then it became 1, and this got changed. So this is how we would be able to solve the problem of game of life, just if we just create a copied version, and then it becomes very easy for us to find the live neighbors. Now the question is, your interviewer is directly going to jump onto you saying that if we see time and space complexity for this approach, the time complexity is going to be big of m cross n. Why? Because we need to iterate over the entire grid to calculate the result. That makes sense. But if we see space complexity, the space complexity is also going to be big of m cross n. Why? Because we are using this additional space to create a new copied matrix, and your interviewer is directly going to jump and saying that can you solve this problem with big O of one space complexity? Can you do that? Okay, now let's see that how can we solve this problem using the constant space. For that, we are going to do some few modifications. And what are the modifications we are going to do? Well, first we will have to understand that what are the items we need. For any particular cell, we need the information of number of live neighbors it has, okay? But we need this information on terms of like number of live neighbors in the original state. So now what would happen is that if we are at this particular position 0, this 0 would be changed to 1, and then when we come to this position, then we will try to find that how many number of live neighbors in the original state it had. Then we don't need to consider this particular value, so we need a way to somehow store its original state, and this can be done pretty easily. How? Basically, currently we are dealing with integer values over here. So rather than using zeros and 1, what we are going to do is we can also use -1 and value number 2. And what would this -1 and value number 2 would represent? Well, it would represent is that if, say for an example, if the current state is 1, okay, so currently it is alive. Okay, if the current state is 1 and somehow it becomes dead, then in that case, rather than this 1 would have been converted to 0, we are decreasing the value, but rather than putting this as 0, we can actually put this as -1. And what would that do is, okay, so that means that this -1 should be dead. This is like we are using it as a placeholder, but this -1 would also indicate that the original state for this particular cell was actually 1. So when we are counting the live neighbors it originally had in the previous state, we would be able to calculate. Same way, if we are in a position where a dead state comes to life, so dead becomes alive. If that happens, in that case from 0 to, rather than going to 1, we would directly go to position number 2. And that is also another way that whenever we identify value number 2, we would presume that originally that was not live in the previous state whenever we are calculating the next value. So if we need to do that, we need to make some changes to our rules. And what is the change we are making? The change we are making is that anyhow, if the current state is live and if the next state needs to be dead, in that particular case, this is where we are going to put -1. So because this becomes dead, we are going to put this as -1. For this particular case, 1, if there are 2 and 3 live neighbors, this is going to remain 1. So we don't need to do any changes over here. For this particular one, if the number of neighbors is greater than 3, which means that this 1 would die. So this would also become -1. And for this particular 0, if the number of neighbors is 3, so in that case, this would become alive. So we would change the value to 2. So these are few rules we are changing. And now let's see that how can we make the things work out in place without using any additional memory. Okay, so this particular row we are not changing because we are implementing this particular rule. Now we are at this position number 0, so this 0 needs to be needs to bring back to alive. So if this is coming back to alive, rather than making this alive with value number 1, we are actually going to mark this as value number 2. So this would also indicate that if the value is 2, then the original state was 0, and this is going to be very helpful. Now we are at this position number 1. How many number of live neighbors it has? Okay, so currently it has 1, 2, 3 and 4 live neighbors, not this one, because the value is 2, which means that the previous state was actually 0, so we are not considering that. So since this has 4 live neighbors, so greater than 3 live neighbors, this needs to die. If this die, we are going to use this as -1, so that is going to be helpful to us in the future. So this becomes -1, which would indicate that the original state was actually 1, and this is going to be helpful. Now we are at this position number 0. How many number of live neighbors it has? So it currently has 1, 2, 3 and also 4 live neighbors, not 3, 4 live neighbors, because this 1 used to, this -1 represents that this used to be originally 1. Okay, so this would remain 0. Now again, for this particular 0, how many number of live neighbors it has? So currently it has, okay, so this was originally 0 and this was originally 1, so this only had 1 live neighbor, which means this would remain 0. Same goes for this one. This particular 0 has okay one live neighbor and also two live neighbors. So if there are two live neighbors, we don't need to do anything. And for this particular one, how many number of live neighbors it has? It only has one live neighbor, which was this value number -1. So this is going to turn out to value number 0. But rather than turning to value number 0, we are going to turn it to -1. And this is going to be the next state. Now, once we get this next state, this is not the answer we need to return, because for our game of life, we need to return all the cells in either 0 or 1. Either they are dead or they are alive, nothing more than that. So in that particular case, what we can do is, if at any point we identify the value to be like positive, so in this case this 2, so this needs to be converted to value number 1, because this indicates that this one is alive. And if we find 0 or negative value, which means that that one is dead, so in that case we will make these changes. So these two are going to become zeros, and this one is going to become 1, and this is going to be the next state, and this is the whole solution. See how beautifully we are able to change everything by just simply making few changes to the input rules. And now if we see time and space complexity, in this case the time complexity is actually going to be big O of m cross n, because that is the grid size we will have to traverse. And if we see space complexity, the space complexity is going to be big O of 1, because apart from using like few variables, we are not using any additional space, and this is a very beautiful solution. Okay, so since this is already a pretty long video, I'm just going to explain you the code, and then I would post this code in the solution, so you would be able to check it out from there. Now, if we see, okay, initially we are initializing an array called neighbors, where we are adding the value 0, 1, -1, and this is going to help us navigate through neighbors of any particular cell. At the same time, we are getting the values of the row length and column length. So these are the values of m and n inside our grid. Now, first of all, we are creating two for loops, one inside the other, where this would allow us to iterate over the given input matrix cell by cell. After that, we are originally initializing a value of integer live neighbors, because this is the most important thing we need to consider, that how many live neighbors any particular cell has. And this is exactly what we are going to do next. We are going to run two loops, but this is going to be a finite number of cases we need to do. So this is not going to add any additional time complexity to our problem, but this is going to allow us to iterate over our neighbor. We are using this condition so we do not go out of bounds. And then at any given position, if we find that any particular neighboring cell has value number 1, then we are going to increment the number of live neighbors for that particular I and j positions. So this, okay, so this part gives us the number of live neighbors. That is pretty awesome. After that, now we are going to implement our 4 rules that we have established. And for these 4 rules, remember, first of all, we are going to check that if the given cell value is, if that is dead or alive. If the given cell is alive, then we are going to check that whether it has the number of live neighbors less than 2 or greater than 3. If that is the case, then the cell needs to die. And if the cell dies, we are going to change the value from 1 to -1. And if that is not the case, we will check that if the given cell is actually dead. If that is the case, which means we are going to check that if the number of live neighbors is exactly 3. If that is the case, which means the dead cell needs to be alive, and then we need to change its value from 0 to 2. So basically, this particular for loop is going to allow us to get all the values of the board setup with all the cells positions changed from either 0 to 2 or from 1 to -1. After getting that, all we need to do is just iterate over the given matrix again, and then simply check that if at any point we identify the value is going to be greater than 0, or the value is going to be either 1 or 2, which means we will need to convert that value back to 1, or else all the remaining values are going to be 0. And this is the whole solution. Pretty sweet and efficient, both in terms of time complexity and also in terms of space complexity. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which is pretty great. And I will be posting the solution in the comments, so you would be able to check it out from there. Also, there is one more place if you want to check all the coded solutions for many of the LeetCode problems that I have solved. And this is the GitHub repository that I have made public, that I will be posting this link in the description and also in the comments, so you can check it out from there. Let me know what do you think about this problem, and if there are any problems you want me to solve in the future. Thank you.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do word search lead code problem, and if we see the number of companies where I want to work at who have already asked this question, there are companies like Amazon, Twitter, Microsoft, Uber, Bloomberg, Facebook, TikTok, Snapchat, Google, Apple, Samsung, Roblox, Goldman Sachs, ByteDance, and eBay. So these are really popular companies, and this problem is really popular because it has very real life applications. We have all played games like crosswords and Wordle on our phones and on the newspapers and different kinds of stuff. So that is where this problem is associated with, and we are going to see that how to solve this one. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given an m cross n grid of characters called board, and we are also given a string called word. Now we need to see that if this word can be created based on whatever the number of characters we are given on this board, and if it does, we need to return true, else we need to return false. Also, we are given a note that the word can be constructed from letters sequentially adjacent cells, where adjacent cells are either horizontally or vertically neighboring. And we are also told that same letter cell may not be used more than once in order to create that word. So let's try to understand this with an example. Over here we are given this big board, and on this big board we are told that we need to find the word A, B, C, C, E, D. So if we see over here on these marked values, so this starts with the word A, the neighboring word is B, the neighboring word is C. Again we are told that we can horizontally or vertically see the words. So if we go vertically downwards, we see another C, and then we find another E, and at the end we find D, which is also adjacent to E, which is this letter, and this is basically part of this given board. So in this case we can return true. Now suppose if this word if we were not able to construct this word, we would not return true and we would return false. So let's see that what would be the optimal approach to solve this problem. Well, we have actually solved similar problems like this in the past using DFS and backtracking, and this is what we are going to do for this problem as well. Let me quickly show you how. Okay, so suppose this is the custom example we are given, and we need to find the word spider to see that whether it exists on this given board or not. And the idea is actually quite simple. What we are going to do is, first of all, we are going to take the first character inside this word, which is S, and we are going to iterate over this matrix until we find this first character. The moment we find the first character from whatever the place is, then we will keep on trying to find the next letter, the next words inside this word, to see if it exists in the neighboring node or the neighboring cell of the board inside this given matrix. And if somehow we are able to reach to the end of this word, we can return true. If we don't reach the end of the word and we actually reach the end of the matrix, we can return false. So the idea is actually quite simple, and there are just few tweaks we will have to use in between. So first we will start iterating over this matrix, trying to find this word number S. Now this is not S, this is not S. Over here we find the first value as S. So because this is the first value as S, now we will have to try to see that whether this P exists or not in the neighboring node of this S. We can clearly see that P exists. But before doing that, what we are going to do is we are actually going to mark this node as visited. So one way to do is to use some visited hash set and store all the values, but that is just causing strain on and to have an extra memory usage. Rather than doing that, we are going to actually modify this input, and we are going to mark it something like hash or something, which is an invalid value and it can never be there. So which means at any point we encounter that this value is hash, we don't need to go back to that place. Now we will start iterating over the neighbors of this S. So neighbors of S can be these three places. If we try to look at these three places and we are looking for the alphabet P, so P is present over here, which means that so far we have found S and P. Now we will update our value to I, and we will try to look for I in this P's neighbor. Also we will mark this node P as like hash, so we don't come back to this place again. Now this P has only two neighbors, because this neighbor s has already been visited because its value is hash, so we can't do anything about it. Now we are looking for this letter I, and we find the letter I over here, which means again we will mark this as hash. We will update the value of word we are looking for. The word we are looking for now is D. We'll try to find the neighbors of I, and in the neighbors of I, okay, we don't find anything over here. This is not D, and this has already been visited, which is hash, which means that there is no neighbor of I that contains this value D, which means that now we haven't found the word so far, and we still have matrix to go to that we haven't visited so far, which means that now we will backtrack from this I to the position we were originally at, which means that from this I we came from P, from this to this P we actually came from S, and now we can say that okay, even in this S it does not lead to us to find this word, and then we will again proceed with our search. So again we are trying to find this letter S again and not the D, because we did not find anything in the route, which means that now okay, this P is not S, this I is not S, this T is not S, so we are good so far. Now at this position we find a letter S, which means that okay, this S has been found. Now in the neighbor of this particular cell we will have to find the letter P, and we are going to mark this S as hash as a way to identify that this has been visited. Now what are the neighbors of S? These four are neighbors of S, and the one value we can find where the P exists is this one. So again we will repeat the same process. We will mark this as a hash. We'll try to find the word I we will find over here. So again we will mark this as a hash, and we will try to find D in the neighbor of this I. So we find D over here. So again we will mark this as hash. We will go update the word we are looking for, and now we will try to search for E inside this D's neighbors, and we can find it over here. Again mark this and then try to find this R. So R we actually find in the neighbor of this one, and this is the correct R, which means that now we are able to reach to the end of this word list, and we can return true in this case, saying that okay, this actually exists inside this given board, and we will be good. So this solution works perfectly fine. Let's see the time and space complexity with this one. So for the time complexity, actually the time complexity is a little bit tricky to find. Why? Because the time complexity is actually big O of n, which is the number of cells. So for every single cell we will have to iterate at least once. So n is given, but then we will have to repeat the same process for 3 times to the length of L in the worst case scenario. Why 3 times to the length of L? Because notice that at any single position, suppose we were at this position number D, and we need to see that okay, whether the next value E exists or not. So we need to check 3 places, not this one, because this already has the value hash, which means we won't check this one. But in theory we might have to check at all 3 places, and imagine if all 3 of them had the value E, we might have to explore the paths on all 3 of them in order to find the next value R. So that is why at every single position N we actually have 3 different options to see that whether this word exists or not, and this L is actually length of the given word. So that is why this is the time complexity. In terms of space complexity, we actually need to store the value inside our space until the time we reach to this entire word. So it would be big O of L, where L is the length of the word that is given. And this time and space complexity works perfectly fine, and I hope this solution makes sense to you. Let me quickly show you that what would be the coding for this one. So for this word search problem, we will actually have to create a backtrack public method that will call itself, and recursively we will try to achieve its answer. So there are some variables that we will need in both in this boolean exist method and also in the new backtrack method that we are trying to create. So let me define some variables that are global and that we can use in both the methods. And the variables we are going to create is to store the value of this board, and we will also need the row and column size of this given board character array. Now we have these, we will assign values to all these 3 variables from these given input endpoints. Once we have this, we will have to iterate over this board character array. So we are going to assign two for loops, and for both the for loops we are going to have the I and j value iterate up until the point of this rows and columns, and inside this for loop we will call our backtrack method. Now inside this for loop we are going to call our backtrack method, and we are going to have backtrack method return a boolean reply either true or false. And inside the backtrack method we are actually going to pass in the values of the current row position, current column position, word we are trying to find, and the index value we are currently at. So for the index value we would initially start with the position 0, and we would increment it every single time inside our backtrack method. And if at any case this returns true, we can simply return true in this case. And somehow if we are able to complete this loop and get out of it without returning true, which means word does not exist, so we can return false. Once this is done, now we will create our public boolean method called backtrack. Now first of all we will check that what is the condition where we will need to return true. So if at any point we identify that the index value is actually greater than or equal to word length, which means that we have already found that the current word already exists inside our given character array, so we can return true in this case. So now we will try to find the terminating conditions, and inside the terminating conditions, first of all we will check that whether the row and column position are they going out of bounds or not. If they are going out of bounds, we can return false immediately. If that is not the case, we will try to see that the current value we are looking at inside our board, if that value is not in sync with whatever the index value of the word we are looking for. If that is not the case, we can also return false immediately. So if any of these conditions are true, we can return false immediately. None of these conditions are true, which means that the current index value actually matches the value of that row and column position inside the board, and now we will have to iterate over the neighbors of this current row and column value inside the board. So in order to iterate over the values of the row and column, we are actually going to have two arrays called row direction and column direction, and that will help us navigate all the neighbors of any particular cell. Also, before moving to the next element, we are going to mark the current row and column position to have a value called hash, so we avoid checking the same element twice. Okay, once this is done, we will also have a boolean variable called return, and initially we are going to initialize its value to false, because basically we are going to call the backtrack function for all the four neighbors of the current cell. So for that we will keep track of this ret variable, and we are going to run a loop to iterate over all the directions, and we will add the values of these row direction and column direction to subsequent row and column positions inside this recursive call to our backtrack function. We will also update the value of the index, because we can determine that we have already find the word inside the previous index, and that's why we are calling the next index value to be searched inside the neighbors of any given row and column position. And also at any point, if we identify that the answer of this return function is actually, or this return variable is actually true, we can break out of that particular element immediately, and we don't have to check all the other neighbors. So we will put that condition as well. Once that is done, basically we are done with the checking part. Now the only thing we need to do is we will have to update the value of the row and column position to whatever the value that was originally there, and in the end we can simply return whatever the answer we got for this ret function. This is pretty much it for both our backtrack method and also our main method, and this should be able to solve our problem. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit this code, and our solution works as expected. And I would be posting this in the comments, so you can check it out, the solution from there. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. So the question we are going to do today is called longest increasing path in a matrix. And if we see some of the companies where I want to get a job who have already asked this question, there are companies like Apple, DoorDash, Google, Facebook, TikTok, Nvidia, Amazon, Uber, Microsoft, Snapchat, ByteDance, and bunch of more. So I'm going to pay my utmost attention. I hope you also find this useful. So this is a LeetCode hard problem and also a very well-liked problem, which is a rare combination to find. Basically, we are given an m cross an integer matrix and we need to return the length of the longest increasing path in this given matrix. Now, how do we build this longest increasing path that we need to return the length of? Essentially, we are told that from every single cell, we can move in 4 directions: left, right, up or down. And based on that, we need to calculate that what is going to be the longest increasing path. We are also explicitly told that we don't have to care about diagonally moving or values outside the boundary. So let's try to understand this with an example. Suppose in this case, this is the example that we are given. Now our aim is to find the longest increasing path. Now we know that from any single cell, how to define an increasing path. Let's say that we are currently located at this cell number 4. Now we have the option to go in 4 direction: up, down, left and right. Now from this 4 direction, we only need to go to the direction of the cell that is actually increasing order. So we need to maintain this increasing property. So from this value number 4, what are the places we can go? We can go to 9 and we can go to 8. We cannot go to 6 because this would be a diagonal and we cannot go anywhere outside the boundary. Now in both the cases, we have the option that the values are currently in the increasing order for this 8 and 9, which means both are legitimate scenario. But our aim is to find the longest increasing path. So from 8, do we have any other option to go to that increases in the path? No. From 9, do we have any other option to go to in any next cell that increases? Again, no. So in this case, from 4, the longest increasing path we can make is going to be 2. But is this the longest inside the given entire matrix? The answer is no. We need to find the cell that has the longest increasing path. So if we take one more example, let's take an example for this value number 1. Again, at this location value number 1, we have the option to go into 4 direction. But let's say that for the ease of convenience, we decide to go into the direction of this 1 to 2. Currently, the increasing path length is 1. Again, from this 2, we have one more neighboring cell that is higher than the value, that is this value number 6. So this time the increasing path value will increase by 1. And again from the 6, we can go to one more neighbor that increases in the value, and that is value number 1. And originally we started with this value number 1 and we moved one hop. So basically we will add one more over here. So essentially we can create a path that looks like this: 1, 2, 6 and 9, and this would be the longest increasing path in our matrix, and the length of this matrix is going to be value number 4. That is what we need to return in the answer. And the first approach comes to our mind is the brute force approach, the very basic approach that we can take to solve this problem. Now let's try to understand that what would be the brute force approach in this manner. Well, of course, the answer is quite simple. From every single cell, we start iterating in all 4 directions, and from all 4 directions we will see that where we can find the increasing path, and the moment we find the increasing path, we keep on adding the value to our answer variable, and we will keep on adding 1 over here. And same way for our increasing path, we will go to its neighbor, and again we will keep on repeating the same process. So let's try to see the solution I'm proposing in action. Okay, so let's say that for the ease of convenience, we start at value number 1 or this value number 9. Again from 9, what would be the increasing path we are able to make, and what is the maximum answer we have find so far? These are the 2 variables we are going to keep track of. So 9 does not have any neighbors that are in the increasing order, because 9 is the biggest value amongst all. So in this case we won't be able to find anything. Let's go to this another 9. Again same thing will happen, we won't be able to find anything. So these 2 are the values that we took care of. Now we are at value number 4. Since value number 4 we already calculated that there are only 2 paths we can take, so currently the increasing path maximum we can make is going to be 2. So answer currently we have found so far is value number 2, that this is the maximum path we are able to make. But let's keep on increasing with next subsequent values. So currently the values we took care of is going to be the first row, so I'm just going to mark them as X, that we already took care of this. Now we are at this value number 6. From 6, what are the options we have? We cannot go here because this is not increasing, this is same. We can go here to 9, so this is good. So from 6 we can again create a path of increasing path of size 2, and then that's it. So again our answer will remain same. We also took care of 6. Same goes for this 6. This 6 we have the option to go to value number 9, and we have the option to go to value number 8, but that won't lead to any further results. So again we cannot move anywhere forward. So we also took care of these 5 variables. Now let's move on to value number 8. Again from this value number 8 we do not actually have any path to go to, so we don't even bother updating any of the variables. Now we are at value number 2, and now things will start to get a little bit interesting. So what are the options for the increasing path we have at value number 2? So first increasing path option is over here, so from 2 to 6, that is good. Again from 6, do we have the option to go for the increasing path? And the answer is yes, that is 6 to 9. So in this case from this value number 2, the maximum increasing path we can achieve is going to be value number 3. So we are going to update our result, and so far the longest increasing path we have found so far is going to be value number 3. So again we are going to update our answer as well. Now we are at value number 1. So what are the options we have so far? Can we go to this? No. Can we go to this 6? Yes. So currently we go to this 6. From this 6, what are the options we have? We can either go to 9 or we can either go to 8. So let's just first go to 8. Okay, now we went to the 8. From 8, can we go anywhere else? No. So in this case, for this particular path, the answer we found is 3. But we still have one more option, that from 6 we can still go to this 9. So even if we go from 6 to 9, we don't have anywhere else to go. So once again the answer is going to be 3 as well. Now after taking care of both of these paths, now let's explore more options, and that option is that from this 1 we can go to this value number 2. Okay, from this 2 we still have option to go to value number 6. From this 6 we still have option to go to value number 9. So in this case we created a path that is 1 to 2 to 6 and then to 9. So in this case we created a path with a path length of 4. That is going to be the maximum path we have found so far. So we are again going to update our values. So this is going to be the current increasing path we found for the cell number 1, and the maximum path we have been able to find is also going to be 4. So we are going to update our answer because we need to enter the longest increasing path. And now we still have one more value that we need to go to. So again from this value number 1 we have the option to go to 1 to 8, and then from 8 we won't be able to go anywhere else. So in this case the maximum path we are able to achieve is going to be 2. After completing or after iterating every single value, we found out that the maximum longest increasing path we can create is going to be value number 4. So our brute force approach gave us the appropriate answer that we were looking for. But was it the most optimal answer? Well, the answer you already know, that of course not. And why? Because there are a few things we can actually make changes to. So first thing we can make change to is going to be regarding that for every single cell we were actually doing a lot of repeated computation, and how we were doing that, let me give you a quick example. So again, let's clean this up a bit. Initially when we were traversing our answer, when we reached to this value number 6, we already knew that from this 6 there is only one path we can go, and that is going to yield us the higher result, and that is from 6 to 9. So the longest increasing path, or the longest path we can make at value number 6, was going to be 2. Now when we came back to this value number 1 originally, from 1 what we did was we went from 1 to 2, from 2 to 6, and 6 to 9, every single place repeating the computation we have already completed, and that is a bad approach. What if we already knew that at value number 6 the longest we can do is going to be 2? Same way this value number 2, the longest we can make is going to be value number 3. So based on this information, if we are at value number 1 and we need to go back to this value number 2, we can clearly see that from 1 we already know that there is an increasing path that leads to 2, but from 2 we already know that the maximum amount of value it can generate in terms of longest increasing path is going to be of value number 3. So rather than doing all of this computation, we could have actually just done from 1 we reach to 2 and see that we already have the computation result for 2. So we could have done 1 plus 3 and the answer would have been immediately available to us as the value 4. So this is one of the major significant improvement we can make. And what this improvement is, this is actually we are storing the results that we have already calculated. So what we are doing is one of my favorite things and one of the most beautiful things that is available in the computer science, that is we are actually using dynamic programming in this case. But on top of using dynamic programming, we are also doing something more interesting, and that is that we are actually rather than treating this as the matrix or 3 by 3 matrix, we can actually treat this as individual nodes, and this individual nodes would have some way of connection with them. How connection? Because we are trying to find a path. Now for this path we are actually given the definition that if only from this current cell, let's say the value of current cell is A, if there is a path from A to B where B is greater than A, then only we can connect A to B and consider it for our path. So rather than treating this as just 2 by 2 matrix or m cross n matrix, we can actually consider every single cell in this matrix is equal to node and the path that we are trying to connect actually as the vertices. And once we do this, after seeing these two words, immediately in your mind it's gonna click that essentially we are treating this as a graph solution, and we are in the graph we are trying to find the longest increasing path. We already know how to build a path, and that is using the greater than or less than relation between any two cells. So essentially we already have a directed graph, and we already know that there won't be any cycles in this graph, because let's say that how does the cycle occur in a single graph? Let's say we go from 3 to 5 up in the same position 3, then we can see that there is a cycle. But in this case it is not possible to have a cycle. Why? Because the relation of this edge is actually based on the property that 3 is less than 5. That's why there is an edge that exists over here. If 3 was not less than 5, then there won't be any edge over here. So which means from 5 to 3 there is an edge, there is an impossible way to create an edge. So essentially this is also going to be an acyclic graph, and we already know that this is a director acyclic graph, and in the DAG or directed acyclic graph we are trying to find the longest path. Basically, rather than treating it as longest increasing path, we are just trying to find the longest path. So essentially now our life becomes much easier. On top of that, we are already going to use the dynamic programming properties. So we are going to know that how we are going to take care of every single value. So we are not going to repeat the computations that we have already created. Now let's see that what would be the solution look like in action. Okay, so now what we are going to do is we are actually going to create a dynamic programming to m cross n grid, and in this case we are going to use this to store that every single element, how many increasing path we can make, maximum amount of increasing path we can make. So this would be a great help for in terms of memorization. On top of that, for every single node, we are treating it as a graph, and we are going to build the graph upon them. So we are not actually creating a separate graph. We can actually use the same matrix. For the visual representation, I'm going to make some circles and some arrows, but you would be able to imagine that what we are actually trying to do. So first, let's say that we are at value number 9. So we are at a graph node like 9. From 9, do we have any edges extending out? No, because this is the same as 9 and this is less than 9. So there is no edges, which means the longest path we can make at value number 9 is going to be of value number 1. Okay, we are good with this result. Now at this second cell 9, again same thing is going to happen, that we are going to have a single cell that is not able to branch out or connect with anything else. So once again the longest path we are going to make is going to be value number 1. Now we are at this value number 4. What are the options we have? So let me just clean this up a bit, and from this value number 4 we actually have a couple of options. We can either grow from 4 to 9, or we can go from 4 to 8. So let's say if we decide to go from 4 to 9, do we need to calculate that from 9 how many values we can go to? No. Why? Because we already know this result. So from this 4, let's say if we decide to go to 9, we are actually going to create a path like this, that initially we are going to have a node 4, and from 4 we have the option to go to 9, or from this value number 4 we have the option to go to value number 8. So currently we have two options. From this 8 we don't know how many options we have because we haven't calculated, but we already calculated the result for this value number 9, which means if we decide to go from 4 to 9, we are for sure guaranteed to have an increasing path of 2, because from 9 it does not lead anywhere else. So we are good with this so far, which means and from this 4 to 8, let's say if we decide that from 4 we are going to go to 8, what are the options we have? From 8 we cannot go here or here. So again from 8 there are no possible nodes that we can calculate, which means we are again going to be able to create a maximum path of 2. So in this case, rather than doing all of this computation, we can actually store our answer, and we can just put down the value 2 over here, that this is the longest path 4 can take. Now we are at position number 6. From 6, what are the options here? It has, well, 6, as you can clearly see that 6 is not able to go over here. It is only able to go over here, and this we have already calculated from. So that means that from 6 we only have two options, and that is the longest path we can make is of value number 2. Again from this 6 we have two options. We can go to this value number 8, or we can go to this value number 9. In either case, the maximum path we are going to make is going to be of size 2. Reasons you already know. From this 8 we cannot actually go anywhere else, so the longest path we will be able to make is going to be 1. Now from this value number 2 we actually have just one option that where we can go, and that is to go to this value number 6. But from this 6 we already calculated the results, and that is going to be 2. So in this case we can clearly write the answer as 3. Now from this 1 we actually have multiple options to go to. So this I'm going to draw in the answer, and you would be able to understand what I mean. So initially we are located at this value number 1. From this 1 we have the option to go to value number 6. From this 1 we also have the option to go to value number 2, and from this 6 we have the option to go to value number 8, and we also have the option to go to value number 9. From this 2 we have the option to go to value number 6, and then 6 we have the option to go to value number 9, and currently we are located at this position. So these are the possibilities, or these are the options we can have. Let's assess each path. So in this case, if we go from 1 to 6, then from 6 we can either go to 8, or we can either go to 9. In either case, the answer for this portion is going to be value number 3. But in this case, if we decide from 1 to 2, 2 to 6, and 6 to 9, we are going to get the answer to be of value number 4. So in this case, 4 is the maximum answer we can get, but we don't actually have to do all of this computation. Why? Because we are using dynamic programming. That is the most important concept so far. So from this value number 1, the moment we see that this is where we can go, our mind should click that if we take this path, then what we would do is from here if we take this path, then the sum is going to be 3. But from here, if we take this path, then the sum is going to be 4. So obviously we are trying to find the maximum value, so we are going to store the value of 4 rather than storing the value 3, and 4 is here. Now we are again located at this value number 1. From this 1, can we go over here? No. Can we go over here? Yes. So what is the maximum path we can make? We can do one jump like this, and we already know that there is only one single entity path we can choose over here. So maximum value we can get is going to be 2. So this is going to be our dynamic programming graph combination matrix combination solution, and that is why this is treated as a hard problem. But in my opinion, if you already knew these concepts, then it won't be so difficult for you. And after watching this video, I can guarantee that this is definitely not going to be hard for you. So we can clearly see that in the end we only need to return the maximum value that is present inside the dynamic programming graph, and that we can return quite easily, and this is going to be the whole solution. Now this is a very beautiful solution. If we see time and space complexity in this case, essentially the time complexity is going to be big O of 2 times m cross n. So overall we can write the time complexity to be big O of m multiplied by n, which is a very good time complexity. And if we see space complexity, well, this is a little bit more expensive because we are using an additional 2 by 2 or m cross n matrix over here. So this is also going to be big O of m multiplied by n, but this is also reasonably acceptable. This is not very complicated. So in my opinion, this is a very good problem to understand three major concepts, and that is graph, dynamic programming, and also matrix. So everyone should do this problem at least once. Now let's go to the coding part that is not so difficult. So basically, first of all, we are going to create a 2D array to store all the directions that we are going to traverse over. We are also going to have some private integers that we are going to use. Now the first idea is to create or to find the longest increasing path. As an input, we are using the matrix that we are given in the input, and we are simply going to iterate over the given matrix. We are also going to create a cache or a dynamic programming m cross n array, and we are simply going to have our answer stored initially as value number 0. Then with using two for loops, we are going to iterate our n cross n array, and we are going to check that whether at any single cell position are we finding the maximum longest increasing path or not. And for to do that, we are actually going to call another helper method called dfx, where in the dfs as an input we are going to provide matrix, the current ith and jth position, so to identify that which cell we are talking about, and the current array that we or the current dynamic programming matrix that we have created and populated. Now inside our dfs method, we are first of all going to check that for any particular value, are we or have we already checked that particular cell value or not, and we are going to initialize the dynamic programming array as 0. So if the value is not equal to 0, then we need to find the value for that, and we are now going to iterate in all four directions from that particular cell. Then we are going to check that we are going out of bounds or not using these four conditions. If not, then we are only selecting the path where the adjacent values are going to be in the increasing order, and if that is the case, then we are going to update the value of our current cache with whatever the maximum value we can find for that existing cache, or recursively calling the dfs method again. And in the end, we are going to add one more value to our cache because we found an additional path that exists. And let's say if we don't find any additional path, still the initial value of cache is going to be 0. So if we increase it by 1, it is going to be added by 1. So let's try to run this code. Seems like our solution is working as expected. Let's submit this code, and our code runs pretty efficiently compared to a lot of other solutions. I would be posting this code in our GitHub repository, and that link for our GitHub repository is actually posted in the description, so you would be able to check it out from there. Thank you. Now in this topic, we are going to study design or system design related problems that can be asked in either system design problem, where you are going to be viewing it from a different lens, or they can be given some input parameters and some specific information, so that becomes a DSA problem. Now these are some of the most favorite problems, especially if you are intermediate to senior level, because now you have some exposure to actual real world scenario on how things work. And if an interviewer wanted to test out that whether you know some basic DSA, and also can you think outside of the box, and if you have to make a fully fledged production ready scalable system, how would you do that? So it can operate in both manners, and I have taken some questions that are pretty popular. So again, they are really good, and they have some element of DSA on it, because on a system design as a topic on its whole, it can be like a fully separate 100-hour long video, and there are like lots and lots of things to consider. So we are not diving deeper into that just now. We are still going to be focused from a point of view of technical interviews. So without any delay, let's get started. Hello friends, I'm a cloud solutions architect at Microsoft, and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting LeetCode problem called moving average from a data stream. And if we see some of the popular companies who have already asked this question, there are companies like Spotify, Facebook, Amazon, Google, Apple, Indeed, Microsoft, Uber, and Goldman Sachs. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode easy problem and also a very well-liked problem on LeetCode. Basically, we are given a stream of integers and we are also given a window size. Now we need to calculate the moving average of all the integers inside the sliding window, which means we only need to calculate the moving average of the maximum size of the window size that is given. If we identify more elements than the window size, we will simply kick that element out. So let's try to understand this with this example. In this example, basically, first of all, we are given the moving average value. So moving average currently is 3, which means that there can only be maximum of 3 values which we need to do the average of. Now, the first value we get is, currently we get the value, first value as 1. Okay, currently we only have one value. So what will be the average? So let me just create a new sum called average over here, and basically the maximum window size is currently 3. Okay, now we only have, since we only have one element, basically the average is going to be 1, because it's like we all know the formula of average, that the total sum divided by total size. Okay, so in this case, since sum and size both are 1, basically the value is going to be 1. Now if we see the example, the second value is 10. So now since this value is 10, and because this value is 10, currently it is still less than the window size we need. So basically the average now going to be 1 plus 10 divided by 2, because we have two elements. So basically the average is going to be 5.5. Okay, now we add one more element, so which is 3. If we add the element 3 over here, now this time the new average is going to be 1 plus 10 plus 3 divided by 3, which is going to be 14 divided by 3. So the value comes up to 4.66. This is going to be the third average, and we need to keep track of every single average. Okay, so we are keeping track of this 1, 5.5 and 4.66, all of them. And next element that comes in, the next element is 5. Now in this case, since the next element is 5, because if we add 5 over here, we would have 4 values inside our window. But the thing is, we are explicitly told that our window cannot have more than 3 elements, which means we will have to kick one element out. Now which element are we going to kick out? Basically the first value that was entered, we will kick this value out and we will add new value over here. So now we are going to have these 3 values only without the value number 1. So now the new average is going to be 10 plus 3 plus 5 divided by 3. So the answer is going to be 18 divided by 3, which is 6. And these are the 4 averages we need to return as the answer, the ones that I have highlighted in white. Okay, so all these 4 we will return, and this is what the problem is asking us to solve. Now if we see, the solution for this problem is actually quite simple. Okay, suppose we are told that the maximum window size can only be 3, and the values we are given, subsequent values, are, say for an example, 1, 2, 3, 4, 5, something like this. These are the 5 values we are given, and the maximum window size we can have is 3. What we will do is, basically for the average we are going to have 5 values. Now first we are only going to have value number 1. So currently let's just assume I'll create a new window over here. Now not here. Okay, let me just do it here. Let me just create a new window over here, and one by one we will keep on adding the values over here, and whenever we run out of the space, we will kick one value out. So first we will have value number 1. Okay, so let's add value number 1 over here. So we are adding from this side. So currently the value is 1, so the average is definitely going to be 1. Okay, we are good up until this point. Now next value is 2. Again we add 2 from this side, so we add one more value 2. So since now the new average is going to be 1 plus 2, 3 divided by 2, so 1.5. Okay, we are good. Next value is 3. So we can add 3 because the window size is still 3. So if we add value number 3, now this time the average is going to be 3 plus 2, 5 plus 1, 6 divided by 3. So the average is going to be 2. Okay, we are good up until this point as well. Now the value number 4 comes in. again remember, we are adding all the values from this side, which means we will have to kick the value number 1, which means we are kicking out this value, and then we are shifting all of these values one step. So let's just quickly do that. So since we have already kicked out the value number 1, and we have the values 2, 3 and 4, and 1 has been kicked out. Okay, now since 2 plus 3, 5 plus 4, 9 divided by 3, the average is going to be 3. Okay, and now in the end we have value number 5, so again we will have to kick out this value number 2. So let's just quickly update all the values. So this is going to be 3, 4 and 5, and we are going to kick out the value number 2 as well, and now the average is simply going to be 4. So this is the moving average for the window size 3. Now if you notice one thing, we kept on adding values from this side, and whichever the values were first added were the first values to be kicked out, and then we maintained a certain window. So if you see, this is a very similar structure to a queue data structure, and this is what exactly we are using. So, and this is the optimal solution of the problem as well. I just showed it to you, that basically we just initialize a queue of whatever the window size is given. So we initialize the queue of window size 3 in this case, and then all we need to do is keep track of the running sum. So we will have a variable called sum, and depending on the window size we would be able to calculate the average instantly, because we will have the value sum and we will have the value of the average. Now at any given time, do we need to calculate every single average again and again? No. Why no? Because say for an example, at this particular portion, like before this 5 was entered, the values we had was 2, 3 and 4, and now we know that we need to add value number 5. Basically, if we are adding value number 5 and we are kicking out the value number 2, previously this sum originally was 9. Now what operation we did? We kicked 2 out, so we will subtract 2 over here, which means now the average is going to be 7. Then we add the value 5 over here, which means that we added 5 to this 7, which means now the sum is going to be 12. So basically we do not need to calculate the whole sum every single time. We can quickly calculate the sum depending on the previous values, so which would be very useful to us. So this is the second thing we need to take care of, and using these two portions we can quickly find out that what is the window size, because that is the queue size. So, and we know that for to calculate the average we need to add items, which is the sum and the size. Okay, so sum, I just showed you how to calculate. Size, we can find it from the queue size, and using the queue, this problem becomes very easy to solve, and this is why this is an easy problem to be considered, and this would be the optimal solution. If we see time complexity, in this case the time complexity is actually going to be big O of n, where n is the given number of values that we need to iterate over. If we see space complexity, now this is a tricky one. We can consider space complexity to be 1 because the size of queue is going to remain constant, or we can consider the space complexity to be big O of n because we are using an additional data structure queue where we are storing some portion of the value. So this you can debate with your interviewer, but most likely they are going to agree with size to be big O of n. And this is the whole solution. So now let's move on to the coding. So since I'm running short on time, basically for this particular code, I'm not going to write the whole code, but I'll just explain you the solution and then I'll post the code in the comments so you can check it out from there. Basically, we need two items. First one is the moving average and second one is the method called next. So first, for the moving average method, basically we have the public moving average method which gives us the size of our window, and this is the size we are going to use to maintain our queue. Now initially we have initialized some variables called size, window sum. So this is the sum of current elements inside the given window, and the count, because this is a very important, we need to make sure that how many elements are there. And then we are initializing a dequeue. We can also initialize a queue over here, doesn't matter, both works the same way. And now let's discuss the implementation of the next value or next method. So in the next method, first of all, we increment the value of the count because we are adding a new value. Then for any given queue, basically we add the given input value at the back side of the queue. So we add a new value in the queue. Now we need to check that whether for the previously calculated window sum, do we need to remove the first element? And for that, how we are going to check is, so in this case, we are initializing a new variable called tail. And first we check that if the given particular count, if that is greater than the size, which means that our queue has become much bigger than the given size, basically we are going to pull the first element outside the queue, and we are going to keep that value assigned to the tail. If that is not the case, the tail value is going to remain 0 and we don't need to pull anything from the queue. Then we check that what is the current window sum, and the current window sum we can calculate by doing like window sum plus the value, because we are adding the value towards our window. And if the elements became greater than the number of size, then we will have to remove the tail element, so we are subtracting that. And then in the end, it's pretty easy for us to return the average, and we can simply do it by by dividing the window sum divided by the size. And now over here we are multiplying it by 1 because this is a double, and the window sum is an integer, so this is just for like a integer to double cast thing. Now this is the whole solution, and now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently compared to a lot of other solutions. So this is a very good solution, and I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, I'm a cloud solutions architect at Microsoft, and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting LeetCode problem called logger rate limiter. And this problem actually has many real life applications that we see in day-to-day use all the time. And that is why this has been a very popular question at many important companies. So if we see some companies, there are companies like Google, Bloomberg, Square, Microsoft, Amazon, Apple, Netflix, Uber, and Facebook. All have basically asked this question. So that is why this is a really important question, and I'm going to put my utmost attention. I hope you also enjoy the video. Okay, so this is a LeetCode easy problem and also decently well-liked problem on LeetCode. Basically, we need to design a logger system for our system where the property is that it keeps on receiving stream of incoming messages. Now, any single stream of message that comes in, it comes in with two items. It has the some message, so like some things of a string of a message, and then it also has the timestamp. Okay, now depending on these two values, we need to make sure that only unique messages are being printed, and during the duration of 10 seconds there should not be any repeated messages. If there is a repeated message, basically we simply discard it, and if the message comes after 10 seconds, we are going to print it. Let's try to understand this with an example. Say for an example, this is our system and we keep on getting streams of different messages. Okay, this could be M1, M2, M3, so on and so forth. There can be like 100 messages, that doesn't matter. We are only concerned about duplicate numbers that come during the window of a 10-second time frame. Okay, so this we don't want. So say for an example, currently this M1, this came in at the timestamp 1 or 1 second. Okay, currently we are just using it for an example. Now these all could have come at 1 second, 2 second, doesn't matter. There can be any number of choices. As long as they are separate messages, we don't care. But then again, during the another system, again same M1 message came at 7th second as well. Since this 1 second message was already printed, and over here I am printing the answer. Okay, so I have printed currently M1, M2, M3, all of these I have printed so far. Okay, M4 as well. Now again M1 popped up at 7 second, but the thing is we do not need to print any duplicate values at 10 second. So since this came in at 7 second, we are going to discard this, and then whatever the new messages are, we are going to keep track of them, and we will consider them to be printed whether they should be printed or not. Now again, the new M1 came on same message. Okay, same M1 message came at, let's say, 13 second. Now since this came at 13 second and the before message was printed at 1, Why this was printed at 1? We are not considering this at the 7 because this was never printed. Okay, so since this was at 13 and the previous one printed was at 1, then we are going to print this one m1 again at the second number 13. And this is the system, or this is the functionality we need to design. I know understanding this problem is more complicated than actually solving this, because the solution for this problem is actually quite simple. Now let me first quickly show you a very trivial solution and a very complex one. So the trivial solution is that, say for an example, we first of all create a queue because we are dealing with messages during a timestamp. Okay, so we are dealing with two items. Now for this particular queue, what we are going to do is, depending on the timestamp that comes in, so we can make this one as like a priority queue or something that deals with the time frame, and only like the first in messages and first out. This is the methodology we are going to use. Now for this particular queue, we already know that how to keep track of the n number of messages for 10 seconds, because this queue is only going to have the value it is going to store for the 10-second period. Okay, the moment 10 second passes, we are simply going to pop out the values that was already in the queue, and the new values can keep on coming in, but this 10-second window is important. And during this 10-second window, since we need to maintain that there should not be duplicates, so okay, no duplicates are needed. This is also another thing we need to keep track of. So in order to keep track of 10 seconds, we are using queue, but in order to make sure that there are no duplicates, we are going to have a hash set that would be in sync with this queue. And this is the solution: queue plus hash set. So this would be the hash set we will keep that would be in sync with this queue. And what we would do is simply, say for an example, m1 message came in, and since this queue can only have messages for 10 seconds, okay, this is the property we already set up. Now let's say m1 message came in. Currently this queue, say for example, is empty or it does not have any entries. So we are adding this value m1 over here. Since m1 has been added, at the same time we will check inside the hash set as well that whether the entry for m1 already exists or not. Currently m1, there is no entry for m1 exist. So since there is no entry for m1 exist, we are going to add a new value to our hash set as well, that is called m1. Okay, now we added m1 over here, and say for an example, this m1 came in at 1 second. Now currently m1 is located inside our priority queue at 1 second. We know that after 10 seconds, this m1 needs to be kicked out. And at the same time, say for an example, after now again 7 seconds has passed. So after 7 seconds, again m1 came. Now since m1 repeatedly came, now this queue, we do not want to check inside the queue that whether m1 exists or not. But at the same time, we can check inside the hash set. And currently m1 already exists inside the hash set. And since hash set and queue are in sync with each other, we can say for sure that since m1 is present inside the hash set, it has to be somewhere present inside the queue, which means we are going to discard this one and we don't do anything with this one. Now let's again go back to the new scenario, and the new scenario is that now enough time has passed and now we are at a value number 13, and again we get the message m1. Okay, so again we got the message m1 and the timestamp is 13. But the thing is, the current queue we had, we were only storing values for 10 seconds. The moment 10 seconds pass, we would start popping out the values from the priority queue, which means this m1 must have been kicked out. And we are also going to keep track of one more thing: the moment we kick out any element from our queue, at the same time we are going to kick it out from our hash set as well. So this m1 at the end of the 10 second, it got also kicked out from the hash set as well. There can be some other entries, we don't care. Okay, m1 has been kicked out, and at the same time now the second is 13. Of course, for the queue, we will see that we will ask the hash set that, hey, does m1 already exist? And since m1 does not exist, so we will add an entry m1 over here, and we will also let m1 inside our queue, and we will print the m1. And this is one way to set up our logger limiter system. Remember, what we did is we use the combination of queue and hash set to solve this problem. The thing is, your mind must go through that why are we making things so complicated when both of these things can be achieved in a single data structure, and that single data structure is actually hash map. And what we could have done is we could have simply created a hash map. Now inside this particular hash map we are going to have two values, and for these two values the first value we are going to keep track of is the key, and then the next one is its subsequent value. Okay, it's a key value pair kind of a data structure. Now this can have multiple entries. Now as a key we are actually going to keep the value of the message. So whatever the message we receive, because remember in our logger system we are receiving bunch of different messages and there are only very few messages that we need to print. So as the whatever the message value is m1, m2, m3, and this m1 can be anything. This m1 can be that hey, I got a job in FAANG. Okay, that doesn't matter, but that we are going to keep track of as a key. And whatever the timestamp is, we are going to keep that timestamp as its value, and this is going to make our lives much more easier. How? Say for an example, currently hashmap does not have any values, and then m1 comes in at 1 second. Currently the timestamp is 1. Okay, so now as a key we are going to store the value of m1, and as its subsequent value, currently because the entry does not exist, we are creating a new entry, and its subsequent value is going to be the timestamp. So current timestamp is going to be 1. Okay, now we have this entry inside our hash map. Now the next thing we are going to do is, again at the same time, we are going to this can receive multiple entries at once. So there can be another entry for m2, m3, this can be 3, this can be 2, there can be n number of values. Okay, and whatever the values we add inside our hash map, we are also going to print them as well, which is the necessary thing that we need to do. But again, if we receive the value m1 at 7 second, then we come at this m1. Okay, since m1 entry already exists, okay, now if it exists, then we need to compare the timestamps. So currently this timestamp is 1 and this timestamp is 7. So since the difference is less than 10, so if the difference is less than 10, actually we do not need to print this one, so we are simply going to discard this message. And then again new m1 comes at, let's say, 11 second, and since 11 second the difference is more than 10 seconds, so in this case we are again going to print out this m1 message, and the moment we print out the m1 message, we will update its timestamp to 11, and this will allow us to check for future m1 messages. This is the whole approach of this problem. And if we see the time and space complexity using the hashmap method, because hashmap method is the most optimal method, so in that case the time complexity is actually going to be big O of we can consider it to be big O of n, because that depends on the number of messages being received. But in theory the checking portion can be done, because for hashmap we know that the insertion takes big O of 1 time, and also the searching takes big O of 1 time. So these operations are pretty quick. The only time that takes is the time for input to come in. So that is why this big O of n, but in from our applications point of view, it is going to be big O of 1. And if you explain this to your interviewer, he is going to fall in love with you. And then the space complexity. So the space complexity is actually going to be big O of n for sure, because we are using additional data structure hashmap to store all the values. And this is a very good time and space complexity to implement such a primitive and important method, because this has been used by all the companies inside the entire world. So you just did something amazing. So put yourself pat on your back, and now let's move on to the coding. Okay, so since I'm running short on time, I'm actually going to show you the solution, and then I'm going to paste the solution in the comments so you can check it out from there. Okay, so let's move on with the explanation. First of all, we create a new public logger method where we are initializing our hash map, because that is the most important thing in the world. And then we are actually implementing our should I print this message or not method. Now in this case, we are receiving two items in the input. First item is the timestamp and second item is the message. First of all, we check that our hash set contains the message as the key or not. If it does not contain, basically we are definitely going to print this message, so we can print that. And at the same time we are going to add the entry inside our hash map saying that what the message was and what its timestamp was. So this is pretty easy to understand. Second thing is that, say for an example, if this does not work, which means that the message already contains, so then we will have to check that what is the old timestamp, and that we can simply get by getting the value from our hash map. And once we have that, we are simply going to check that whether the difference between the current timestamp and the old timestamp that we have already saved inside our hash map, if that difference is greater than or equal to 10, then we are simply going to print that message, and we are also going to return true. If it is not less than 10 and if the time not enough time has passed, simply we are going to say that no, we should not print this message, and we are going to return false. Notice that in this case we are not updating the entry inside our hash map because the previous 10 seconds hasn't passed. And this is the solution. This is a very simple and easy to understand solution. Now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently in terms of time complexity and pretty efficiently in terms of space complexity. So again, I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So in this video, we are going to solve a very popular LeetCode premium problem called design Tic-Tac-Toe. So without any delay, let's get started. We wants to design a tic-tac-toe game that is played between two players on an n×n grid. So typically we play tic-tac-toe between a 3x3 grid, but in this case we are just given that we need to create an n×n grid. But needless to say, even if we have to do it on this grid, the logic is going to remain same, and we are going to try to solve it in the optimized manner. Now we are given following the rules, but we all know what the rules are, that a move is guaranteed to be valid, which means every single move is going to happen on a block that is empty. Second thing is that once a winning condition is reached, no more moves are allowed. This is the critical portion of designing this problem. That is, we at every single moment, we need to make sure that whether a winning condition has been established or not. And we all know what winning condition looks like. If any of the player is able to make any such row or column or diagonal fashion in three sequential values, then that player is deemed as winner, no matter whatever the case might be. So let's try to see that what is going to be the most simplest approach that we can take, or the brute force approach, to check if at any given position any single player has reached the winning condition or not. Well, the answer is quite simple. Let's assume that any single player makes a move. So in this case, since the move is located at a non-diagonal square, we only need to check that whether this happens like all three zeros, or whether these happens as all three zeros. If this is the case, we can simply deem this as winning condition, and we can stop the game from there saying that this player has won. If that is not the case, then we can continue the game. So if we have to do this, well, this operation would take big of n time, and we will have to repeat this n operation n times, which means the brute force approach would yield big of n square time complexity. And this is just like the most logical thing if we have to do it in most primitive manner. Now let's try to see that what are the improvements we can make on this brute force approach. And for that, we will have to understand that how does winning condition work. So we are given three different options. Number one option is that any single player is able to complete either three rows. That is one option for the winning condition. Second one is any single player is able to complete the blocks in three columns. That is the second portion of the condition. And third condition is that we complete three diagonals. So is there a way to make this solution faster using these three items for every single move that is being made? And we are trying to target to have better time complexity than big of n square. And the answer is quite simple, that yes, we are able to do that. But for that, we will actually have to keep track that at any given position, any single move is made, how many corresponding rows with same symbol is currently present. That is number one thing we need to check. Second thing, how many number of corresponding columns have been filled. That is the second thing we have to check. And third thing, whether it is placed on a diagonal or not. So for that, we will have to use some indexes, which means now we have a way to identify any single box, that how it is represented based on its row and column value, and we can find that particular cell. So what are the winning conditions? Number one winning condition is 3 rows. Number 2 is 3 columns. And number 3 is 3 diagonals. So first let's assume that how can we keep track of 3 consecutive rows are present for any single player? Well, for that, what we can do is we can simply create an array with 3 sections, which denotes that at every single row position where the value is currently placed, and whenever any single value is being placed, we simply update the value by 1 for that particular player. And let me try to explain what I mean. So let's assume that currently we have created an array like this for any single player, and we know that at every single position we are able to identify that box based on the current row and column position. So let's assume that this is currently our rows array, and let me clean this up a bit so it would make things more clear. And currently we are only checking for 3 row condition. So let's assume that for this one we currently have 0, 1 and 2 as the values corresponding. Let's assume that currently player makes a move, that is X. So now we can define that this move has been currently made at row position 0 and column position 0. Currently we are only keeping track of the rows. Okay, so we are going to say that at row position number 0 there has been one entry that has been made for this particular X character or the player with X symbol. Next, let's assume that this player makes some random move, and then this player makes this move again. Once again, we can say that at row position 0 another X has been made. So we will go to our rows arrow and we will say that at this row's 0th position there has been one more move that has been added. So whatever value is, we are going to add it by one value. So currently we can mark this as 2. Let's assume that this player makes some random move, and once again at the 0th row we add one more X, which means now after adding this we will check the row position, that is once again 0. So we will try to add it once again, and we realize that this position actually had value number 3 at one of the locations or one of the index locations at row. The moment we identify that, we can say that this player with X character has actually won the game, and we can stop the game over here because winning condition has been established. This is the scenario in order to identify that at any given entry point whether a row has been created or not. Now let's try to understand the second winning condition, that is 3 columns. Once again the logic is going to remain the same, and let's try to redo this all of these operations. And once again now we are going to move in the column direction. Okay, so let's assume that currently one player makes a move like X. Now this time we are tracking the value 0. Okay, so let's assume that our second player makes the column 0 row over here. So currently this 0th position is located at row 0 and column 1. So currently even for our column we are going to have one more array, and once again it is going to have value 0, 1 and 2. So at position number 1 currently all of these values are going to be 0, but at position number 1 we identify that one character has been made, so we will mark it by value number 1. Once again let's assume that this player makes a move here and this player makes a move here. So once again at column position number 1, 1 we have made one more move, so we are going to add this by 2. Let's assume that this player makes a move here and then this player once again makes a move here. In this case once again we find that 3 items has been added at the same position inside the row, and that's why we are marking it as 3. So we can also say that a winning condition has been established. So these are the 2 scenarios for rows and columns. Now let's try to take care of the third scenario or third winning condition on how we are going to keep track of that, and that is to keep track of the diagonals. So let's mark the values 0, 1, 2 and once again 0, 1, 2, and we will try to mark for the diagonals. Now what are the squares being covered by diagonals? So these are one set of squares and these are second set of squares. Now In order to identify that whether a value has been placed on a diagonal or not, it is very simple. The moment we identify that both row and column value are same, we can just add one more entry that on the diagonal position one value has been added. But the question is, we actually have two diagonals and second diagonal is this one. So for this one, how do we identify if any single value is being added at one of these three positions? How do we mark as this? We can call it as anti-diagonal. So we already established that for diagonal, if the row value equal to column value, if that is the case, we can mark that one character has been added for that subsequent diagonal. But for anti-diagonal, how do we keep track of that? So for that, let's assume that these are the squares we are talking about. So let's see the position of this square. So currently the row position of this square, the column position of this square is equal to 2 and row position of this square is equal to 0. Same way, in this case, the row position is equal to 2 and once again, in this case, the column position is equal to 0. So in both the squares, if you do the sum of row plus column, you would always find the answer to be n minus 1. And in this case, n is equal to 3 because we currently have n by n grid or 3 by 3 grid. So the moment we identify that this is row plus column is actually fulfilling the condition of n minus 1, or in this case, because this is a 3 by 3 grid, if row plus column is equal to 2, then we can for sure say that that particular item has to be on a diagonal and has to be on an anti-diagonal. And for that, we can also consider this square as well, because this is also row 1 and column 1. If we do sum of this falls to this is 2 and this is 0. So for this particular one, once again the sum is 2, and once again for this one the row position is 2 and column position is 0. So once again the sum is 2, and no other square is going to fulfill that condition. Let's try to check our theory. Let's assume that we talk about this square. So currently this square is located at row position 2 and column position 1. So 2 plus 1 is actually going to be 3, not 2. So for diagonal, we already know if row and column are same, then it's a diagonal. We can mark it. If for a row and column is equal to n minus 1, then it's an anti-diagonal. And then now let's see that how do we check for the winning condition in this scenario. So now the logic is actually quite simple. All we need to do is at every given moment, we need to keep track of row and column position. But now we don't need to check for the whole thing regarding creating separate arrays, because there are only two diagonals possible, normal diagonal and anti-diagonal. So at any given moment, if I enter a value on a diagonal, it has to be added for that particular diagonal. So let's assume, let's restart our game. So once again, currently I add one value x over here. So currently the row and column position is 0, 0, which means I will have to add one value to the diagonal. So currently diagonal initial value is going to be 0 and anti-diagonal initial value is going to be 0. But because I added one value over here, I will have to add one value to the diagonal. Okay. Now let's add a 0 at some random place. So I add a 0 over here. Once again for the 0, we are also going to keep track of the same thing. Now let's add one more value on x. Now this x is currently located at column position 1 and row position 1, which means row is equal to column, which means in the diagonal we need to add 1. So we can add value 1 over here. But notice that this is also fulfilling the condition for anti-diagonal as well, because 1 plus 1 is equal to 2. So once again, we are also going to add one more value to the anti-diagonal. Now let's assume that for some reason we decide to add one value over here. Okay, 0 is here, and then we add one more value over here. So this is 2 and this is 0. So in this case, we only update the anti-diagonal and not the diagonal. So once again, anti-diagonal is going to be 2. And now for some reason, let's try to add one more value of x. Let's add it on the diagonal. So now this is 2 and this is 2. So this is diagonal. So even on diagonal, we identify value to be 3 or to be n. So in this case, we can consider that a winning condition has been established. Now let's try to reapply all of this logic that we just discussed for both the players side by side, and then we will try to find some solution. So now we have our array, or we have our image. So let's try to put it over here. Okay, let's try to give the index value 0 1 2 and once again 0 1 2. And now let's create one set of instructions for player X and one set of instructions for player O. We are going to have initially our row array. So we are going to store 3 values inside the row. Once again for column, we are going to store 3 values inside the column. Once again for diagonal, we are going to have just a normal 0, and for anti-diagonal, we are going to have a normal 0. Same thing going to happen for row. Okay, cool. So now we have all of our answers, and now let's add first value X over here. So this is 0 0. So on the row position 0, we are going to mark one value. On the column position 0, we are going to mark one value. Now row is equal to column, which means we are also going to add one value to the diagonal, and anti-diagonal is going to remain the same. Now once again, let's repeat the same exercise for 0 as well. Now 0 is currently placed on row 0, which means on the row we are going to add value 1, and column 1. So on column 1 we are going to add value 1. This is not on diagonal or anti-diagonal, so we don't care. Next, let's add X one more over here. So this is added on row 2. So on the column 2. So on column 2 we are going to add value 1, and row 0 we are going to add value 1 more. So row 0 already had one value. We are going to add it over here. So let's add value. This becomes 2. And now this is 2 plus 0. So this satisfies the condition for anti-diagonal. So once again, we are going to mark anti-diagonal as 1 as well. Now let's add one more 0 over here. Okay, so now 0 is currently placed on a diagonal and also anti-diagonal. So we are going to add 1 1 on both of these locations. Plus currently 0 is placed on column number 1. So column number 1 already had 1. So we are going to mark it as 2. And this is row 1. So row 1 does not have any value. So we are going to mark this as 1. Okay, now let's try to put one more X over here. Currently this X is placed on this is row 1 and column 0. So row 1 is 1, column 0 is going to be 2. Okay, and this is not a diagonal or anti-diagonal. Now let's put one more 0 over here. So this is row 2 and column 1. So on the row 2 we are going to add one value over here, and in the column 2 or in the column 1 we are going to add one value 3. The moment we identify 3, we don't need to do any further calculation because a winning condition has been reached. This 0 has 1, and we can simply return that 0 is the winner and this is the winning condition. And this game can keep on going on, and eventually we would either find a draw or a winning condition, but we would be completing this whole solution in big O of n time only, nothing else. And you can notice that this is a much better time complexity compared to our brute force approach, which is awesome. If we see space complexity, well, space complexity is also going to be big O of n. Why? Because we are enabling these row and column arrays, and they are directly dependent on the number of inputs. So this is the whole solution. I know I repeated bunch of things many times, but the purpose was to explain you in the most simplest manner. And now let's quickly see the coding solution. Unfortunately for this one, I won't be able to show you that how does code runs, because I currently don't have LeetCode premium subscription because I ended my subscription and never renewed it. So I will show you the code and hopefully we can end this video. So this is going to be the coding solution for our designing Tic-Tac-Toe. So first we have our class Tic-Tac-Toe, where we have the array for rows and array for columns. We also have an integer for diagonal and anti-diagonal, and we simply have an integer for the size of the array. This is going to be our n cross n grid. Now let's initialize our data structure, where we are simply providing the value of n. Based on this value of n, we are also initializing the two arrays that we want for rows and columns. Okay, now we are doing something slightly different. So we have a method called move, and remember, at every single move we have to identify that whether the game has ended or some player has won or not. Now the thing is, for both of the players, we are given the values as integer, and we are marking that for player with value number 0 is marked as 1, and player with value number X is marked as -1, or you can do vice versa. Now the question is, if we use -1 over here, how would we do the sum of two values? And for that we are actually using math.absolute function. So no matter what, we are always going to be doing the sum based on the absolute values, so it is always going to come up as positive integer values, so nothing, no issues. Now the idea is very simple. For every single player's move, depending on the row and column position, we are going to update the rows and columns array based on the player value, and in this case the player value has been either 1 or -1, and in either case, because we are going to be doing absolute value, so we should be able to find it if that is equivalent to size or not. So we check for the rows and columns. Next, we also update the diagonal value. For that, we simply have to check if row is equal to column. If that is the case, we simply update the value of the diagonal. Next, we have to check for the anti-diagonal as well. For that, we check row plus column, and we have the condition that if the size is if that is equal to size -1, in that case we also update the value at the anti-diagonal. And then we have a very simple condition that at any given moment we identify that whether the current row position or current column position in the rows or columns array is equal to the size, or the current diagonal position is equal to size, or current anti-diagonal is also equal to size. If any of this position happens, we simply return the player saying that this player has won. If that is not the case, and if no one wins, then we can simply return 0. So this is a very simple code, and once again I would be posting this code in our GitHub repository. The link is in the description, so you can check it out from there. Thank you. Hello friends, so today we are going to do an awesome LeetCode problem that has been asked in a bunch of different IT companies. So without any delay, let's get started. So the problem is insert, delete, get random, big O of 1. And if we want to understand the problem statement, basically we need to implement a randomized set class where we need to implement these three methods. That is, first one is insert, second one is delete, and third one is get random. And we need to make sure that we implement these methods in big O of 1 time. Now you can see that this is a LeetCode medium problem and also a very well-liked problem, but in my opinion, this should have been an easy problem. Also, if you want, you can read this whole description. If not, let me just give you an explanation that what this problem is asking us to do. Basically, we need to create some sort of data structure where we can keep track of three items. First one is add, second one is remove, and third one is get random method. Okay, so let's try to understand each of the method one by one. Now for these two methods, we don't need to return any values. We just need to return true or false because we need to return a boolean value, and this would be defined based on the value is present inside the existing set or not. So let's assume that currently this is an empty set and we are being asked that, okay, just add value number 5. So if we have to add value number 5, we can add value number 5, and because 5 was already not present inside the existing set, we need to return true in this case. Next, we might be asked to add value number 7. So once again for 7 we will add it and return true. Once again we might being asked to add value number 9. So once again we will repeat the same process and the answer is also going to be true. But now let's say for an example, once again we are being asked to add value number 5 once again. But because 5 is already present in this case, we can't add the value to our existing set, but we can simply say that for this 5, because it was already present, we did not add it inside the set, we need to return false. So this is the logic for the add method. Second logic for the remove method is also very similar. That let's assume that for this example, let's add one more value, 11. Okay. And now for remove, we are being asked to remove value number 9. So first we need to check that whether 9 is present inside our data structure or not. Yeah, so 9 is present. If 9 is present, we need to remove 9. So let's get rid of 9. And currently we only have three values, 5, 7 and 11. And because 9 was present and we removed it, once again we need to return true for this one. Once again, let's assume that we are being asked to remove value number 17. Now 17 is not present inside our existing data set. So in this case, we will return false because we did not remove any values from our data set. Okay. And for the get random method, this is just very simple. Whatever the values are currently present inside our set or data, we simply need to pick any random value. So if we are being asked to get random, we can return value number 7. Next time we might return value number 11. Next time we might return 7 again. Next time we might return 5. Once again we might return 5. Any number of values, it is going to be randomly picked and we have no control over it. Now for all of these three cases, Simply we are just implementing the same method, and also the logic is going to be that we need to complete all of this in big O of one time. Okay, now the thing is, for this get random, actually it is very beneficial for us to use any existing method that is present for any single language like C, Java or Python. All of these language, they have their own way where they actually store, or where you can actually pick a randomized value from the existing set. So this is very beneficial to us, but there are few problems in our cases, and we need to do things slightly bit differently in order to achieve the solution. Now first let's try to take this problem one by one iteratively, and the moment you understood that we need to solve this problem in big O of one time, you must have understood that we need to do one or two things. We can either use hash map or hash set in order to solve this problem. So if we have to solve this problem, actually if we only needed to do like add and remove method, we should be able to complete this using hash set or hash map. Both of this would fruition the same result, and we would be able to complete this problem in big O of one time using any of the hashing data structure. So let's try to see that in example. Let's assume that we initiate a hash set, and now currently we try to add the values. So let's assume that we add value number 5. Okay, so 5 was not present inside the hash set. We can check this in big O of one time. Because it was not present, we add value number 5 to hash set, and we can simply return true. Once again we need to add value number 6. So once again we will repeat the same process, add 6 and return true. Same way we need to add value number 7. So once again we will add 7 and return true. Okay, this works in big O of one time add method, no issues. This is a very simple thing. Once again, if we have to implement the same logic for the remove method, let's say that we need to remove value number 6. So we can simply return true and say that okay, 6 has been removed, and that's it. Yeah, we can say that because 6 was present, we removed it from the hash set, so it is no longer there, and we return true. Once again we need to remove value number 8. We can check in big O of one time that whether 8 is present inside our hash set or not. Because it is not present, we need to return false in this case. So both of these logic works exactly fine, no issues with this. But when we need to do get random method, we cannot implement get random method in this scenario, because typically get random, for that we need to say that okay, give me, if I use like predefined method of get random from any single language, that method typically works like that. If there are values between 1 to 100, give me any random value, and it can return any value between like 7 or 51 or 55, something like that. But the thing is, in our case, we only need to find the random values between value number 5 and value number 7. Now one logical method comes to our ways that we take count of all the values, put them in some sort of list, and then in the list we only keep the values that are already over here. So we are simply going to create a list of size 2 where we are going to have values 5 and 7, and then we can say that give me a random value amongst between 0 and 1 index values, and based on the index value, so let's say for the first random we get index value 1, so we return value number 7. Let me broaden up the horizon. So let's assume that there are few more values, okay, 9 and 11. So between 0 to 4 I need to return some values. Okay, so in the 0 to 4 I need to return some values, and now in the first 0 to 3, basically 4 values. So in the first time it says that the value is 2. So if value is 2, we need to find the value at index location number 2, that is value number 9. So we can return 9. Next time, if the value is 3, once we can return value number 11. So on and so forth. Now the thing is, for get random, in order to use get random, we need some sort of indexed data structure where we store all the remaining values, and then we select a random index value, and whichever value is located on that index location, we need to return that value. So we already know that we already took care of this add and remove method using the hash set. Okay, but the thing is, in order for us to implement this get random method, we need to keep track of a list that contains all the values that are currently present inside our hash set, and we need to know that at what index location which value is present, because when we try to add a value, we need to add it at any particular index location, or we need to keep track of that index location. Why? Because when we have to remove that value, we can remove it from the hashing data structure, but we also need to remove it from our array list. And if we don't know the index, if we have to search one by one, then this becomes big of an operation. So this is the complexity. But once you know that you will have to use two data structure, this becomes very easy and very simple to do. So let's try to solve this problem, and we will try to go through the add, remove and get random methods. Now you all know that how does get random work. Once we have this list with all the data structure, and list only contains the data that is currently present inside our hashing data structure. It can be hash set or hash map, anyone. Then it is very easy to implement the get random method. Okay, so this we already know, but tricky part is managing this list with this hashing function at the same time. So in this approach, hash set would not be a good choice. Actually, we will have to use a hash map in this problem. So let's try to solve the same thing using hash map, because we need to keep track of the index location. This is the important part. So now once again, let's assume that this is currently our hash map. In the hash map, we know it's a key value based data structure. So as part of the key, we are actually going to store the value or the incoming item that comes in with our method add. Okay, or add or remove. These comes in with an integer value. So whichever the integer value that it comes in with, this is going to be stored in the key portion of our hash map. And as part of its value, we are also going to have a subsequent array list. And inside this array list, it is also going to have index values. So let me mark some index values over here, 0, 1, 2, 3. Okay. And as part of its value, we are going to store the index numbers so that we can do add and remove operations quite easily. Now let's say that now let's see the logic for the add operation. Let's assume that I need to add value number 1. Okay. So I can add value number 1 over here because 1 was not present. First, I will check whether 1 is present or not. Because 1 was not present, I add value number 1 inside our hash map. Okay, all of this operations happens in big of one time. At the same time, I add 1 in the very last position of the array list that we have created. Now currently this array list is empty, so very last position is also going to be index value number 0. So I'm going to store 1 over here. And whatever the index value is, that is going to be the size of the array list, and that index value I'm going to store as the value for our hash map. So this is going to be value number 0. Same way if I need to add value number 2, once again the logic is going to be same, 2, and because this index location is 1, so I'm going to store 1 as the value. Let's add value number 5. So 5 and index value is 2. And let's add value number 7. So 7, index value is 3, and this is our array list so far. Okay. And for all of these operations, I'm returning true because these values were not present. Now let's say that I do one more operation, add value number 7 once again. So in this case, because 7 is already present, which I can check in big O of one time. So because of that, I can simply return false, saying that 7 is already present. So I cannot add 7 inside our data set that we have stored. Now let's go back to the remove function. For the remove function, the logic is actually quite simple, but we need to do some additional steps. Why? Because we need to make sure that this list only contain the data that are currently present inside the hash set, and any data that is out of order, we need to fix the order because we might need to remove some element from the middle as well. So what is going to be the logic? Let's assume that we are being asked to remove value number 5. So what we can do is first go to the value number 5. We know that 5 is present, which means we will have to remove this. So the answer is going to be true. That is for sure. But what is going to be the logic for removal? First, we will check that, okay, for 5, where it is stored inside our array list. So it is stored at the index location 2. So this value we will have to remove. But if we remove this value, then we might end up in a position where the values would be 1, 2, then this is going to be a null value. And then the last one is going to be value number 7. Okay. So now the problem is that the value number null is no longer there. And in this case, if we have to implement our GetRandom method, if we randomly select value number 2, then we might end up returning null, which means we will only need to keep the valid values, no longer the null values. So for that, what we are going to do is, let's assume that we get rid of this one, and then this is a null value. We realize that we need to remove value number 5 from this position too. So one simple logic is that we are going to swap value number 5 with whatever the last element is inside our hash, inside our array list. So let me remove this one. So we are going to have a scenario where this is value number 7, this is value number 5, and then we can simply get rid of the last element inside the array list. So we will not have 5 over here, and we will also not have value number 5 over here, and we are simply going to have value number 1, 2 and 7 inside our array list, and we are also going to have 1, 2 and 7 inside our hash map, which means our add and remove function will work exactly fine. And when we get to a level of GetRandom, we can simply select the random value of amongst any one of these 3 index values. So currently the index values are going to be, give me a random value between 0, 1 and 2 index values, and it can randomly pick any values. And this can work for even if we have 100 values, the same logic is going to be there. So this is the approach. Now the time complexity, obviously for add remove, it works in big of one time because we are using hash map, and for the GetRandom, because we are using the pre-built method that operates in big of one time, and we are only searching for the index value, and fetching a value from the index value of the data structure works in big of one time, then also it is the same thing. So this is the whole solution of this problem, and it's a very interesting problem once you understand the trick. Okay, so now let's see that what is going to be the coding logic for this problem. Okay, so now let's see the code for insert, delete, get random. So first we are going to initialize our hash map, and we are also going to initialize an array list. We are also going to initialize a variable called rand to store the random values, and we are going to initialize our public randomize set class. Now first thing we need to implement is the insert method. So for that we need to implement a boolean method insert, where we are inserting a value. The first thing we are going to do is check whether this value is part of the key of our hash map or not. If it is part of the key, we can simply return the false. If it is not part of the key, we need to add the value to our hash map. For that we are adding the value as the key, and the size of current array list is going to be the index value, because we are always adding the value to the very end of the list, and we can also add the value to the existing list as well, and we can simply return true. Now let's see the logic for the remove operation. So first we check that whether the value is present inside the key or not. If it is present, if it is not present, we can simply return false, because there is nothing for us to remove. If it is not present, and if the value is present, then we need to first get the index value for that particular position, and we need to get the last element inside the existing list, because we need to swap the values. Okay, then we are going to swap the elements inside the existing set that is about to be removed, and we are going to update the value inside our hash map. Plus we are going to simply remove the last element inside the array list and also inside the hash map, and in the end we are going to return true, that we return the values. And then last method is the GetRandom method, where we are going to simply run the GetRandom method inside our existing list, and in order to find the next randomized item, we are simply going to look for the all the available index values of our list, and this is the whole logic. So now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs much faster than most of the other solutions. So that is pretty good. And this is the whole solution. Hello friends, hope you are having a fantastic day today. So now we are going to do a very popular LeetCode problem called LRU Cache. And this is a very well-liked problem, and it is a LeetCode medium problem. Now this problem can be asked in two manners. This is a very popular system design constraint as well. It's very simple for a system design, but still it is there. And also it is a LeetCode problem, so it can also be asked in your technical interview. So I ask you to put higher attention to this problem because it can be asked in two different types of interviews. Now let's understand the problem statement. Basically, we need to create a data structure that follows the constraint of a least recently used cache. So first let's understand that what are going to be the constraint for the least recently used cache. The simple thing is, purpose of cache is to store some values. Let's assume that currently we have this cache and we can store 3 values inside the cache. So the idea is that first I add value number 1, then I add value number 2, and then I add value number 3. Now, because value number 1 was the very first value that I entered, or it is the least recently used item in the cache, because relatively number 2 and number 3 have been used after number 1 was being used. So number 1 is the least recently being used value. So if I have to add value number 4 inside the cache, I need to kick out 1 and I need to add 4 over here. But in this scenario, now the least recently used item is going to be value number 2. And if next element is 5 I need to enter, then I need to kick out 2 and add value number 5. But currently now this 3 is the least recently used, but say for an example, for some reason I ask this cache that, hey, get me this value number 3. In this case, now this 3 is no longer the least recently used value. Now the least recently used value is going to be this value number 4. So in case if I have to enter value number 6 in this case, now again I'm going to kick out value number 4 and add value number 6 over here. This is the constraint of least recently used cache, and this is what we need to implement. But now let's go back to our problem statement and understand what exactly being asked us to do. So number one thing is, we need to create a class LRU cache class where we need to implement few methods. Number one method is a capacity method. So the capacity method defines that this is going to be the size of cache. So in this case, currently our capacity is 3, and this is what we come up with. Okay. Next one is that we need to create a method that gets any particular element from the key from our existing cache. Now the thing is, the value we are storing inside the cache is actually a key value pair kind of the thing. So in the input we would be given values like 1 1. So in this case, the value we need to store is a key value pair, that is 1 1. This is the whole node where 1 is defined by the key and its subsequent value is value number 1. Okay. Now, in order for us to put the value, now if we have to add a new value inside our cache, then we are given some more constraint. Number one constraint is that we need to update the value of the key if the key already exists. Okay, so that is number one constraint. Number two constraint is that if the key does not exist, then we need to add the whole key value pair inside our existing cache. And for some reason, if we move out of the capacity, then we need to evict, or we need to kick out the least recently used key. So the same thing that we just saw in the example. Okay. So now let's try to understand this whole scenario with like a slightly broader case, and we will try to understand that what are the things we need and what are the constraints we have and how can we actually start implementing these methods. Now, for all of you, I must know that the moment you heard that we are using key value pair, the number one thing that comes to your mind is that we are actually going to use hash map, and you are exactly correct. In order to store all the values inside the cache, we are actually going to use the hash map. Now the thing is, in the hash map, the typical structure is that we have a key and we have associated value. Now in this case, the node we are trying to store, the node is actually structured as a key value pair in itself, and this is going to be the value, and the key is going to be the same key that we are being given inside the node that we are going to use. But one different thing we are going to do is that instead of storing, let's assume that currently the value of this node is that key is 1 and value number is 5. If this is the value we need to store, we are not going to store it like this, that number 1 as the key and value as number 5. No, this would be correct, but we will not do that. Instead, what we would do is we will see that what is the pointer location of this node, and we are going to store the pointer location that points to this particular element, and it would be the same thing because we are using the hash map. So access is always going to be big of 1. We can always find this value in big of 1 time, but this is going to be greatly helpful for us in order to maintain the order in which the elements came in. This is the most important part, because we are not only storing the values inside the hash map and kicking the values out of the hash map, we also need to keep track of that what was the least recently used item, which means at the same time we will also have to keep track of that which was the most recently used item because of the get operation. You understand my point? That what I'm trying to say, because remember, we need to implement three methods. Number one method is a capacity. Now capacity is really easy to make sure, because that is going to be the size of our hash map that we are going to implement. So we will never be able to exceed our capacity. That is number one, that has been taken care of. Second method is the put method. Okay, put method is also relatively easy, that I just explained, that we as a key we are going to store the key, as a pointer we are going to store the node that we are going to point. Next method is the get method. This is also very easy, because we know that in the get we are being asked that, hey, this is the key and fetch me the whole value. Now inside the hash map, it is really easy to fetch out values. We can do that operation in big O of one time. Let's assume that currently we have a value like 2 and its subsequent pointer that points to the value of 2 and 5 in the node. If we are being asked to fetch this value, we can fetch it very quickly in big O of one time. But the problem is, when we have to, for this put operation, when we run out of the capacity, then in that scenario we will have to do an eviction. Now for this eviction, we need to keep track of that what was the least recently used element that we came up with. And in this case, first instinct is to use a simple queue, because let's assume that for a second we don't have this get operation. Okay, let's assume for a simple second. Now what would happen is, currently we have our hash map. Now inside the hash map we need to store the values of key value pair. Okay, and what we are going to do is, let's assume that the current capacity is 3. Okay, so let me add 3 blocks. Same way, the current capacity of the queue is also going to be 3. Now number one thing is, first value we are trying to enter is 1 1. So let's assume that I'm entering value 1 1 over here. Same way, the very first entry I'm going to enter inside the queue is going to be 1 because of the key. Second value is 2 2. Once again second value is 2. Next value is 3 3. Once again the value is 3. Now let's assume that there is value number 4 I'm trying to insert. What value should I evict? It's very simple. The very first value that entered inside the queue has to be the first value that gets kicked out of the queue. So this is very simple to implement. But the problem is that currently this sequence is fine, but the moment I apply the logic of get, and now in this scenario, let's assume that I decide to get value number 2. Okay, let me add this value number 4 before. Okay, so let me go ahead and quickly do that. Okay, I added value number 4 over here. I also got rid of 1 and I adjusted the flow of 2 and 3. Okay, so now I adjusted the flow of 2 and 3 and 4, and now I have already added the value number 4. Now the thing is, I apply get operation. Currently in this scenario, the least recently used element is value number 2. That is very simple to understand. But now if I do get 2, immediately 2 becomes actually the most recently used element, because I just accessed 2. So now what would be the new flow of the queue is that it's going to be 2, 4 and 3. And now suddenly 3 becomes the least recently used character. And in this case, if I have to kick one value out, I can also kick that out. Basically, if I want to add value number 5 in this case, now I need to kick value number 3 out. Now the question is, you must be thinking that, hey, even with the queue, we can actually implement the same thing. What we will do is, whenever we are being asked to run a get operation, all we need to do is we first need to find the value that is currently present inside the existing queue, move it to the very first element of the queue and shift all the other nodes one step forward. And then also this logic would work. But that would be a suboptimal approach. Why? Because hash map is going to run in big O of one time. No issues with that. Queue, typically it is going to run in big O of one time because we are simply popping elements out from behind the scenes. But when we have to do the get operation, we need to iterate over the entire queue in order to find the position of that element, and that operation takes big O of n time. And if we see the problem statement, we are very explicitly being told that the functions get and put must run in on an average big O of one time complexity. So we need to take care of that scenario. So now let's just break down the same problem and try to come up with the thinking that what are the things we need what are the things we have, and how can we make the solution better. This is the approach you should be thinking in your actual interviews as well, and that is why I created this whole 10-minute preamble of the whole things that we are now going to come up with the optimal solution. So in this case, once again, we already mentioned few things, that we are using hash map in order to store the values. Now you will understand that why, instead of using hash map to store just the values, why am I storing the pointer of that particular value. Now it will come to your senses. Okay, what I'm suggesting is that currently, remember, we need to keep track of two items. Number one item is what is the least recently used item. Number two item is the moment we use the get operation, we also need to keep track of what is the most recently used item. And there is going to be all of these bunch of different elements that fall between each other. But basically, the moment we are accessing any particular element, that becomes most recently used element. The moment we want to kick out any element, we kick it out from the least recently used element, which means we need a data structure where we can actually work on both sides of the queue to either enter the value or remove the value, and we need to do it in fast and efficient manner. And for that, the very simple thing is one of the most basic data structure, that is a linked list. But this is not a simple linked list. We are actually going to use a doubly linked list. And how this doubly linked list is going to help us to solve all of this issues, let's think about it. So now let's understand that suppose currently this is our hash map where we are storing all the values. Let's assume that this is our doubly linked list. Okay, and currently for our hash map, once again the capacity is 3. Now why are we using pointer instead of actually using the value? That will come to your mind very quickly. So let me just add few values. Okay, number 1, number 2 and number 3, these are the 3 values. And let's assume that for these 3 values, I'm marking as pointer 1, pointer 2 and pointer 3 as the 3 nodes that contain all the information. Now once again, I'm marking these 3 nodes over here, pointer 1, pointer 2 and pointer 3. Okay, and currently inside our doubly linked list as well, because we added values sequentially in the same sequence, we are going to have, okay, so this is our least recently used item and this is our most recently used item. Okay, now the very first item we have in the least recently used is going to be pointer 1 or the value 1 or the node 1. Okay, you can think of it, all of these things. So basically value 1 and 1. Same way, second is going to be P2, basically value number 2 and 2. And third one is going to be pointer 3, that is going to be 3 and 3. Now the thing is, where this pointer would come into useful is when we have to change the positions, because same logic will come to your mind that, hey, in the queue, why we were not using queue? Because in order to find any particular element, we had to jump through all of these places and that was causing big O (n) time. But in this case, we have the additional benefit that because we have the hash map, based on any particular key location, we can directly find that where is that particular value is located inside the existing queue. And all we are concerned about is to storing least recently used and most recently used values. So now we are going to start manipulating these values. So let me just clean this up a bit, and now we are going to start working our magic. Now let's assume that currently we need to add value number 4 in this case. Okay, so we are going to add value number 4 over here. Once again, now the logic is quite simple. We are because least recently used value, we already know that is P1. We are simply going to get rid of it. But now what we need to do is we simply need to say that whatever the value, that is because we removed the least recently used value, which means we removed the head of the existing linked list. So the moment we remove the head of the existing linked list, automatically the second value becomes the least recently used value. So now we have P2, that is least recently used currently. Next value is going to be P3, and then we are going to have value number P4 as the most recently used value. So let me update those values. So P3 and P4. Okay, currently we have these values associated, and subsequently we have pointers that point to those correct values. Now let's assume that for some reason we decide to access value number 3. Okay, we create another operation, that is get operation, get 3. Now the moment I do get 3 operation, suddenly now even though 3 is in the middle, what I will do, in order to do the get 3 operation, first I'll do that whether key number 3 exists inside the hash map or not. Yes, it exists. If it exists, all I need to do is I need to fetch the value of the 3, so I can simply return that. But at the same time, I can go to this pointer's location and I can say that, hey, whatever your pointer location is, now you need to jump to the head of the to the tail of the linked list, because currently now you are the most recently used value, and that can happen in big O of one time because it's a doubly linked list. So we are just going to use the same logic, and now in this case P4 becomes our second least recently used value, and P3 becomes most recently used value, and we are able to find this value because we are using pointer. So we are avoiding the scenario where we have to iterate over every single value inside the linked list and saving up on the time. Okay, now for the same scenario, let's assume that instead of this, now we are trying to add value number 5. Okay, so if I want to add value number 5, I need to kick out least recently used value. I already know least recently used value is P2, and in the P2, because I'm storing the whole node, it contains the value as 2 and 2. So all I need to do is that whatever the head position has the node, I just need to go to that key position, and the moment I go to the key position, I simply delete or remove that key. So now I'll get rid of this 2. Okay, I'll also get rid of this 2 over here. Now my least recently used is automatically going to adjust. That is going to be P4 and P3, and now there is going to be P5 as the most recently used because I can easily manage that. And in this scenario, now once again I need to enter the value 5 and P5 over here, and that's it. This is the whole logic of least recently used test case scenario, and you can add as many nodes as you want, the logic will remain same. And now let's try to understand time and space complexity. Time complexity, pretty simple to calculate. We are using, okay, so let's assume for capacity it doesn't matter because it is like we are just allocating some value, so this does not take part in the time and space complexity scenario. Now let's assume for the get operation. So what are we doing for the get operation? If we want to get any particular value, get 3, let's assume, we are going to check that whether this key exists inside the hash map or not. Yes, it exists. Now we can easily fetch the value from the pointer, there is no issue with that, but at the same time we will have to mark 3 as the most recently used value, and that can also be done in big O of one time, and this hash map can also operate in big O of one time. So get operation now works in big O of one time. Awesome. Now let's take care of the put scenario. Once again, for the put scenario, we will also have to repeat the same thing. Basically, let's assume that now we have this value number 6 we need to add. We realize that the capacity is full. So because capacity is full, we are going to go to the hash map first, take whatever the head position is, find what is the key associated with that because it stores key and value both. And this key contains the value number 4. So go to value number 4, kick value number 4 out, add value number 6 over here, and that's it. You solve the problem. And now this operation also happens in big O of one time. So this is the whole approach. Now let me quickly go over the code. Now let's look at the code for our problem LRU Cache. So first thing we are going to do is we are going to create a static class node where we are going to store the definition of the node that contains the values key and value. On top of it, we are going to keep track of the previous node and the next node for any particular node, and this aligns with our doubly linked list concept. We also have a simple constructor to store the value of key and value that comes in as the put method. Now we have some variables that we need to define. So first variable is the capacity. Next one is a hash map. Now inside the hash map, as a key, we are going to store the integer value of the node, but as its subsequent value, we are actually storing the pointer of the node and we are pointing it to the element that we needs to put in. This comes along as we understood during the explanation. And then we have two dummy nodes that are head and tail, where head is going to keep track of the most recently used and tail is going to keep track of the least recently used element, and then we can simply manipulate those values. Next thing is this is the method in order to instantiate the capacity. So it is a very simple method. All we are doing is just creating a hash map of the same size. On top of it, if we have to, let's understand the logic for the get method, in which we are given the key as an input. So first thing we are going to check is whether this key exists in the hash inside the hash map or not. This we can do it in big O of one time. If it doesn't exist, we can simply return -1. If it do exist, we can simply return the node value. That is perfectly fine. But before that, we need to create, or we need to put it as the most recently used value. So we need, what we are going to do is we are going to instantiate a temporary node that is going to be associated with the given key. And for that we are going to remove that from our doubly linked list, and we are going to put its position as the at the head value. And both remove and insert at head values, I have created helper method for those. So this is the remove method and this is the insert at the head method. These are just very basic pointer manipulations inside our existing linked list. Now going back to our get method, now in this scenario, and in the end, once this node has been mentioned as the most recently used node, then we simply return the node's value. So that fulfills our get method. Next, let's understand the logic for the put method, that is slightly more complicated. We are given the two input values for the node that we need to put in. Now, first thing we are going to do is we are going to check that whether this existing key already exists, and if it does, we simply need to update the node associated with that. So if it exists, all we need to do is just assign a temporary node. Whatever the value of the new node is, assign that to the existing value for our existing hash map key. And then we need to remove that node pointer and insert it at the head, because now this becomes the most recently used value. If that is not the case and we need to enter the new value all by itself, so first we are going to check that whether we are running out of capacity or not. If we are running out of the capacity, we are simply going to remove the last element that exists at the tail. So that we can simply do it in big of one time, because we can already always find that what is the value associated or at the least recently used using our doubly linked list, and then we can simply remove that value. And then we can simply add a new, in either case, now we simply need to add a new node inside our existing hash map. And after adding this new node, we need to add this new node at the head, because now this becomes the most recently used value. So I know that this code looks like a little bit complicated, but overall the simple logic remains the same. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions in terms of time complexity, and also great in terms of space complexity. So once again, I will be posting this code inside the GitHub repository that we have, and you can check it out from there. Let me know in the comments, what do you think about this video? Do you think is there anything else I could have done to make it better? I'm always open for the feedback. So thank you so much for that. Until then, take care. So finally, we are at the last topic, that is bit manipulation or binary related data structure and algorithm problems. Now I'm going to be very honest with you. You can skip this topic completely if you want to, because the likelihood of you being asked these questions is very low. But that does not mean that someone might not ask. And the problem that this topic solves is actually the fundamentals of computer science and somewhat electrical and EC engineering and communication. So it's like it goes across multiple spectrum of computer science related engineering. Also, we learn deeper into like how basic electronics work. So different gates, AND gate, OR gate, NAND gate, all the different gates, how do they work? In terms of introduction, all you need to understand is what is the different truth table for each of those basic gates. So I'll be displaying that on the screen right now. You can take a screenshot and just keep it a copy for yourself. It's very simple to understand, nothing more complicated. On top of it, we are going to be solving the most asked and most popular bit manipulation questions, even though this topic is not very popular. So if you just solve these 7 problems, you would be done with this topic, that's for sure. Now I apologize for the video quality, because this was recorded when I was just learning how to record stuff, so they are not extremely great audio and things like that. So I apologize in advance, but again, the core concept is still very much viable and helpful to a lot of people. And I know we are almost done to the finish line, so I hope you have the patience to complete this. So the LeetCode problem we are going to solve now is called single number. We can see that this one is a LeetCode easy problem and also one of the most liked problems on LeetCode. Basically, we are given a non-empty array called nums. Now, every single element in this array appears twice except for this one element, and we need to find that single element that is only present just once. Now, the important thing is we need to be able to find the solution in linear runtime, so big O and runtime complexity, and using constant extra space, so using big O of 1 extra space. Now let's try to first understand a couple of examples. Suppose we are given an input array like this, then we can see that 1 appears twice and 2 appears only once. So we need to find the single number, so we can return 2 as the answer. Same way over here, if there are more entries, still we can see that 2 appears twice, 1 appear twice, 3 appear twice, and 4 appear twice. 7 only appear once, so we need to return 7 as the answer. So basically this is the problem statement. Now let's approach this problem in multiple ways. The brute force approach is going to be quite straightforward. So brute force approach is going to be quite straightforward. We first take a look at the number and then iterate over entire array to find that whether another copy of this number exists or not, and we can keep on repeating the same process over and over. So basically this is an inefficient approach, and this would yield big O of n square time complexity in the worst case scenario. Next approach is a slightly simpler approach. We can basically sort the given input array. We can find that then we can just iterate once and find the value that is only repeated just once. So this approach would be better than the brute force, but this would still run in big O of log n time complexity, so this is still not valid for us. Next approach is that we can actually use a hash map to solve this problem, hash map or hash set, and where we can just simply iterate over this given input and try to keep on adding all the entries inside the hash map. We can keep track of the frequency occurrence, and in the end we would find that the frequency for 4 is only 1, but that is also still going to run in big O of n time, but the space complexity is also going to be big O of n, so that is also not acceptable. So that brings us to the last solution we have. And now honestly, you are not expected to come up with this solution unless you are like a complete geek or a complete nerd, but let me talk about the solution. Basically we are going to use something called XOR gate in between any two numbers. Now you know that this is a bit manipulation technique, and basically we have gates like AND gate, OR gate, XOR gate, and things like that. So XOR is a very popular way whenever you are dealing with multiple entries that cancel out each other. And how it works is that this is the truth table for the XOR gate. So let's say that we are given X and Y as two separate numbers. So if both are basically 0, then we simply return 0 as the answer. If both are 1, then also we return 0 as the answer. So we only return the remaining answer if both values are not same. So if 1 is 0 and 1 is 1, so then in that case we basically return the appropriate value. Now this XOR logic applies to all the numbers as well. If we do 4 XOR with 4, then also the answer is going to be 0 because both values are same. There is also a logic that if we do 4, then do an XOR with 5, then do an XOR with 4, then once again these 4 are going to cancel out each other and we are going to end up with a result called 5. And this you can try to understand based on the X or Y truth table for numbers greater than 4. So basically I'm not going to write down the whole solution, but you can trust me on this, that this solution works as expected. And if we have, let's say that 10 different entries, let's say that A, then once again XOR of A, then once again XOR of X, then once again XOR of X, then once again XOR of B plus XOR of B, and then lastly if we have plus XOR of C. In this case all of this are going to cancel out each other and only we are going to be left with value C. And this is exactly what we are going to do in this problem. That suppose you given our nums array, the values are 1 2 3 and then 1 2 3 and then value is 4. So basically we would have a result value that is continuously going to store the values of the XOR to its previous value. And so in the result value, first we are going to do 1 XOR 2, same way then we are going to do that plus XOR 3, and if we continues to do that, eventually the repeated values are going to cancel out each other and we would only be left with the only number that is not repeated. So in this case, in the result, we would find the value 4 as the answer. And basically this is the whole solution. If we see time and space complexity, in this case, the time complexity is going to be big O of n, and the space complexity is going to be big O of 1, because we are not using any additional space apart from using a couple of variables. So this is relatively easy and simple approach to solve this problem. And once again, this is a pretty popular bit manipulation problem. So now let's quickly see the coding solution. So the coding solution is actually the smallest that I have done so far. Basically, we just initialize a variable called result, and then we iterate over every single nums that is currently present inside the nums array, and we simply do XOR operation with the existing result value. So basically all the elements that are duplicates or multiple copies of each other would cancel each other out, and only the single number would have left inside our result variable, so which we can return as the answer. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code beats 99.983%. So pretty much all the other solutions out there, which is exceptionally fast. It is also really good in terms of time space complexity as well. And once again, the coding solution is present on our GitHub repository. So this is the GitHub repository that I'm talking about. Now you can notice that on this repository, I have solved hundreds of LeetCode problems. These are the most popular and most important LeetCode problems of all time. You would be able to find solutions for each one of them. So all you can do is just simply search for it and you should be able to find it. Now these problems are pretty straightforward, and if you want to see that how popular any particular question is, I have created this Google sheet, where in the Google sheet I have created two sheets. First one is something I created by myself. I went over LeetCode Premium and went that how popular, how liked, and how important a question was based on how many times it was asked at different companies, and then I basically sorted them through different topics and different difficulty level, which are color coded. Then we have another list for LeetCode 150, which is also pretty popular list out there, and I have been solving all of these problems as well. So if you are in the process of preparing for yourself for technical interviews, yeah, these two can be a good resources at your disposal, and I hope you find it useful. Links for both of them are presented at the description of this video. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, number of one bits. And this is a bit manipulation problem. I know a lot of people don't like it, but it's really simple to understand. So the problem statement is pretty simple. We just need to check that in any given integer, if we represent it in binary form, how many times the one value is being repeated. So in this given example, we are given a number like this, n is equal to 1011, which is the binary representation of the decimal value 11. That we need to check that how many times this one is repeated in the given integer, and clearly over here we can see that the one is being repeated 3 times, and which is the answer of this problem. And notice that the number is represented quite long because it is showing that all the 32 bits of any integer, and all the input types would be of 32 bit, and we need to find that how many times one exists. So the first approach we are going to take is quite simple, and we are going to use a binary operator AND. Now let me show the table for AND binary operator for any given two values. We can have four possible combinations, and A and B means if the value of A and B both are 1, in only that scenario we are going to consider the value of A and B as 1. Otherwise, if there exists any single 0 or both values are 0, we would just simply put the values as 0. Using this logic, we can solve this problem really fast, and the most basic approach is we would simply run a loop 32 times, and every single time we are going to compare each element with 1 and see that if we AND the value that exists at any given location with our value 1, and if the answer is 1, we do counter plus, and after running the loop for 32, all the 32 bits, we would just simply return the value of our counter. Let me show you by an example what I'm trying to say. Suppose the input we have is 13. If we represent it in binary, it would look like, and we would have 28 zeros and the prefix. Now we will create a value, just any random variable, and we would give it as value number 1, and we will run a loop from 0 to 32, and inside the loop, for every single value we would compare that whether this 1, we would compare it with the rightmost element in our given input array, and we would do an AND operation between these two values, and we would have a counter that we initially set it up as 0, and whenever we find that the answer of these two AND variables is actually 1, we would simply increase the counter. So for the rightmost position, we would increase the value of our counter, so counter would become 1, and after we are done with this condition, we would simply do a left shift for this random operator for the given input. So now 1 would be shifted one position to the left, and we would again do the same operation. So this time we will do an AND operation between this 0 and 1, and the value of AND operation would be 0. So we won't update the counter, and again we would do a left shift for this one element. And again we would do an AND operation. The value we would get is 1, which means we need to update our counter. So counter becomes 2, and again we would shift our element. We do an AND operation again the value still remains 1, so we update our counter again, and we update the counter to 3, and then we would subsequently update the value of this random character to 1 bit to the left. And now notice that all the remaining bits are 0, so the AND operation will always equal to 0, so we won't update the count, and at the end of the loop we can simply return whatever value of count we found as our answer. Now this approach works perfectly fine, and this approach actually runs in big O of 1 time, because we only have to run the loop 32 times, which is a minimal amount of work that we have to do, and the answer would always be constant. So this is in itself pretty neat solution, but let's see if we can go one step further and we can reduce this loop counter time to less than 32. In order for us to understand the optimal solution, let's first take an example. So, say we are given a value n equals to 36. Now let's represent this value in binary, because we know that binary works like 2 to the power 5. And if we do the summation of these values in decimal terms, uh, this would become 4, and this would become 32. So 32 plus 4 becomes 36. Now, the intuition behind this solution is that if we take one value lesser than 36, let's say 35, and if we represent this value in binary terms, the binary representation looks like, and notice that the first one that we encountered on our original input, the one value lesser than that has the exact opposite in terms of number of ones up until this point. That if we do a AND operation between these two values, the value we would get is like this. So notice that this one has already disappeared in the AND result of these two values. And if we repeat the same process, so now this value that we got in binary, the value is actually 32. And again, if we repeat this same operation, that we do an AND between the number by itself with one value lesser than that, we would gain a result like so. First, let's represent the value number 31 in binary. And now if we do an AND operation between these two values, the answer we would get is all zeros, which exactly means that we would only run the loop the number of times one we have in our original given input. Because over here we only had 2 1 in the input, so during the first iteration of our loop we got rid of this first one, and we can see it over here. And during the second AND operation we got rid of the second one as well, and we got the answer as all zeros. So at the beginning, if we create a variable count and we originally set it up to 0, and every time in the given loop, if we just go through the loop and the value of the value of current n is not equal to 0, we just simply increase the value of count to 1. So which means that during this first iteration the value of count would be 1, and during the second iteration the value of count would be 2. And after that we found that the value of n is actually equal to 0. So we can simply break out of the loop, and when we break out of the loop we would return whatever the value of count we had found. And in this case the value of count we found is actually 2. And this solution would work perfectly fine, and this would be our optimal solution. The time complexity for this solution is also big O of 1, which is a constant time. But the thing is, the number of loop iterations that we have to go through would only be equivalent to whatever the value of 1 we are given in the original input array, and we don't have to run the loop 32 times like the previous solution. So we are actually in our constant time solution, we are also saving a lot of time, and this would be the fastest solution we can reach into. And in terms of space complexity, we are not using any additional space, so complexity would also be constant time. And now let's move on to coding. Thank you. So first of all, we will create a variable for count and set it up to 0. Now we simply run a loop. We will run this loop till the number is not equal to 0. And with every iteration, we will increase the value of count, and we will simply do n equal to n and n minus 1. At the end of the loop, we just return count. Looks like our solution is working. Let's try to submit the code. And yeah, submission works as expected. It's pretty efficient and neat. And let me know what do you think about this video. And if you have any more suggestions, feel free to reach out to me in the comments, and I can address them. Thank you. Bye bye. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do a lead code easy problem, reverse bits, and this has something to do with bit manipulation. So let's understand the problem statement. Basically, we are given a 32-bit unsigned integer and we need to reverse all the bits in it. Let's consider it by an example. Suppose the value we are given n is equal to 5 And if we represent it in binary, the binary representation would be, and since the given input is 32-bit, all the other bits would be 0. Now we just need to return a new element, reverse, that looks like the exact reversal of this binary value. So this would the so the rightmost bit on the original input would be the leftmost bit on our new variable. So the value should look like 1, 0, 1, and all the remaining zeros, because this one is also 32-bit. So basically the rightmost 0 would be at leftmost position in our new variable, and we need to return this. The problem statement is really easy to understand, and let's see that what could be the approaches we can take to solve this. In order to solve this problem, we are going to use bit manipulation, and specifically we are going to use two bit manipulation operators. First one is AND operator, and second one is OR operator. And let me show you by truth table what each of these operations represent, and these are the symbols to represent them. So the possible value for A and B we could have is, so for A and B, if both the values are 1, then only we consider A and B as 1. Otherwise, if there exists a single 0, we will keep their value as 0. So this would be the table for A and B. And in A or B, if there exists a single 1, we would consider the value for A or B to be 1. So if both are 0, then only we would have A or B as 0. Otherwise, the value would always be 1. Now let me show you that how can, using these two operators, we can calculate our solution. We are only given one thing over here, the input parameter n. And suppose our n is 5, so the values would be like this. The new variable that we are trying to determine, reverse, is actually unknown to us, and that will have all the values that are in reverse order for the given n. And we know one thing, that all the values in given n is actually 32 bits, not more than that. So the first intuition is that if we run a loop 32 times, and every single time we take whatever element is present in n, and if we put it in our reverse variable, so whatever element we have present in our n, we put it in the reverse variable, and then we start shifting the reverse variable one step to the left side. So at the end of the loop, our reverse variable would be exact reverse of whatever value that is present in the given n. So let's determine that what would be our algorithm. Initial value for our reverse parameter would be 0. So the entire value would be, and when I say 0, I mean that all the 32 bits would be 0 for the reverse element. Now, at the beginning of, and we would run a loop from I equals to 0 to I equals to 32. And at the beginning of our loop, we would have a condition that every time we are going to left shift the value of reverse parameter to 1 bit. So at the end, we would have rotated any value that is present over here. We would have rotated it to 32 times, and it would end up on the leftmost position. But after the rotation of the value, so first of all, so inside the loop, first of all, we will rotate 1 bit to the left, and we would represent it with this symbol. Next, what we are going to do is, somehow we will have to get whatever value of n is present. We need to copy that value for that particular element and somehow put it on the subsequent position at our reverse order. So how can we do it? And we know, based on our and or operators, so at any given moment the possible value for n would be either 0 or 1,
and we want to copy whatever value of n exists in our reverse parameter, a reverse variable. So if we do an n and one operation, then this would specify and this would provide us with whatever value of n there exists. So suppose if the value of n exists as 0, and if we do an AND operation with 0 and 1, the result we would get is 0. If the value of n exists as 1, and if we do an operation 1 and 1, the value we would get is 1. So this is how we can get the exact value of 1 that is present, exact value of n that is present. And once we calculate this value, that n and 1, we need to put this value in our reverse variable. But the thing is, in our reverse variable, all the values are initially set it up to 0. So all the values are 0, and the potential value of n and 1 operation could be either 0 or it could be 1. And whatever we get over here, we need to transfer it to our reverse variable. And the way we can do it is, if we simply do whatever element is present at our reverse variable, and if we do an OR operation with whatever the answer we get from n and 1, we would be able to put the exact value that was present at n at any given moment. So the operation that we are going to do is, current value of reverse we have with, and we would be ORing that with n and 1. And suppose initially, so if the value of n is equal to 0, the answer after this operation would become 0, and we know that the value of reverse is initially set to 0. So we would be doing 0 or 0, and the answer we would get is 0, and we would shift it to our reverse. And at every single iteration, we are going to do a left shift on the reverse parameter. So whatever value we set up at the first, at the end of the 32 iterations, it would end up over here. And so we are taking care of the value of reverse parameter by shifting them one parameter left. But we also need to shift the values of given n one parameter, one step, one bit to the right side, because we need to calculate every single value of n. So suppose the value of n is like 0, 1, and then bunch of zeros, and then 1. And this comes out to be the whole 32 bits. We need to calculate every single value of n that is present, and we need to put it in the reverse order. So at the beginning of our loop, we will calculate this value. We would put it in our reverse loop, and once that is done, this value would be stored over here initially in our reverse variable. But we know that we are doing a left shift operation on our reverse variable. So eventually the value will keep on transporting on the left side, and it would end up at the first position, which is what we want. But the thing is, on the n way, on the given input, we need to do a right shift operation. So we keep on eliminating the values that we have already calculated, and we are eventually, when we come to the end of the 32nd bit, we would come to this value. So 31st bit would become this value, and this value would be entered at the second position, reverse variable. So I hope this makes things clear. I know it's a little bit tricky to understand, but once you will do an example by yourself with this expression, that reverse, the value of reverse is actually the reverse we currently have, or n and 1. And after this, we would be able to copy whatever value of n we have to our reverse for that particular bit. And then it's just a matter of shifting the values of reverse on the left side and shifting the value of n on the right side. And at the end of the loop, we can simply return the value of reverse variable, and this would be our answer. So now let's calculate the time complexity for this approach. Basically, the time complexity would be big O of 1, because the only work we need to do is we need to run a for loop for 32 times, and that can be done in constant time. And even for the space complexity, we can complete the entire iteration in just constant time, because we are not using any additional data. We are just using couple of parameters to store some values, and this would be a very fast solution, and it's really simple to understand. But the thing is, we need to come up with a little bit of logic, and we need to have a little bit of understanding of the bit manipulation operators. And now let's move on to code. So first of all, we will create a variable reverse and initialize it to 0. Now we will run a for loop. Inside the for loop, we will first of all do a left shift on reverse. Then we will apply our logic to calculate the value of n to reverse. So we will do reverse or with n and 1. And now we just do a right shift 1 bit for the variable n. And after the loop, we simply return the value of reverse. Let's try to run this code. Yeah, looks like our solution is working. Let's try to submit it. And yeah, our submission works actually 100% faster than all the other submissions, but this is not true. This is because the solution runs in the constant time. And hope you like the video. Let me know what kind of videos you want me to do next, and if you have any suggestions regarding my videos, feel free to let me know so I can improve upon them. Our aim is to clear the FAANG, and we are not going to stop till we clear FAANG interviews. Thank you. Bye. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, missing number, and let's understand the problem statement. Basically, we are given an array of numbers containing n distinct numbers in the range of 0 to n, and we need to return that there is one number that is missing, and we need to return the missing number. So if we take the first example, the range we are given is 0, 1, 2, and 3. But when we see the actual input of nums, in the input we only have 3, 0, and 1. That if we start cancelling out the numbers that are present in nums and also present in our given range, 0 can be cancelled out, 1 can be cancelled out, and 3 also can be cancelled out. But the value number 2 is present in our range but not in the given input. So we would simply return the value 2 as not being present, and 2 being the missing number. So there can be multiple approaches on how we can solve this problem. Okay, and we would try to keep in mind with this follow-up as well, and we will try to solve this problem in big O of 1 space complexity and big O of n runtime complexity. So the first two trivial approaches we have in our mind is first one, that if we sort the input array, we can we can solve this problem easily. But the issue with the sorting approach would be that the runtime complexity would be n log n, because we need to do sorting first, and that takes n log n time. Second approach is to use a hash set, and we would keep on storing all the values of nums input in the hash set, and then we would iterate with the range loop and go over hash set to see if the value exists in the hash set or not, and eventually we would find a value that exists in range but does not exist in hash set, and that would be our solution. And the good thing about hash set approach is that runtime complexity would be big O of n, and but the issue comes for the space complexity, and the space complexity for this approach would also be big O of n, which is not what we want. So let's see what would be the optimal solution, and I would be showing two optimal solutions in this coding problem. So our first optimal approach is actually pretty simple. Basically, we are given two items. First one is range, that is from 0 all the way up to n. And second one is nums input array, where the values are 0 all the way up to n, but one of the value is missing, and we need to find this missing value. So the most simple approach to do is we run a for loop on this range parameter, and for every single value in the given input from 0 all the way up to n, we simply do an addition of all the values. We store the result of all the elements in the range in a parameter called range sum, and we would find some value over here. And again, we repeat the same process, but this time for nums. So we do the sum of all the elements in the num with another for loop. We store the result of sum in a new parameter called num sum. You can put any name. This is just randomly something for taking the name. And then when we do a difference between range sum and this number sum, the difference would actually be the missing number. And this way we would be able to find the solution pretty quickly. Let's take it by a quick example. So clearly we can see that this value 1 is missing. So the sum of all the elements over here would be 10, and the sum of all the elements over here would be 9. So if we simply do 10 minus 9, we would find the value 1, which is the missing number. And this solution is pretty simple to do, and the time complexity would be big O of n, because we are just simply running two for loops separately. So we are not doing much work in terms of time complexity. And for the space complexity, other than storing the value for just couple of parameters, we are not consuming any additional space. So the space complexity would be constant. And this is an optimal approach that we are asked as a follow-up in our original input. For the second optimal solution, we are going to use bit manipulation. And specifically, we are going to use XOR operator. So if you don't know what XOR operator is, let me give you a quick tutorial on what each value is being represented when it gets XORed with some other value. We can only have four possible values for A and B because all the values in computer system are represented as binaries. Now in the XOR, if both values are 0, we consider the value as 0. If any one value is 1, we consider the A XOR B as 1. Same goes for this one. And if both values are 1, we again consider A XOR B as 0. Now, let's see that using this logic, how can we find the missing number? So, now consider this property that for any given value n, if we XOR n with itself, the answer we would get is actually 0. And let me show you what I mean by that. Suppose our current n is actually 6. And now let's represent this in binary. And now let's try to do n XOR n. And this is the symbol for XOR in in programming language. So if we do the result, uh, 0 0 is 0, 1 1 is 0, and 1 1 is again 0. So if we XOR two values together, the answer we get is actually 0. But if we XOR So suppose if we XOR the values like 6 XOR 6 XOR 3, the answer we would get is actually the value by itself. So because 6 XOR 6 would be 0. And now let's try to XOR 3 with this given 0. So the binary representation for 3 is equal to 0, 1, 1. And now when we try to XOR these two values, 0 and 3, the answer we would get is 0, 1, 1, which again means 3, the number that we XORed 0 with. And we also notice one more additional property over here, that whenever we XOR two values, so 6 XOR 6 XOR 3 gives the result as 3. Also, if we change the order and if we put any order like 3 XOR 6 XOR 6, this will also result in 3. And if we do like 6 XOR 3 XOR 6, this will also result in the value 3. Because order doesn't matter. If we are XORing two values by itself, both are going to eliminate themselves and their answer would be 0. So whatever is remaining would be the answer of this one. And we can repeat this for whatever number of times you want. So we can, if we do something like uh, 2 XOR 3 XOR 2 XOR 6 XOR 6 XOR 7 XOR 7. If we run this entire thing, still the answer after this would be 3, because notice that over here 2 cancels itself, 6 cancels itself, and 7 cancels itself, and only 3 is going to be remained. So now since we have established all of this, let's try to see that how can this be useful for us in this given problem. The input for our given problem is actually we are given range and we are given the input number. So suppose for an example, the range we have is 0 to 4. So 0, 1, 2, 3. Let's consider it 0 to 3. And the input parameters we have is suppose 1, 3, and 0. So notice that number 2 is missing. Now, if we were to use this XOR logic, that if we XOR all the values in the range with all the values in the nums, we would get something like this: 0 XOR 1 XOR 2 XOR 3 for this range portion. And if we XOR this with the nums input, we will get 1 XOR 3 XOR 0. And if we combine both of these, basically all the values that are same would be eliminated and would be turned to 0. So this 0 would cancel out this 0, this 1 would cancel out this 1, and this 3 would cancel out this 3. And notice that right over here we just determine that the order in which XOR happens does not matter. Everything is not right next to each other, still they will cancel out each other, and at the end we are only going to be remained with the value that is not at all present in this nums input. So in the nums input we don't have the value number 2 present, so the result of range XOR nums would actually give us the value 2. And the result 2, we can simply return it, and this would be our solution. So this is a very neat, very unique solution, and because we have the knowledge of XOR, we are able to come up to this result. And if we use this in any interview, this clearly shows that you have very sound knowledge of computer concepts, and you know how to apply them when they seem fit. This would definitely give you a very sharp edge over all the other candidates. And let's do the complexity analysis. So for the time complexity, we are actually doing everything in just the single loop, for one loop for range and one loop for nums. So the time complexity would actually be big O of n, and the space complexity would actually be big O of 1, because we are not using any additional space. So this would be the most optimal solution, and this is what the problem is asking us to find. Now I showed two optimal solutions, but first optimal solution is very trivial to understand. So I'm not going to code it up, and I'm only going to code up this XOR solution. So we will first of all create a variable XOR and we initialize it to 0. You can give any name. And now we will run a for loop starting from the range. So int I equal to 0 to I is less than or equal to nums dot length I plus plus. And every time we will XOR the number with itself. So now again we will run another loop, and this time we will run it for the given input array. Notice that we are only using I is less than number of length, and over here we are using less than or equal to, because in the range we have one value more than whatever the length of number is. And again we repeat the same operation, XOR with the value in the given input array. And now we will simply return whatever we found in XOR, that this would be our missing value. Let's try to run this code. Looks like our code is running. Let's try to submit it. And yeah, our solution works perfectly fine, and it's actually pretty fast and pretty efficient. And hope you like this video. I'll be posting the solution in the comments, and let me know if you have any suggestions for the videos. Yeah, let's clear FAANG together. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code medium problem, sum of two integers. So let's understand the problem statement. Basically, we are given two elements a and b, and we need to return the sum of two integers without using the plus or minus operator. And the problem statement is really simple. Basically, we are given two values a and b, and we need to return the sum of a plus b equals to in this case 3, but without using the plus operator. So let's see how can we do that. We are going to use 2-bit manipulation operators. First one is something called XOR or exclusive OR, and second one is AND. So let me show you what each of them does and what does it mean. So we will consider a table like this, where we are given the values of A and B and the value of A XOR B. Now these are binary elements, so the only possible values we can have for A and B is 0 and 1, and we can have four possibilities. Either both are 0 0, 0 1, 1 0, or 1 1. And the answer for A XOR B would be 0 0 is 0, 0 1 would become 1, 1 0 would also become 1, and if both are 1, we would again consider it as 0. So this is just something that we keep in our mind, and we will use it further down in our equation. Now let's see what would be the table for A and B. Now as the name suggests, A and B, we only set the value as 1 if both entries are 1. Otherwise, if there is any single 0 present, we get the answer of A and B as 0. And now let's see how can we use these two operators to find the sum of any two values for our given problem. So suppose we are given two values like this, a equals to 5 and B equals to 3. So the sum of A plus B, as we know, is 8. And let's see how these values are represented in binary. So A would be represented as 1, 0, 1, and B would be represented as 0, 1, 1. Because in binary operator, the value of any element is actually done as 2 of 0, 2 of 1, 2 of 2. So this becomes 4 and this becomes 1. So 4 plus 1 equals to 5. And same over here, this is 2 and this is 1. So 2 plus 1 equals to 3. Okay, now let's try to do a summation of these two values. So 1 plus 1, we cannot do 2 over here because this is a binary representation. So we will do as 0 and we would have 1 as carry that we carry on towards the left value, and again we get 1 plus 1. So again the value becomes 0 and we have a carry that we need to consider on the left side. If we take the carry again, we get the value 0 and we will have a carry over here, and we don't have any value over here, so we can just consider this as 0, 0. So with the carry, the value becomes 1. And if we do the if we find the binary value for this one, this is actually 2 of 0, 2 of 1, 2 of 2, and 2 of the power 3. So the value 2 of the power 3 is actually 8, and which is our answer. So if we do the simple addition of binary values, we can also get the answer as 8. But the problem over here is that we should not be using the plus operator, so we cannot just simply add these two values. So the longer route we can take is we can try to do A X or B first, and then we would do A and B, and we would move the values to one point left. This is simply what we are going to do for the given elements until the point where we find that the values of A and B uh, as 0. So this is the broader idea of our algorithm, and let's see what I mean by that. So the value of current A is 1, 0, 1, and B is 0, 1, 1. So let's try to do A XOR B. This is the symbol for XOR in computer language. So we will simply use this one, and let's see what the value becomes. So we know that 1, 1 is 0, 0, 1 is 1, and 1, 0 is also 1. Now we need to do the operation of A and B. We are doing this operation to find the carry value with A and B values. And because we are finding the carry values, we know that whenever we have a carry at any location, we need to move it one step on the left side. So we will again use the same logic that we will use A and B to find the carry value, and we would move it one step on the left side. So let's see what the values would be for A and B. So basically we have 1, 1 over here. So that value would become 1. And notice that we are writing 1 over here and not over here because we are shifting the element on one step towards the left side. So we have 1, 1 as 1. Next values we have is 1, 0, sorry, 0, 1. And we set it up as 0, and again we have 1, 0, so again we set it up as 0, and because we don't have any value over here, we shifted one value on the left. We can consider the value as 0 over here. Now we have calculated the results for A XOR B and A and B, and we have moved them towards the one step on the left. In our algorithm, this would become our new A and this would become our new B, and we would have a loop that until we get a value of B that is not 0, we would continue with this operation, and let's see where we will get. So now the values for A and B would be, A would become 1 1 0, and B would become 0 0 1 0. And now let's repeat the operations again. So first we will do A XOR B, which gives us 0. 1 1 becomes 0, and we will have a carry, but we will consider it later. 1 0 becomes 1, and 0 becomes 0. Now let's do A and B and shift it to 1 bit on the left side. And because we have to move it 1 bit on the left side, we will start it over here. So 0 0 becomes 0, 1 1 becomes 1, 1 0 becomes 0, and 0 becomes 0. And because we don't have any value on the rightmost part, we will consider it as 0. So again, we will assign the values as A and as B. And we notice that B is still not 0. So we will continue with our operations and we will continue with our loop. So again, let's repeat the same operation. So A mod B becomes 0, 0, again 0, again 0, and 0. So all zeros we are getting as A XOR B. And now A and B shifted one element on the left side becomes, we start one element from the rightmost element. So 0, again 0 for these two, 1 1 becomes 1, 0 0 again becomes 0, and we have one blank element on the rightmost bit, so we can consider it as 0. This becomes our new A and this becomes our new B. We notice that B is still not 0, so let's repeat the operation. And now we are going to do A XOR B equals to 0 0 0 1 0, and A and B shifted one bit on the left side. So notice that on this A value we don't have any ones, which means that under no circumstances we can have this A and B where we get one answer, because A is always 0. So same thing applies over here, and basically this value would become all zeros, 0 0 0 0 0. And now again we assign our values. So this becomes A and this becomes B. And notice that in this scenario B is completely 0. So we can break out of the loop, and when we break out of the loop, we can simply return the value of A. So the value of A we have found in this scenario is 0 1 0 0 0. And this is a binary number. If we were to convert it to decimal value, we can understand this as 2 of 0, 2 of 1, 2 of 2, 2 of 3, 2 raised to 3, and 2 raised to 4. So all of these values are 0, so we don't consider them. This one is 2 cube, which is 8. So we can return A as 8, and this would be our final answer. And if we see the original two values in our request, basically we had the two integers A equals to 5 and 3, and we get our answer perfectly defined over here, and we reach to this answer without using the plus operator. So this would be our solution. And now let's calculate the time complexity for the given problem. So basically, if we see the given input over here, we have a constraint that all the values are between -1000 and +1000, which means that essentially we can calculate the time in a constant time complexity, big O of 1. We don't need to calculate anything additionally, because overall the input is quite small and we can simply do it constantly. And also the space complexity would be big O of 1, because we are not using any additional space. We are just using a couple of variables to store just few values. So this is a really ideal approach. And I know that a lot of people don't like to have manipulation, and they simply ignore it or they hate it. And most of the times companies don't tend to ask this kind of questions, but we are preparing for FAANG. We are not preparing for some random company. And if you want a dream job, why would you compromise? So I would just suggest that go over it. It might take you like 2-3 hours to go through all the bit manipulation questions and understand the concepts. But once you are done with that, you will have an extra edge in the interview. So I would highly recommend not to skip anything and not to put anything on the chance. I will, and now let's move on to the coding, and we are going to implement the solution. So if our intention is to just submit it for the sake of submitting it, and have it accepted by LeetCode, we can simply write one line of code. We can simply return A plus B, and apparently it works. Yeah, but this is not what we want. So we would be writing the complete solution that we would use in an actual interview. So first of all, we will create a while loop to see if the value of carry is actually 0 or not, and we are going to store the value of carry in the B element. So while B is not equal to 0, now we will create a variable to store the value of A XOR B. Let's name it temp. And now we will calculate carry as well. We will do A and B and shift it to one place left. Shift it to one bit on the left side. And now we simply store the value of temp in A. So A becomes our temp. And as mentioned earlier, we will store the carry in B. And yeah, that's pretty much it. Once this loop runs, our solution should be stored in A. So let's return A. Let's try to run our code. Looks like our solution is working. Let's try submitting it. And yeah, our solution works pretty neatly. It's apparently 100% faster than all other solutions, but actually this is not true. All other solutions are also 100% faster because the runtime is in constant time. So hope you liked the video, and let me know in the comments if you want me to update anything in the video. Our aim is to clear FAANG interviews. I'm making these videos so I can practice for myself, and also I can spread the knowledge I have gained to other like-minded people. And yeah, see you soon.
So the lead code problem we are going to solve now is called reverse integer. Now this one is an extremely popular lead code problem and also a medium one. Basically we are given a signed 32-bit integer x, and we need to return x with its digits reverse. So basically let's say that if the given x value is 1 2 3, then we need to return x is equal to 3 2 1. Same way, if we are given a negative number, let's say x is equal to minus 4 3 5, then once again we need to return as minus, then 5 3 4, and so on and so forth. So this is the basically the whole problem statement. Now we are also given some condition where the given number should not exceed the maximum range of a 32-bit integer. If that is the case, then we need to return 0. So let's try to understand that what is going to be the most common logic to solve this problem. Let's say that I tell you that we are given values 1 2 and 3, and I ask you to reverse it. Logically, as a human, what you are going to do, you will first go to this number, you will find the very last number, and you would put that very last number into the front of this new x that we are trying to create, and then eliminate this number from your site, and once again repeat the same process and repeat the same process for all the remaining numbers. So basically 3 would come over here, 2 would come over here, and 1 would come over here, and this would be our answer that we are going to return. This is exactly what we are going to do to solve this problem as well. Basically all we need to do is just do the modulo by 10 operation for this given x value, and at every instance we are going to do the operation that x is going to be x divided by 10, and we are treating x as an integer value. So this division by 10 would basically yield that we are eliminating the very last element every given moment. So let's see that what is the solution I'm proposing. If the given x is equal to 437, suppose like this, okay, then first of all on this given x we are going to do x modulo by 10 operation. So we are dividing it by 10 and finding the remainder. So remainder in this case is going to be 7. So first of all in our new x we are going to add 7 as the very first value. So basically how we can add this value, basically we will just do like 10 to the power 0 and 10 to the power 1 and so on and so forth. This is how you add digits, and multiply by current value we have and add it to the existing value. So it's very common. Typically we do it with a small operation that we will see in the code. So we would take this value in and we would put it over here. After that we are going to run this operation x is equal to x divided by 10. So that would eliminate this 7 from this existing number. So after this once again we are going to repeat the same operation. Now this time the remainder number is going to be 3. So once again we would append 3 over here and then remove 3 from this existing number, and lastly we will have 4. So we will add 4 over here, and once we have no characters left inside the x, or the given value of x is less than 10, basically we will just add that value and then get out of the loop. Also at the same time we will have to understand that at every given instance while adding or building this number, are we going out of the bounds for the given integer value of the 32-bit number. So for that the only thing we can do is we can just compare whenever we build a new entry for x, and if that entry exceeds the existing limit for the integer or 32-bit signed number, then we will just simply return 0 in this case. So this is the whole solution, and typically this solution would work in the total number of given numbers. So basically let's say that we are currently given 5 numbers, so 1 2 3 4 5, then the time complexity is going to be big O of 5, because we will have to do it for every single character by character. So this is actually going to be big O of logarithmic of x value, where x is going to be the type of system that we use to represent the numbers. Now since we are using 1 to 10 numbers, so this is going to be a decimal system. So simply we can say that this is going to be logarithm of x for the total number of given characters. But overall this is a very simple straightforward solution. And now let's quickly see the coding solution. So first of all, we are going to initialize a new variable called reverse, there where we are going to store the answer, and then we are going to run our loop that while the given x is not equal to 0, we will first extract the last digit, and that is by doing the modulo operation, and then we would simply divide the current number of x by 10, and because it's an integer, so we would just remove the very last character. Now we simply need to check the overflow condition before we start updating the reverse functionality. So we are only checking that if this given reverse value is already greater than the integer by max value by 10, or if that is not the case and if the pop is greater than this value, then we can simply return 0. Otherwise we also need to check for underflow case the same operation in the reverse order, that if we are going out of bounds in the minimum value case. If either of this is the case, we can return 0. If that is not the case, we simply add that value and update the existing reverse number by multiplying the current reverse number with 10 plus adding the pop value or the last value we added, and we can simply return the reverse value. So let's try to run the scenario. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully, beats nearly 82% of all the other solutions, which is pretty good. So once again, the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, counting bits, which in my opinion should be a lead code medium problem. Let's understand the problem statement. So basically we are given an integer n as input, and we need to return an array such that it defines that for every single value from the range of 0 all the way to whatever given n is, how many times the value 1 is repeated in its binary formation. So let's try to understand this with an example. Suppose our given input is 3. So the range from 0 to n would be 0, 1, 2, 3. And if we represent these values in binary, the representation would look like 0, 0, 1, 1, 0, 1, 1. And we need to return an answer array such which is of n plus 1 size, such that it represents that for every single value from 0 to n, how many times this bit 1 is being repeated. So now for the 0th position, we don't have any ones, so we enter the value 0. For the first position, we have one bit, so we enter as 1. Same goes for the second value, so we again add 1. And for the third value, we have two ones, so in the answer, we provide as 2. And this would be our array that we would return as our answer. So let's see what are the different approaches we can take. So the first approach we can take over here is of one of the previous lead code questions that we have already solved, a number of 1 bits. And let me give you an overview of the solution we had achieved previously. So if we are given any number n is equal to 5, and if we represent it in binary, it becomes 101. And if we want to find that how many number of 1 exist in the given input, we would simply do an AND operation between the number and its one value lesser than the number of itself. So one value lesser over here would be 4, and if we represent it in binary, it becomes like this. And if we do an AND operation between these two values, the answer we get is 0, 0, 1. And this would be our first iteration. Now we would repeat the same process. So now again the number we found after doing this AND is 4, and we would do an AND operation with one value lesser than 4. So 3 would become 0, 1, 1. And if we do an AND operation between these two values, the answer we get is 0, 0, 0. And the moment we get 0 answer, we break out of the loop. And at the beginning of our loop, we would create a variable count, and only initially it would be set up to 0, and with every iteration we would increase the value of count. So during this iteration the value of count would become 1, and during this iteration the value of count would become 2, and at the end when we find that the number is actually 0, we would return whatever value of count we found as the number of ones that exist in our given input. So we found that in our given input 5, it has two number of ones. We can repeat the same formula for the given input, and let me show you how we can do it. Suppose the input we are given n is equal to 4. We need to create an array from 0 to 4, and we need to calculate that for every single value how many number of ones are present in that given input. So the answer array would be, we would need to provide that how many number of ones exist. So we can create a function called count1, and for and we can run a loop over all these values, and every single time we would pass on whatever the current value we are trying to find the count for. And whenever we run this function that uses this logic, the one that we just discussed, then we would be able to find that how many number of one exist for every single given element. And when we get the answer back, we can just simply fill in our array and return this as answer. This solution would work perfectly fine, and the time complexity for this solution would be n, because we will have to run a loop towards the entire towards all the given values. and for every single value we would have to run this operation, count the number of ones, and this loop runs for the time being of number of ones that exist in any given input. So over here for number 5 there exists two ones, so we will have to run the loop twice. Suppose if we are given any n is equal to like this, then the loop will run 6 times. So we can say that this solution basically works in the time complexity of big O of n times log n, because in order to find this count, because in order to find number of ones, we would have to run multiple loop, we will have to run multiple iterations in this count one solution. So this is in itself a pretty efficient solution, but we need to see that if we can find a better approach and can we have an optimal solution. We can have optimal solution, and let me show you how we can achieve that. Now, in order to find the optimal solution, first let's try to understand that how the logic actually works if we want to find the number of ones in any given element. So the operation we are doing is basically we take n and n minus 1, and then we do a counter plus plus. So we can represent it in a different manner. So first let's try to understand that suppose n is equal to 9. The actual calculation we are doing is n minus 1. We are doing an AND. So basically this means that after the AND operation we get the value as, and the value this comes up as 8, and we do an a plus 1. So keeping this in mind, and again if we do it for the value number 8, what we are actually going to do is we are going to, now our n is 8, so we will do n minus 1 as 7, and the answer is 0. So basically our n is 0 at this moment, and we again do plus 1 in our counter. So if we write this in other way, we can write it as that answer for the number 9 is actually whatever the answer we found for 9 and 8 plus 1. And if we go down one step further, the answer for actually this 9 and 8 is actually the answer for whatever the value of 8 we found plus 1. We can write this exact same formation as this. And if we try to calculate the value for this uh, a of 8, actually we can write it as a of 8 and 7 plus 1 for this particular value. And this actually becomes a of 0 plus 1. And we know that a of 0 is actually 0, plus 1 is 1, and this 1 is actually the value of a of 8. Now, if we replace this a of 8 over here, we can say that the a of 9 is actually a of 9 and 8 plus 1, and we know that the value of a of 9 and 8 is actually a of 8 plus 1, and we know that the value of a of 8 is actually this 1. So we can say 1 plus 1, and we can come to the conclusion that the number of ones present in value number 9 is actually 2, and which is what we are given over here, and which is what we know. And basically what we have done is we have taken this input for any single individual element, and we have actually computed the results, we have actually stored the results, and based on those results we are able to find the future values. And basically we are applying dynamic programming. We can simply calculate the solution for our entire array in just big O of n time. Let's take another example to make things more clear. Suppose our given input is equal to 6. So if we want to find the answer for 6, using the logic we found over here, we can consider this as answer for whatever we find for 6 and 5 plus 1, and the answer for 6 and 5 is actually this equals to 4. So we can write this as answer for whatever the value of 4 we got plus 1, because this turns out to be 4. And subsequently, if we calculate the value for 4, we can break it down further as, so we can write this as answer for 4 and 3 plus 1 for this portion and plus 1 for this one. The answer for 4 and 3 is actually n is equal to 0. So we get answer of 0 plus 1 plus 1. This would be our final answer for our answer for value number 6. So see over here that we have, when we get to value number 6, we would have already calculated all the values from 0 to 5. And since we have the answer for from 0 to 5, we will use those answers to quickly determine the answer for value number 6. And this logic enables us to get our solution in just single iteration, and this would be a better time complexity than our previously suggested algorithm. And in terms of space complexity, anyways, we have to create an answer array in order to return it as a part of the answer, because it is given as requirement uh, for the given input, that we are not using any additional space, and we can just use the same array to represent the answer and also use it as our dynamic programming solution. So space complexity would also be a big O of 1. And this is a really ideal approach. And let's move on towards the coding. So first of all, we will create an answer array, and we would give it the size of n plus 1. And now we initialize the answer array of 0th value to 0. And now we just need to run a for loop. We'll start the loop from I is equal to 1, because we already calculated the value for 0. And we will run it while I is less than or equal to n. And we just have to write one line of solution, that if our answer of current I is actually equal to answer of I and I minus 1, and whatever the result of this is, we just add 1 to it. And yeah, basically after the loop we should have our answer array completely filled up, and we can simply return it. So let's try to run our code. Oh, we forgot to initialize the value. Yeah, looks like our solution is working. Let's submit this. Our submission works pretty fast compared to a lot of other submissions, and as we can see that this is just a couple of lines of code that is really doing the trick. So though this is really simple to see, but in order to come up to this answer requires very strong knowledge of dynamic programming. Hope you like the explanation and the videos. Let me know if you want me to do anything else with the videos, or provide me any suggestions on how can I improve.
So this is my final message to all of you. Thank you so much for sticking around and staying until the very end of the video. I know it's not very easy or quite straightforward. It's a boring topic and it has a lot of complexities associated with it. But I appreciate you on your commitment and your perseverance throughout this entire course. Now, this is not the end of the story. Keep doing your part, keep practicing. This will definitely change your life if you can crack some awesome interviews and find a better job. And feel free to please support my channel as well, Destination FAANG. I don't know how many hours it took me to make this video, and it's been an incredible journey so far. What started as a passion project for me to learn myself has evolved into something beautiful, and that has been helping people all across world. Now, we live in very uncertain times. There are wars going, there are people dying, there are uncertain governments, and bunch of things that has been unprecedented happening in the world. We don't know what tomorrow feels like, so I just have one urge to each one of you. If you can, help someone out in need. It can be your friend, it can be some person you see on the street, it can be someone maybe thousands of kilometers away from you. No matter what, try to make this world a better place. Let's help each other out. That is the only way we grow. So please, you do your part, I'll be doing my part, and let's make this world a beautiful place. Also, best of luck in your journey, and I hope you crack all the interviews you can and go as further ahead in your career as possible. So till then, take care.